In this chapter, we are going to look at a few memory management tools at our disposal in the Qt framework and from the C++ programming language. We will see that we have three ways to manage memory. You can use the new operator and the delete operator, which is a really low-level way to do things, and it's not recommended to use this at a high level in C++ projects, in modern C++, I should say. We also have smart pointers, which were introduced in modern C++, and we will see how we can use this to our advantage in memory management. And after that, we will look at the Qt parent-child relationship, which is a Qt-specific way to manage memory, and it is going to be really cool, as you are about to see. Let's head over to the next lecture and do this. In this lecture, we're going to look at the differences between the heap and the stack. And we are going to see how you can allocate memory for your object either on the heap or the stack, and we will see the differences. The main difference I want to highlight is that if you are using heap memory, you need to have a strategy for releasing that memory and give it back to the computer so that it can be used to do other things. Otherwise, your application is going to keep eating up memory, and at some point, it's going to be killed by the operating system. You don't want that. So there are two main pieces of memory your application is going to be using, the stack or the heap. And some of you are going to start asking, what is the difference between the stack and the heap? Well, the difference is in how memory is managed. And what I mean by that is how memory is allocated to your application and how memory is given back to the operating system when your application is done using the memory. We're going to look at a few examples in a minute, but just know that there are two pieces of memory your application is going to be using. Okay, to understand the stack, let's look at a simple example here. Here we have a simple function called doStuff. And it's really not doing anything special. Inside the function, we are just allocating for an object of our class called house, and we are calling a method on that class. That's what we are doing here. And you can ignore the code here. You can think that it's not here. We're going to use this in a minute. I just want to highlight the differences between the stack and the heap. Now, if we call this function, for example, in the main function, it is going to be activated and it is going to be pushed to the top of the stack. Once it is to the top of the stack, the house object here is going to be allocated on the stack. When this function is activated, we are going to call this method, and when the function finishes execution, this object that was allocated on the stack is going to die off. It's going to die when the function finishes execution, and this is a key point you need to remember. Objects allocated on the stack are killed, and the memory they were using is returned to the operating system when the scope or the function, in this case, where they were living, finishes execution. This is a key point you need to remember. Okay, if we go in the main function and call this function, it's going to be activated, it's going to allocate for the object, it's going to call the method, then the function is going to finish execution. Before the function goes away, it's going to kill everything that was allocated on the stack in that function call. You need to remember that. Okay, so this is what is going to happen. We are going to try and visualize this. The object is going to be allocated on the stack, and when the function finishes execution, it's going to be killed off, and the memory it was using is going to be returned to the operating system. This is what is happening here. Okay, now let's talk about the heap. We have talked about the stack. Let's talk about the heap. To use memory on the heap, one raw way we have to do this in C++ is to use the new operator. So we use a syntax like this. We're going to say new house, and we're going to pass parameters to the constructor, and then the new operator, once it's done creating the object, it's going to give us a pointer that we can use to manipulate the object. This is how the new operator works in C++. We can then use this pointer to call stuff or to call methods on the object, and when you go through a pointer, you use this pointer access operator you see here. And another thing you need to remember with the new operator is that you have to actively release the memory. Again, you have to actively release the memory through the delete operator when the object you are using was allocated for through the new operator. And the new operator is going to be using memory on the heap. Let's visualize this a little bit. Again, the function is going to be called in the main file or the main function. And what's going to happen, the object is going to be allocated for on the heap. This is the yellow thing you see right here. After that, the new operator is going to give us a pointer that is going to be pointing to this memory here. Let's suppose we are not using the delete operator to release the memory when we are about to exit the function. When we don't do that, our function is going to finish execution. The pointer that was pointing to that memory is going to be released because this pointer itself is living on the stack. Then our function is going to finish execution and the object will stay on the heap. If we keep calling this function multiple times, we will be leaving a lot of objects on the heap. And we say that we are leaking this memory here. If your application keeps doing this, it is going to run out of heap memory and the operating system is eventually going to kill your application. You don't want to do this. Again, if you are using heap memory, you need to remember to release your memory with the delete operator when you are no longer using it. Another way to say this is that if you use the new operator here, you are in full control of your memory. And the operating system or C++ is going to give you the responsibility to release the memory when you see fit. So be responsible, release memory that you allocate for through the new operator. Okay, so this is the point I am trying to make here. Be responsible, be a responsible C++ developer. Now, if you do things correctly on the heap, you can allocate on the heap with the new operator. The new operator is going to return a pointer that you can use to manipulate things on the heap. The pointer is going to be pointing on the heap, and when you are about to get out of the function, you are going to use the delete operator. The delete operator is going to release memory on the heap, so we're going to clean things up. We're going to be left with our pointer on the stack, and when the function goes away, the pointer is going to be killed, and we will be clean after our application has done its things. This is the flow we should use to do things if you are using memory on the heap through the new operator. Okay, now let's see how we can set up the house object so that we can play with it in Qt Creator. It's really nothing complicated. The only thing is that we are stealing things from the QObject class, which is built into the Qt framework. We are doing this because there are a few things we're going to see in the next lecture or the next few lectures. But for now, think that the house class is building on top of QObject, and we're going to be putting in a few of our things. We're going to be setting up a QString object. QString is a class that represents strings in Qt, and it has a few things that you don't find in the std string class from standard C++. Here we have a constructor. Don't worry about the explicit thing here. You can ignore it. And we're going to pass two parameters. We're going to pass a parent. This is a Qt thing, and we're going to learn about this in a minute when we hit the next lecture, I think. And we have our description here. We also have another function I don't think we have talked about with a tilde character here. This is a destructor, and it is what is executed when your object is about to die. We will see this in a minute. We also have a printful function, which is going to print information about our house here. This is the definition of the class, and we have implementations for the methods here. You see the implementation for the constructor. We are using an initializer list to forward the data from these parameters to our members. Here we are calling the base class constructor to initialize the QObject part of us, and we are using mdesker here to initialize the description string. We also have a destructor here, which is going to qdebug output a simple message to let us know that the object is dying. And we have the printful function, which is going to print the description here. Nothing special really. Okay, now that we have this, I think it is big time we headed over to Qt Creator and I did these things here. Here we are in Qt Creator. We are going to create a project. It's going to be a Qt application, but this time we are going to create a console application, which is a Qt application. In other words, this is going to have access to Qt classes so that we can use them. Things like QString and QObject, we want access to them. That's why we are creating a Qt console application here. Let's do this. We are going to give it a name. We are going to put it somewhere on our drive. I think we can go in 3 here. And I am going to use this as my default location for my chapter here. You can do whatever you want at this point. And we are going to be using CMake, using the MinGW kit the usual thing really. We don't want get, and we are going to finish. And the first thing I am going to do is to create my house class. In Qt Creator, you can do new. You can right click on the project name here, do add new. We are going to add a C++ class. We're going to choose. We are going to give it a name. We're going to say house. That's going to be the thing. And we are going to inherit or specify our base class as QObject here. We can leave the rest as it is. We're going to include the QObject, and we are going to add a QObject macro to our class. Once you have everything like I have here, you're going to hit next. And we don't want to get. If you want, you can use get, but for now, we're not going to use it. And we are going to finish up here. Again, we are going to get the trusty QMake warning here. This class is not going to be automatically added to our target, but we're going to copy this to the clipboard. And now that we have that to the clipboard, we're going to go to the add executable command and add that. I am just going to hit Ctrl V or paste that in here. And you see that we have added house.h and house.cpp. They are not going to show up yet. For them to show up, you have to come to build and run CMake again. And now they are going to show up, and they are part of our class here. Now, the class is really what we have seen in the slides. It inherits QObject. It has a constructor here. And we can right click and switch header source to see the implementation of the constructor. Nothing really special. But we can put in our private section. You can remove the signals thing here. We don't need it. We're going to add a private section, and we are going to put in a QString called mdesc for description, if I can pronounce that. And this is really it. Okay, so once we have this, we are also going to put in a printful function, which is public. So print info, and it's a const method. We should make it const because it's really not going to modify our object. And we are going to take another parameter. Let's say QString desk for description. We should really make this a reference so that we avoid unnecessary copies. Const QString reference. I think we can do something like this. We can put in an empty string as the empty initializer. So what we're going to do, we're going to take out the implementation given to us by Qt Creator. And what we're going to do, we're going to go to the header file, and we will tell Qt Creator to generate implementations for these things and put them in the CPP file. This is something that is going to save you a few seconds, and it's going to help you with syntax. If, for example, you don't remember how to write an implementation for a method like this. But that's not an excuse to not know how to do things. It's just that Qt Creator is going to help us do things a little faster. So we are going to right click on the method name, the constructor here. We are going to do refactor, and we are going to do add definition in house.cpp. If we do that and we go in the CPP file, we're going to have a constructor here generated. We can do that for printful, and we're going to do refactor, and we are going to do add definition in house CPP, and we will have an implementation here. Now, what we can do with this, we can decide how to forward the data in our object. We can either go in the body and assign things, but it is a really good idea to use initializer list in the constructor here. So what I am going to do, I am going to go to the next line and put in a constructor, an initializer list. The first thing I am going to do, now what we're going to do is to go down and say QObject, and we are going to forward the parent to our parent class. This is something you can do. Again, if you are rusty on this, I would recommend checking out a C++ specific piece of documentation, either a book or a video or whatever you find on the internet. We are going to initialize our member variable, and we are going to pass in DESCR, and this is going to be our constructor here. We can go in the body and put in a simple message saying that we have constructed a house and we need QDebug for this. So let's say QDebug. And in our information printing function, we are going to just QDebug house and print out the description that was passed when we built this house object here. This is going to make things a little easy. One thing we don't have that we want is a destructor, and a destructor is something that looks like this. We have a tilde character. we have the class name, and this is going to be it. This is going to be our destructor, and it is called when the object dies. We can put in an implementation for this as well. So we're going to right click on this. We're going to refactor, add the definition in house CPP, and we can say QDebug, and we're going to say house object. We can put the description for the house, and we can say is dying to kind of know what is happening here. Now I think our house class is ready. We can go in the main CPP file and include it. And we are also going to include QDebug here. And we are going to go down and set up our do stuff function that we really did in the slides. Let's comment out the heap stuff here. I just want to show you how stack memory works before we use heap memory. The do stuff function is going to allocate for a house object on the stack. This is a stack object, and we are going to call something on it. And when the function exits, the object is going to die, and we will see the structure called. This is what I want you to see here. So we can go in our main function and call do stuff, and we're going to call the function, and we can QDebug. We can say done here, just to know that we have hit the end of our main function here, and we will see what happens. Let's run the application, but before we do, I think we can go to projects and go to run configurations and run in terminal. This is what we want. We are going to build by hitting the hammer button. We're going to look at compiler output here. CMake is doing its thing. The build is good. We have no compiler errors, but I want you to see what happens when we run. It's going to say house object constructed, and what is really happening here. Let's go to the main function and really try to understand. We are running the main function, and we are running the do stuff function here. When we run do stuff, we are hitting the body of the function. We are going to hit the line here that sets up the object. We are going to call the constructor. We are going to say that we have constructed an object. That's what we see here. After that, we are going to call the printful function, and we are going to print information on the house. That's what we see here, house first. And we are going to hit the end of the function, and the object is going to die. Then we are going to come back in the main function here and say done. This is something I want you to see, and you should really take some time to understand the flow of how these things happen if this is the first time you do these kinds of things. So this is really how stack objects work. They die off the moment the scope or the block where they were set up is exited. The house object here was set up in the block of this function. When we exit this block, everything on the stack is going to be killed off, and its destructor is going to be called. This is what I want you to see. Now that we have seen this, let's look at the heap. Okay, so let's uncomment our code for the heap here. And we are going to do the same thing, but before we go, we are not going to delete or release the memory. Remember, you have to release the memory through the delete operator. The rest is going to be the same, and we are going to run again. So it's going to build. Once it's done building, we're going to see things popping up here. But see the difference. We are constructing the object, but we are constructing the object. You see the message here. We are calling something on the object just like we are doing here, and we are going to print the information. But notice that we are coming back to the main function and printing done without having destroyed the object. And try to imagine if you are calling do stuff maybe 1,000 times, and the house object is a really big object. You're going to be leaving all those pieces of memory, and the operating system is going to keep thinking they belong to your application is using them somehow, but other parts of the operating system are not going to be able to use that memory. This is called memory leaking, and it is a bad thing. You should remember to release the memory you allocate for using the new operator here. So to solve this problem, you have to remember to call the delete operator. It is really simple, but it's very easy to forget to do something like this. And in some cases, it's really not as obvious as it is here. So let's run with the delete operator, and you're going to see that now we are going to release the memory before we exit the function. You see the object is dying because we explicitly released memory here. And this is really what I wanted you to see, the differences between stack objects and heap objects. Now, manually releasing memory has been a big point. People against C++ used to say, it's a bad language, it's really unsafe, you can forget to release your memory, bad things can happen if you use C++. And the C++ community has built a lot of ways you can release memory without explicitly doing things like this. One of those ways is to use smart pointers. I am going to show you how to do that in a minute. But we are also going to see a Qt specific way to solve these kinds of problems. This is all I had to share in this lecture. I hope you found it interesting. We are going to stop here in this one, and I will see you in the next one. In this lecture, we're going to learn about smart pointers and see how they help in the quest to make memory management easy when heap memory is involved. In the lecture on heap and stack memory, we had a chance to look at how you can use stack memory and how you can use heap memory. And there was a problem with heap memory in that you had to always remember to call the delete operator on your heap object before the function exits. If you don't, you're going to leak memory, and that's a problem. We saw that you could remember to delete the memory explicitly, but sometimes this is not going to help out, and we are going to see a simple example here. So once you have the do stuff function, you can call it, and if you are using the stack, things are going to be cleaned up. If you are using the heap, you need to explicitly release the memory. Again, to visualize the problem with heap, if you use the new operator, the object is going to be allocated for the heap. You are going to get a pointer pointing to the object. And when the function exits or the function goes out of scope, the pointer is going to be killed, but the memory on the heap is going to stay. And if you keep calling the same function multiple times, you're going to be adding up to the heap memory that you are not cleaning up. And this is a bad idea. We saw that to solve this, you need to actively release the memory from the free store using the delete operator. And if you do that, you will have a situation like this. The object is going to be allocated for the heap. You are going to get a pointer pointing to the object. And when you are about to go out of the function, you are going to call the delete operator. The thing on the heap is going to go away. Then the function is going to exit and the pointer itself is going to go away and everything is going to be clean. But to be able to do that, every call to the new operator somehow has to match up with the call to the delete operator. And what is going to happen is something like this. The new operator here is going to match up to this delete operator. This new operator is going to match up to this delete operator. And this new operator is going to match up to this delete operator. And you might be saying, if I remember to match up things exactly this way, I am not going to have memory management problems. Well, you can't be more wrong. Suppose we have a function like this. Again, do stuff, we allocate for our stuff, and in the printful function, somehow an exception is thrown. Now, some of you might not know about exceptions, but it is a thing that is thrown when something goes wrong in your application. And the thing that is really important to know about exceptions is that if an exception is thrown, the function where the exception is thrown is immediately killed. In other words, we are going to immediately get out of the function and we want to have a chance to run the delete statement here. And we are going to leak memory even if we remembered to put this delete operator here. I realize exceptions can be confusing if you don't know about them. If you are interested, you can check documentation about them. But please know that it's not always safe to match up things this way with new and delete. And that's why smart pointers were created, to try and make memory management easier and safer. The main point about smart pointers is that once you allocate for memory on the heap, you are going to get an object. And when that object dies, the memory on the heap is going to be cleaned up. Let's look at a simple example here. Suppose we have the same structure we had before. We are going to allocate for memory on the heap, but this time we are going to get a smart pointer pointing to that memory. And in this case, it is a unique pointer. There are many kinds of smart pointers in C++, and we're going to look at a few of them. but just know that it is a kind of pointer that is going to give you an object. But when this object goes out of scope, it is going to release this memory automatically. And as a bonus, this is even going to work if exceptions are thrown, and our code is going to be much safer with smart pointers. So when we are about to get out of the function, the smart pointer is going to die, but it's also going to release the memory and everything is going to be clean. In C++, we have three kinds of smart pointers. We have unique pointers, we have shared pointers, and we have weak pointers. Unique pointers are designed to be pointing to a single memory location. Or in other words, you can't have more than one unique pointers pointing to the same memory location. That's the design for unique pointers. Shared pointers are designed to have multiple pointers pointing to the same object. And again, I won't go into too much about unique and shared pointers. If you want, you can check a C++ specific piece of documentation. We also have weak pointers, but I'm not really going to talk about them here. And in this lecture, we are going to play with unique and shared pointers. Let's look at our doStuff function when it is using smart pointers. Here we have an example that is going to be using unique pointers. So we are going to set up a unique pointer object. It's going to be pointing to our house object. And the object name is going to be uphouse1 for unique pointer house1. And we are going to allocate for the object here. This is just one way to set up unique pointers and smart pointers. There are many ways, but I just want to show you the design idea behind them to make memory management easy. We can also use shared pointers in the same way. So we're going to say std shared ptr. It's going to be pointing to house within these angle brackets. This is the object name, and we are going to allocate for memory on the heap. And the thing is, when this function goes away, this object is going to die, but it is also going to automatically release space on the heap, and everything is going to be clean. To play with this in Qt Creator, we are still going to be using our house class here. So this is what we used in the last lecture, nothing really special. And here is the implementation. Now that you know this, we're going to head over to Qt Creator and see this in action. Okay, here we are in Qt Creator. We are going to create our project. It's going to be a Qt application, a console1. We're going to choose. We're going to give it a name, Smart Pointers, and store it somewhere on our drive. We are going to be using CMake as the build system, and we don't want to use the MSVC kit. You can use it if you want, but we are going to use MinGW. No big deal here. We don't want to get, and we are going to finish. This is going to create a project. Let's wait for this to finish. We have our CMake list.txt file. Now, what we are going to do is to bring in the house class we did in the last lecture. And what I am going to do is right click on the project in the last lecture. I am going to right click and show this in Explorer. And what this is going to do is to bring this. And I am going to copy the house class. And I am going to close out of this. I am going to go where the current project is stored. So let's do the same. We are going to right click on main.cpp, right click and show in Explorer. This is going to open up, and I am going to paste in these files. Okay, the files are here. Now I can close out of this and go to my CMake list.txt file. Let's crack it open and make sure we are in the right one. And we're going to go down in the add executable command, say house.h and house.cpp to make sure these things are picked up by CMake when it is building our project here. We can go to build and run CMake, but I also think you can go to the project, right click on the project here and run CMake. I think it's going to do the same. We're going to have our header file, and we will have our main CPP file and our house CPP file, I mean here. And this is what we did in the last lecture. We can hop over in the main CPP file and include a few things we need. So we can include QDebug, I think, and we can bring in the house class, and we will set up our doStuff function with a bunch of things. Okay, let's make sure this is commented out. Again, if you don't want to type this, you can look at the source code given with the course I am going to share the GitHub repository for this, and you will have access to the code here. You can copy and paste if you don't want to type all this. So now we have our do stuff function. We can use it to do things on the stack. This is what we did in the last lecture, and this is going to release the memory. Actually, let's try this. To do things in steps, and we are going to head over in the main function and put a piece of code like this. We are going to put a message saying starting and ending, and between these two messages we're going to call our do stuff function here. So what we expect to see printed out is starting. We are going to go in the function, set up the object. We are going to call the constructor. We are going to printful. When we get out of the function here, we are going to release the memory because this is a stack object. Then we are going to print ending here. Let's go to projects and make sure we run this in the terminal. And we are going to run. And sure, this is what we expect here. Starting, we're going to construct the object. We're going to printful. We're going to release the memory. And we are going to end. Okay, this is the stack. Let's see what happens if we use the heap. We can use the heap here and forget to release memory on purpose. Just like we did in the last lecture, I just want you to practice this a little more. So what's going to happen? We are going to go in the function. We are going to create the object. The constructor is going to be called. We are going to printful, and we are going to get out of the function without releasing this memory here. And we want to see a message saying that the object is dying, and it is what we have right here. This is bad. You need to remember to release your memory. That's going to improve chances that your application works well. If we do this, we're going to see the object is going to die. But this is not guaranteed to always work because the printful function may be throwing an exception. And if it does, we are going to directly get out of the function and we won't have a chance to release this memory here, and that's a bad thing. So heap memory with the new operator and the delete operator, it's not guaranteed to really make things safe for you. What we can do, we can use smart pointers to make things easy. And I think to be able to use smart pointers, you need to include the memory header from standard C++. So let's include that. And this is the syntax to set up a smart pointer. We are using unique pointers in this case. You say std unique pointer, you specify what the pointer is going to be pointing to, and you allocate for your memory, just like we did before. But now the memory is going to be managed by this smart pointer here. And when the smart pointer goes out of scope, and it will go out of scope when we get out of this function here, the smart pointer is going to be killed, but it will also take with it the memory we allocated for on the heap. And this is going to be really cool. Notice that we are using the new operator and we don't have a delete operator anywhere, but you will see that the destructor for the object is going to be called, meaning that the object was destroyed on the heap. And this is really cool and powerful. Let's run this and we will see what we expect. We see that after we see that when we get out of the function, the smart pointer is going to die, but it is also going to die with the object here. And this is really cool. This is what I want you to see. We can achieve the same using shared pointers. And I want you to see an example for this. Let's do this. And if we run, we will see the same output. Okay, we're going to build the object. We are going to printful. And when we get out of the function, the smart pointer is going to die, but it is going to go with memory on the heap, and that's going to destroy the object, and we will end as we do in the main function here. This is really all I wanted you to see in this lecture, how you can use smart pointers to manage memory. But in the next lecture, I am going to show you that you can also use the Qt parent-child relationship to make things easy, and you need to be aware of that relationship, because that's the reason why you see many Qt classes taking the parents. That's for memory management reasons. And we are going to learn all about that in the next lecture. So we are going to stop here and I will see you in the next lecture. In this lecture, we're going to learn about the Qt parent-child relationship. And this is a Qt specific way to deal with memory management issues. In the last few lectures, we saw that we could directly use the new and delete operator to manage memory. In a lecture after that, we saw that we could use smart pointers, and Qt provides a Qt specific way, and which one you use is going to be your choice as the developer. In this lecture, we're going to explore the Qt parent-child relationship. But before we do that, please remember that you can do things on the stack, you can do things on the heap with the new and delete operator. But when you use the new and delete operator, you need to actively release memory from the heap or the free store. The heap is also sometimes called the free store. Smart pointers make things easy because when the pointer object dies, it is going to die with the memory on the heap, and the destructor for your object on the heap is going to be automatically called. But in this lecture, we're going to learn about the Qt parent-child relationship. So how does it work? Well, when you create your objects, you can set up a hierarchy like this. You can have a parent object. This parent object can have children, and we have child 1 and child 2. Each of these children can have its own children. For example, child 2 has grandchild 2, 1. You can set up a hierarchy like this. And the good thing with this is that now you don't have to manage all these objects here. The only thing you need to care about is the parent object. And when it dies, it is going to make sure that it kills all its children, and you are going to automatically release memory for all these children. And you can take advantage of this in your Qt application. One requirement to be able to use the Qt parent-child relationship is for your classes to be inheriting Q object. And this is the reason why we made our house object inherit Q object in the previous lectures. Now, how can this parent-child relationship be useful? Suppose we have a window, and in this window we have a bunch of buttons. For example, we have button 1 and button 2. We have some text edit. We have a lot of things. We can parent all these little components to the parent window. So we can say this thing is a child of the parent window. This thing is a child of the parent window. This thing is a child of the parent window. This thing is a child of the parent window. And we don't have to manage the memory of all these things. We are just going to manage the memory of the parent window. And when we kill it, everything under it is going to die. We can come back to Qt Creator to show you an example. If we go to Tools and Options, I think we're going to have a window pop up. And we have a bunch of things in this window here. For example, we have these buttons. We have these text or these lists of things. And all these things may be parented to the parent window here. Okay, these buttons may be parented to this window. All these little buttons may be parented to this window. And when we kill the parent window, everything here is going to be automatically released. And this is really cool. This is something you see used a lot in Qt, and I want you to be aware of it. Okay, to play with this, we are still going to be using our house class. It's not going to be very different. Nothing different really. Here is the implementation, but our do stuff function is going to be a bit different. We are going to set up a bunch of objects. We're going to set up parent. Okay, it's a house object. We are allocating for this on the heap. So the moment you see the new operator, you should know that you should do something to release the memory. We're going to set up another house object, house 1, and we're going to say the parent of this object is the parent object here. Okay, this is what we are doing. We are passing pparent as the parent object for phouse1. We can set up phouse2 and say that its parent is phouse1. You see what we are doing here? We are creating an inheritance hierarchy, but the only thing we are releasing really is the parent here. So if we delete this parent, it is going to delete all its children. So it's going to look at the list of its children. It's going to find house 1. It's going to try and kill it. But before the guy dies, it's going to look at its children, and it's going to find phouse2 as its child, and it's going to kill it. And everything is going to be cleanly released using the Qt parent-child relationship. Let's head over to Qt Creator and play with us a little more. Here we are in Qt Creator. We are going to create our project. It's going to be a console application. We are going to give it a name, and we're going to store it somewhere on our drive. We can hit next, choose CMake as the build system. We are going to hit next again. We are going to use the MinGW kit. We don't want to get, and we want to finish here. This is going to create our project. And we want to steal the house class from the last lecture again. We can go there because I have the project open here. If you don't have it open, you can open it or go wherever it is on your drive. You can use whatever method you want. I am just going to show in Explorer. And this is going to pop up here. I am going to copy the house class, the header and the CPP file. And I am going to come back to my current project and do the same, show in Explorer. And it's going to open up here. And I am going to paste in my house class header and CPP files, I should say. And now you should be getting a hang of this. We need to go to the CMake list.txt file and bring in house.h and house.cpp. And after we do that, we can run CMake on the project. We're going to say run CMake, and our files are going to show up here. We have the house class, nothing special really. It's everything we've done in the last few lectures, and we have the CPP file here with the implementations. Now, we can go in the main CPP file and put in our do stuff function with the correct includes. You need QDebug, memory, and house included here. And this is what we saw in the slides. We have a parent object. It's going to have a bunch of children. So we have phouse1 as the child of the parent. We have phouse2 as the child of phouse1 here. This is the hierarchy we have, and we are only releasing the parent object. And when we do that, you're going to see the destructors for parent, house1, and house2 called. This is what we want here. Okay, let's head over in the main CPP file and call our function. We're going to debug output starting and debug output ending. And between these two lines, we are going to call our do stuff function. Before we build, let's go to projects and look at the run configurations and run in terminal. And we can build the project and see the compiler output here and see what's going on behind the scenes. The build is good. Now we can run, and we're going to see something interesting happen here. We're going to run the starting message here. That's what we see printed out. Then we're going to see house object constructed, house object constructed, house object constructed here. And we are constructing 3 house objects, so this is nothing interesting or surprising. This is going to be our first house, the second house, and the third house. That's why we see these constructors called here. Now, when it comes to releasing the memory, notice that we are only releasing the parent object, but see that the first thing to die is going to be parent. Okay, so the parent destructor is going to be called. Then it's going to release the memory for its children. It's going to look at the list of the children it has. It's going to find phouse1. And it's going to kill that. But before house 1 dies, it's going to see that it also needs to clean up its children. It's going to find that it has phouse2 as the child, and it is going to kill that. And we're going to see the destructor here called. When all the destruction is done, we're going to hit back the main function, and we are going to print ending here. And it is what we see last year. I really want you to see this. One thing you can try is to also parent phouse2 to pparent. You can do that. You can really play with this and see how things work out. So now all these 2 children are parented to the same root parent here. And if we run, we're going to see how things are destroyed. Let's run this. Again, we should see the construction of 3 houses. And we're going to see parent 1 is going to die, house 1 is going to die, house 2 is going to die. You can wire these things up depending on the logic of your application. Before I close off this lecture, let's see that you can also use smart pointers to manage the parent object. You don't really have to use the delete operator if you don't want that. So we can comment out this little guy here, and we can say pparent is going to be a unique pointer. We can do something like this. But the moment you do that, notice that you can't directly pass a unique pointer or a smart pointer as a parent. The thing is, smart pointers have a way to get to the row pointer that they are managing. So a hack we could do here to get things to work is to call the get method on the pointer. Okay, this is going to give us a row pointer to a house object, and it is what we're going to be using to manage things here. But notice that we are not actively releasing the memory with the delete operator. But if we run, we're going to see that the same thing is going to happen. We're going to destroy our objects, because when the smart pointer object goes out of scope, it is going to release its memory, and it is going to start by killing the house pointer, but it is going to see that it has a few children, and it is going to release all these children here, and we are going to get out of the function. Now you have three ways you can manage memory in your C++ programs using Qt. You can use the new and delete operator. You can use smart pointers like we have seen in the chapter here, but you can also take advantage of the parent-child relationship in the Qt framework. We are going to stop here in this lecture, and I will see you in the next one. Congratulations on hitting the end of this chapter, where we were learning about the tools we have at our disposal to do memory management in C++. We saw that we could use the new delete pair to do things, which is a low-level way to do things. If you have to use this, you know how to do that by now. We could use smart pointers, which are going to make it easier to do memory management. But this is going to require you to learn about smart pointers in C++, and there are a bunch of them. For example, we have unique pointers, we have shared pointers, and we have weak pointers, which we didn't really talk about in the course here. So if you are interested, you can do your own research. And we ended by looking at the Qt parent-child relationship, which you are going to see a lot of in the course here. And now you're not going to be surprised if you see us passing a lot of parents when we create objects in our Qt applications. We are going to stop here in this lecture, and I will see you in the next chapter. In this chapter, we are going to learn about signals and slots. And this is a way C++ provides to connect things. For example, if we have a button somewhere in our application here, and we have something we want to happen, for example, we want a function called when the button is clicked, we can set up a connection between the button and the function. And whenever you press on this button here, the code in the function is going to execute. And we're going to see how we can set this up using signals and slots in Qt. We will start by looking at lambdas, which is a C++ 11 feature, which is really cool. It's going to allow us to set up signals and slots in an easier way. So we're going to learn about this. And after this, we will go full scale and look at how to use signals and slots in Qt applications. After that, we will do a bunch of demos to really nail this down in your brain and get you ready to start using this flawlessly in your Qt applications. In this lecture, we're going to learn about lambda functions. And the lambda functions are a feature that was introduced in C++ 11, and they are a C++ construct that allows us to create functions on the fly. And you might be asking, why would I want a function on the fly? Well, you're going to see that as we progress in the chapter. But for now, please understand the syntax and the mechanics to work with lambda functions in C++. And the syntax is what you see here. To set up a lambda function, the first thing you need to provide is the capture list. And that capture list is going to be encapsulated in square brackets as you see here. After that, you need to provide the parameter list. This is going to be where you pass input to the lambda function. You may specify a return value of the lambda function. Then you are going to set up a body within a pair of curly braces. Please take a look at this syntax for a while and make sure you understand it. Now, let's see how we can set up a simple lambda function. What we are doing here, we are setting up a capture list within a pair of square brackets. We have the parameter list. We have our body, the opening curly brace and the closing curly brace and a semicolon, because this is a statement in C++ here. Now, this entire thing that I am circling is going to be our lambda function. Okay, this is our lambda function. And after we create this lambda function, we are going to assign it to something called func, and we will let the compiler deduce the type of this thing. And at this point, when we hit this location in our code, we will have the lambda function variable, if I can call it like that, in our code, and we will have the ability to use it. For example, once we have this func lambda function, we can call it using the syntax here, and this is going to execute this and say hello world on the console. I realize this may be cryptic, but please bear with me. We are going to have a chance to play with this in Qt Creator, and it is really going to make sense. And when we start using this within signals and slots and doing all kinds of crazy things, you're going to be glad you learned this syntax in C++. I use this all over the place in my C++ projects. Now, this is the syntax to set up a lambda function, and make sure you understand this. Now, we have set up this lambda function and called it in a separate statement, but it is possible to set up a lambda function and call it immediately. And we're going to look at a simple example here. So you can do something like this. You can set up your lambda function. Again, this entire thing, let's make sure I circle it. How do I do that? Let's go here and do something like this. This is our lambda function, but we are adding a pair of parentheses to call the lambda function. Remember, the parameter list is empty, so this lambda function is not going to take any parameter. But when we set up code like this, we're going to see hello world printed out on the console. And this is because we are setting up the lambda function and calling it immediately with these pair of parentheses here. Please make sure you understand this. And at this point, I really want you to keep an eye out for the syntax. We have the capture list, we have the parameter list, and we have a body of the lambda function within this pair of curly braces. Now, let's see how we can set up a lambda function with parameters. We have our trusty capture list within this pair of square brackets, and we have our parameter list, which is no longer empty now. Now it has two parameters, A and B. The type is int. And we can specify our body within the pair of curly braces. And now you know what this lambda function is going to do. It is going to print out the sum of whatever you pass within these parameters. And this lambda function is called right away. You see we have a pair of parentheses with 7 and 3. So this lambda is going to add up 7 and 3, and it is going to print the result saying A plus B equals 10. That's what it's going to say when we run this in Qt Creator. One thing I want you to see is how you can set up a lambda function that returns something. Sometimes you need to specify the return type, and if you need to do that, you need to use a trailing return type syntax here. This is what it's called in C++. So you need to use this symbol here, a dash and a greater than symbol, and you specify the return type. The rest is really the same we have seen before. We have the capture list, we have the parameter list, and we have a body. Now, this lambda function is going to return the value, which is going to be a 10, and we are going to be printing that in this statement here. And again, make sure you understand the syntax. In a minute, we are going to head over to Qt Creator and really play with us, and you are going to understand how this works. Now, I want to understand what we call capture lists. Capture lists are a way for the lambda function to get access to data outside the scope of the lambda function. Because looking at the code here, you might think we have A, we have B. I am going to automatically get access to A and B and use them within my lambda function here. But when we get to Qt Creator in a minute, you're going to be in for a surprise. You don't have access to these guys because the lambda function here is really its own entity. You can think of it as an object living somewhere in your C++ program, and it doesn't have automatic access to things we have in the scope where we declare this lambda function here. That's why we need a capture mechanism to make sure the lambda function has access to these things. You can think of the capturing mechanism as a way to connect what we have inside the lambda function to things living outside the scope of the lambda function here. Please think of it this way. And here we are capturing A and B. This is the syntax you use to do that. You specify whatever you want to capture within this pair of square brackets, and now you will have access to these things. And if we run this lambda function, it is going to work. Again, make sure you understand the syntax. We are going to see this in Qt Creator, and you are going to understand this. Capturing has two sides to it. You can either capture by value or by reference. And if these concepts don't make sense, please bear with me. I am going to try and explain here. So here we are capturing the C variable, which lives in this scope. And what we are really doing here is making a copy of this value and storing it inside the lambda function. This is really what we are doing here. So we will have a copy of the C variable 42. It's going to contain 42, but it's going to be a copy, okay? And I want to prove to you that it is going to be a copy. We are going to go down and set up a for loop, and it's going to loop from 1 to 5. I think it's going to print for 4 times. And each time we go in the loop, we're going to call our lambda function. When we do that, we are going to print the value of C. And after that, we are going to increment C here. When we increment the value of C, we will be affecting the value outside the lambda function. We want to be affecting the copy we have in the lambda function here. This is what I want you to see. So this program is going to keep looping, printing 42, 43, 44, 45, or whatever, but the inner value in the lambda function is not going to change. And we're going to see this in a minute. And hopefully this is proving that what we have in the body of the lambda function is a copy. It is not the original thing. This is what I want to prove to you. But sometimes you want to capture by reference. You want the thing inside the lambda function to be affected when we do an incrementation like this. And to achieve that, you can capture by reference. And the syntax to do that is what you see right here. You use an ampersand symbol in front of the variable you want to capture. And in this case, it is going to be captured by reference. And what we have inside the lambda function is going to be a true reference to the C variable. So when we increment on the outside like we do here, the change is going to be even visible inside the lambda function, because what we have inside the lambda function is really a pointer or a reference to the thing we have on the outside. I really want you to see this. In many code bases out there, you're going to see things captured by reference and things captured by value, and you need to understand what this means. Let's look at how we can capture everything by value. We have this syntax in C++, and you use an equal symbol. When you do this, everything outside the scope of the lambda function is going to be captured by value, and what we have inside the lambda function are going to be copies of the things outside the lambda function. Again, if we do the same test we did before, if we increment C here, we will be affecting the outside value here, but we won't be affecting the inner value of C. And we're going to see this in a minute when we hit the IDE. We can also capture everything by reference, and the syntax is what you see here. And if we run code like this, we're going to see that the change here is going to be visible on the outside. We're going to see the outer value changing, but we will also see the inner value changing. Now that you know this, we're going to head over to Qt Creator and play with us a little more. Here we are in Qt Creator. We are going to create our new project. It is going to be a plain C++ application because we don't need Qt at this moment. So we're going to say non-Qt project. It's going to be a plain C++ application. And we are going to give it a name and save it somewhere on our drive. We are going to go and this chapter here, this is a new chapter we are starting. We are going to use this as the default project location. We are going to use CMake as the build system. We want BNGW as the kit. We don't want Git, and we will finish. Now, lambdas are a thing that was introduced in C++ 11, so you need to make sure the C++ standard you are using is greater than 11. I think we can even change this to 17. It's not going to hurt. Okay, and we are going to go in our main CPP file and clean things up a little bit. The first thing I want you to review is the syntax for lambda functions, and it is what we have right here. I want to make sure you remember this. So we have a capture list, What makes up a lambda function is the capture list. You need a parameter list that you are going to use to pass things into your lambda function. We may explicitly specify a return value, and we are going to have a function body. We are going to start up by setting up a lambda function and giving it a name. So let's do something like this and clean up. I don't want this to be messy. Why do we have this here? Let's do something like this. You can take this out, and we are going to say stdc out. Sorry for this, and this is going to go away in a minute. And why do we have all this space here? I don't know where it's coming from, but we have our lambda function here. So the way you set up a lambda function, you specify the capture list, you specify the parameter list, and you specify the body, which is going to be delimited by these curly braces. Inside the body, you can do whatever you want. In this case, we are going to say hello world, and I want to comment out the call for the lambda function here. So once we set up the lambda function, which is this thing we have in blue, again, let me try and highlight it, because some people are going to be confused as to where does the lambda function start and where does it end. The thing we have highlighted here is going to be our lambda function. And once we set this thing up, we're going to assign it to a variable called func, and we will let the C++ compiler deduce the type for this thing using auto, like we have been using it before. But you might be asking, Daniel, what is going to happen if I run my code right now? Why don't we try it? Let's go to projects and change the run configuration to run in terminal, because this is a console application. Let's try and build it. Let's look at compiler output here and build. Okay, the build is good. You see, we have no errors here. But if we try to run this, we're going to see that nothing is happening here. We can close the window here, and we're not seeing anything happen. The reason is we are setting up the lambda function, and now we have a handle, if I can call it like that, to this lambda function, but we are not doing anything with it. To be able to do things with it, you need to call it. And we call it like we call any other function. So we can use this variable name and use it like we are calling a function. And this is going to execute it, and we are going to see the body execute here, and we will see hello world on the console. Let's run. Now we are going to see hello world because we are calling this lambda function here. We can call it multiple times. Let's play with it and have some fun. We can say func, and if we do that, we are going to see hello world printed 3 times. You can even do this in a loop, but I'm going to let you play with that. All I want you to know is the syntax to set these things up and call them. Now, we have seen how we can create a lambda function and give it a name, but we can create it and call it immediately without storing the lambda function name here. We are going to go down here and put in a piece of code that is going to allow us to do that. I don't want to type all this, and I am going to adapt it to say stdc out and stdendl here. So we are setting up the same lambda function, but notice we are not assigning it to anything. Again, this entire thing here is our lambda function, okay? But notice we have a pair of parentheses, and this is what is calling the lambda here. Okay, if we run the code, we're going to see hello world printed out because we are setting up the lambda function and calling it immediately. And you can do that if you want in your C++ program. But personally, I haven't seen a good example for this, but some people are using this, and it is in C++, and you can take advantage of this if you want in your C++ programs. Another thing you can do is set up a lambda function that takes parameters. I am going to put in a piece of code here to save on some typing time. And what this is really doing, it is taking 2 parameters, A and B, and it is going to print the sum. And we are calling this lambda immediately. This is what we are doing here by passing in 7 and 3 as the parameters. Again, this entire thing is our lambda, if I can highlight it correctly, and we are calling it using this pair of parentheses, and we are passing in our parameters here. If we run this, we should see stdc out a plus b equals 10. Let's run this. And sure, this is what we see here. And we can also change this and store this lambda in a variable and call it. And the syntax to do that, but let's not clutter this. I am going to put this in a separate location here. So let's do that. And we are going to copy this and put that below. And we are going to say that we want to store the lambda variable. The lambda. And what we are going to do is something like this. We are going to say autofunc, what we did before. And we are going to assign the lambda to func, but we're not going to call it immediately. If we want to call it, we need to go down and say func and pass in 7 and 3. And this is going to do exactly the same thing. This is just a different syntax to do things in C++. If we run this, we should see the same thing printed out. Now we have the flexibility to change this. For example, we can change this to 38 and we should see a 45 printed out as the sum, and it is what we see here. You can use lambdas like this if you want. Let's comment this out. Next, we are going to see that we can set up a lambda that returns something. This time it's going to be different from what we did before. Let's say std_cout and std_endl and take out the comment line here. So now we are setting up a lambda function which is going to return a value, and I think this is not very readable. So what we are going to do is, what can we do? We can capture this lambda. Okay, I am going to do this on the fly and say value. Okay, and we are going to set up a lambda on top. We are going to say autofunc equals, and we are going to say it equals our lambda that we did before, and we're not going to call this immediately. We're going to say something like this, autofunc, and notice that we are specifying our return value here. This is the syntax. You put this symbol, a dash, and a greater than symbol, and you specify that your lambda is going to return an int in this case, and you can use whatever return type you want. But now we are going to say autoValue equals func, and we're going to call this with 7 and 3. Why not? You can do something like this. Then we're going to print that value. You can do something like this if you want. I just split this into 3 steps to make it easy to understand, because putting a lambda in an std_cout statement is the quickest way to get confused if you are learning about lambdas here. Now, if we run the code, it is going to print a 10, because here we are calling our lambda function. It's going to return a value, and we are going to print this value here. And our lambda is just adding things up. Let's run. We should see the sum is 10, and this is going to work exactly like we want. Now that you understand this, instead of passing in the value like this, you can go even crazier. Let's comment this and really show you this. I want you to play with this as much as you can. We can copy the code, and we can go down here and we can uncomment the thing. Now we can do what we did before. We can grab the lambda, take out the semicolon. We don't need that. We don't even need to capture the value here. Let's come back. That was bad. We're going to grab the entire thing here. We're going to cut it out, and we're going to print it. So let's do something like this. We're going to paste this in, and we are going to call the lambda with 7 and 3. And this is going to work. Look at this. Look at how ugly the syntax here is, but it is going to work. But it is the same thing we did on top here, just compressed to be put directly in an std_cout statement. Again, this is our lambda. It's not going to have anything captured. It's going to have 2 parameters. It's going to return an integer. We have the body of the lambda, which is going to return the integer, and we are calling the lambda directly. The return value is what we are going to print in this std_cout statement here. And you can do this if you want, but personally, I don't recommend things like this because many people are going to find them hard to read in your code bases. Let's run, and we will see the same thing printed out. If we put in 33, why not? We should see a 40 printed out as the sum, and sure, we have a 40 printed out here. Let's comment this out. I still have a few things I want you to see before we close the lecture. Okay, now we are going to learn about capture lists. And this is a way to capture things outside the scope of the Lambda function. Let's make sure the code is as I want it. We're going to take out the comment line here. And we're going to take out our capture list. This is a Lambda, and some people might think that code like this is going to work. We are setting up the Lambda and calling it immediately, but notice that we have a bunch of squiggly lines here. Okay, and if we hover over this red thing, it's going to say variable a cannot be implicitly captured in a Lambda with no capture default specified. And what this really means is the Lambda has no way of knowing what a is or what b is here. You need to help it out because this Lambda is really something living anywhere in your memory, and it doesn't directly have access to things we have in our main function here. Some people might think, because the Lambda is showing up here, it should have direct, immediate, or default access to things outside the scope of the Lambda function, but it doesn't. Okay, it doesn't. And if you try to compile code like this, you're going to get a bunch of compiler errors. And sure, you see your compiler errors here. To have access to a and b, we need to explicitly put them in our capture list. And we're going to say a, comma b to capture a and b. If you want, you can only capture a, but then the compiler is going to complain that it doesn't know what b is. So we need to tell it a and b. Now the compiler is going to know what they are. It is going to access them and sum them up and give us the sum that we desperately need to see here. Let's run. This time compilation should go through and we should see our sum printed out here. And this is what capture lists are for in your C++ program. So let's comment this out. We're going to see that we can capture either by value or by reference. So let's go down here and put in a piece of code. We want to show that we can capture by value here. And what this means is that the thing you capture in your Lambda is going to be a copy of the original thing you had outside the Lambda function. This is the point I am trying to make here. Let's make sure the code is as I want it because I hate using namespaces in front of my main function. I like to directly specify the namespace where the thing is living. That's why I am using stdcout, stdndl, and whatever here. Okay, let's capture by value. We have our Lambda function. It's going to capture C. So now we will have the ability to use C inside this Lambda function. Again, if you don't capture it, the compiler is going to complain if you use it right here. You need to capture the C value or the C variable before you use it in this Lambda function. But one thing I want you to know is that the C we have in the Lambda function is a copy of what we have on the outside. Again, the main method here is that C is a copy. And we will try and prove that. We will prove that by calling our function or our Lambda function repeatedly in a for loop. The loop here is going to go from 1 to 4. So it won't print when we hit I equals 5. But in the loop, we will try and modify the value on the outside because we have access to it, and see that the change we do on the outside is reflected inside the Lambda function here. And every time the Lambda function runs, we will try and print the value of C. And the message I hope you see is that as we loop through this loop, and what I want you to follow is the value of C both inside the Lambda function, the inner value, and the outer value outside the Lambda function here. Let's run this, but before we run, please make sure you have this maybe typed out on a paper or a piece of something, just to make sure you understand what is going to happen here. Because what is going to happen, we will be repeatedly changing the value on the outside. So we will see it incrementing 42, 43, 44, but the value on the inside is not going to change because once we set it up, the Lambda function is going to have a copy of this 42, and it is what it is going to repeatedly print as we loop, calling the Lambda function here. I really want you to see this. Let's pass this through the compiler and let's see what we see. We see the outer value is 42, the outer value is 43, the outer value is 44. The outer value is changing, but notice what is happening to the inner value. 42, the inner value, 42, the inner value, 42, the inner value, 42. The inner value is not changing because it is a copy the Lambda function captured when it was being set up. And once it is set up, it's not going to change. The change we are doing down here is only affecting the outside value of C. It is not affecting the copy that the Lambda function has taken when we set it up right here. I really want you to get this clear in your mind. Now, we have captured by value, but it is possible to also capture by reference. If we want the change we do on the outside to also be affected or reflected, if we want the change we are doing on the outside to be reflected on the inside of the Lambda function here, we can capture by reference. So let's go down and show you a piece of code that is going to capture by reference. Let's uncomment this and fix it up a little bit. I took more than I needed here. Let's take this out, and we need to change this to stdcout, stdendl, stdcout, and stdendl. And now we are going to capture by reference using the syntax here. If we run the code, the change we do on the outside is also going to affect the thing inside the Lambda function. And if we run the code, we will see the value on the inside and the value on the outside changing together. And this is really cool. 42, 42, 43, 43, 44, 44, 45, 45. We are capturing by reference here. Let's comment this out. And I want to go down and give you a bonus and show you that you can capture everything in the context englobing your Lambda function by value. If you want to capture everything by value, you use the syntax here. Okay, let's fix this up. Say stdcout. Okay, this is fixed now. So we are capturing everything by value. So C and D are going to be captured. But if we try and loop modifying the outside value, the changes are not going to be reflected on the inner value of C because we are capturing by value. Remember, what we have inside the Lambda function is going to be a copy. Remember that. Let's run. And 42, 42, 43, you see the inner value is not changing. It is keeping or staying to 42, but the outside value is changing. Again, the point of this little example here is to show you that you can capture everything by value using the syntax here. You can also capture everything by reference, and let's comment this out and see that. We can go down and put in our piece of code, and it is really nothing special. We are capturing everything by reference using the syntax here. Let's fix this a little bit. Okay, it is fixed up. Okay, it is fixed up. And what is going to happen here, the change we do on the outside is also going to be reflected on the inner value of C. So we're going to see 42, 43, both on the inside, on the outside. That's what we expect here. Let's pass this through the compiler, 42, 42, 43, 43, 44, 44, 45, 45. And this is what you can do with Lambda function. I really hope you have a good introduction to Lambda functions. Now that you know them, we're going to head over in the next lecture and learn about signals and slots in the Qt framework. Go ahead and finish up here and meet me there. In this lecture, we're going to learn about signals and slots. And the signals and slots are a big feature of the Qt framework. And I believe it's one of the big reasons many people choose to use Qt. Because signals and slots make communication between objects really easy, intuitive, and it's really easy to look at the code and understand what is going on behind the scenes. Now, signals and slots are a mechanism to allow objects to communicate. And a good example to explain this is to do an example. For example, suppose we have this push button here. And when you click on it, we want the text in this text level to change. What you can do, you can get this push button to emit a signal. Okay, it's going to be like emitting a signal. And when you click it, the signal is going to be emitted. And the text label is going to respond on that signal. And what you do in your code is you wire things up and say something like, if the button is clicked, I want the text label to respond. And this connection is going to be alive as long as you want to be alive. If you want, you can kill the connection, but it's going to be alive for as long as you want. We can do the same. For example, on top here, we have a slider, and below we have a progress bar. We can wire things up and say, whenever I move this slider towards the right, I also want the value in the progress bar here to change. And you can keep this connection in your application, and if you don't need it anymore, you can kill it. And this is really cool. So let's see how this works. The way things work in Qt is that some objects have the capacity to emit signals, and other objects have the ability to respond to different signals. And you can set all these things up in your C++ program using the Qt framework. Qt provides three ways we can work with signals and slots. We can use string notation, we can use functor notation with regular slots, or we can use functor notation with lambda function. I don't expect you to understand anything about this right now, but we're going to look at this one by one, and you're going to see what happens here. Now, a slot in the Qt framework is a function that has the ability to respond to some signal emitted in other parts of your Qt application. Again, a slot is just a function that is going to respond when a signal is emitted. You can think of it this way. Now that we have the slot, we can connect it to some signal. For example, suppose you have a button in your Qt program, and when that button is clicked, it is going to emit a signal. Okay, what we are saying here is whenever we click on this button, I want the change text function to be executed. And we say that using the connect syntax in Qt. You say connect, you specify the source object. This is what we are doing here. You specify the signal the source object is going to emit within this signal thing. So you say signal, you say parentheses, you specify the signal. Don't forget the parentheses on the signal, because the signal can pass parameters. That's why we have this parameter here. We can pass in parameters if we want. Then we specify the receiver object. You see, we are specifying the this pointer to mean that the receiver is going to be the object in which we are doing this connection here. This is what we are doing. Then we will specify the slot or the responder, the function that is going to respond to the signal being emitted. Now, the moment we have this connection set up, every time somebody clicks on this button, this function here is going to execute, and it is going to do whatever we want. This is what we call string notation, because you use this string signal slot to connect things up, and it is going to work. One thing I should say is that this is a syntax that comes from early days of Qt, I think from Qt 3 or Qt 4, I don't know, but it is an old syntax. And we have a new syntax called functor notation, and it is what we see here, but think of it as just different ways to do the same thing. So we say connect, we specify the source object here, we say an ampersand symbol, say the name of the class that is going to be emitting the signal, and then we specify the signal from that class. Okay, so it is a push button, and we want to respond whenever this push button is clicked. You can think of it this way. We also specify the destination object, and we specify the function that is going to execute when the signal is emitted. And this is just the syntax we have to use in Qt. We have to specify the class name for the object that is going to respond, and you're going to see how we use this in Qt Creator in a minute. But this is a syntax I want you to be aware of. Another thing we can do is use lambda functions. Again, the syntax is really the same. We specify the source object. We specify the signal from the source object using the syntax here. Don't forget this ampersand symbol. We specify a lambda function that is going to respond to this button being clicked. And this is our lambda function here. Let's see if I can highlight it so that it is really simple to follow. So this is our lambda function. It is going to capture everything in context. And whenever the lambda function executes, we're going to execute the code here. And this is just going to change the text in a label that we have on our user interface. And these are the three syntaxes you can use to connect things up in your Qt application. For signals and slots to work, you have to do a few things. The first is to make sure that your class inherits QObject. Another thing is to specify the QObject macro in your C++ class. If you don't, signals and thoughts are not going to work, and this is just a requirement you have to remember. Now, you must be wondering, what are the differences between these ways we can use to connect signals to slots? Well, to understand that, I would recommend you read this piece of documentation here. I have the link on the slides, but we can also hop over to our browser. You're going to see the differences between these guys. Some types of connections work in some scenarios and they don't work in others. For example, the string-based notation works when you want things to communicate from C++ to QML. And you can read this. I recommend reading this after you are done with this chapter here, and you're going to know more about these things. But the point I want to make in this lecture is that we have 3 different ways we can connect signals and slots in our Qt application. Now that you know this, we're going to head over to Qt Creator and play with all these kinds of connections we have talked about. Okay, here we are in Qt Creator. We are going to create a new project. It's going to be a Qt widgets application because we want some user interface stuff going on here. We're going to give it a name and store it somewhere on our drive. It's going to be a CMake project as usual. We want to make this a Qt widget application, and we want to use the MinGW kit. We don't want to get. And this is a summary of what is going to be created as a result of this project here. Let's wait for things to be patched up by Qt Creator here. And we have our widget header file. This is what you are familiar with now. We have the widget CPP file and we have our UI form. What we are going to do is to set up a button. Okay, we're going to put in the text and we are going to give it a name. Let's give it my button. We can call it my button. No big deal here. And what we want is to respond when this button is clicked. But we don't want to do it through the form like we did before. For example, coming here and go to slot. We want to do things ourselves. Let's go to widget. The first thing we want to do, let's not go so fast. We also want to put a label on here. So let's grab a label. I think that's what we had in the slides. Sorry for this, I was going too quick. And we're going to keep the name label. This is not going to hurt, but we can expand it and say hello here, or get out of here. We can say something like this. Now, we don't want to use any layouts or something. This is going to be enough for our purposes. Now we are going to go to the header file for our widget class, and we will set up a slot. And to set up slots, you use the syntax here. You say private slots. I think this is the syntax. And then you specify the function you want to be your slot. And it's going to be change text. I think this is what we used in the slides. And notice that we have a private here. If you want, you can make your slots public and they are going to be accessible from the outside. But this is something I want to use only in this class here. That's why I am making this private. I can generate an implementation or a definition for this slot. And one easy way to do this is to right click, go to refactor and add definition in the CPP file, which happens to be widget.cpp. And it is going to take us in the widget CPP file and we will have our implementation here. What we want to do in here is change the text of the label we have on the user interface. So we are going to say UI label and we are going to set the text to some other text. We can do something like this, but this is not working yet. If we run the application, you're going to see that if we click on the button, nothing is going to happen. Okay, we click, nothing happens. We can look at the application output here. Application output, this is what I want to see. And if you click on the button here, nothing happens. So what I want you to see is that we can use the string notation to connect things up. And we will set up our connections in the constructor of our widget class. Let's say that we want to learn about string notation. And we are going to say connect. We will specify the source object. The source object is going to be my button from the user interface, and we will specify the signal that the source object may emit. And I think we should use the pointer notation here. And the signal we want to respond to is the click the signal. And how do I know push button emits the clicked signal? Well, I can check the documentation, and this is really something I want you to be familiar with. You can go to Q push button, and we can click to open the documentation for Q push button. And if we look at more, I think we're going to have a section on the signals that the button emits. Can I see your signals? We have events, we have protected functions, we have slots, and we are not showing that here. So we have properties, public functions. Let's go to the parent of the push button here. So if we click on Q abstract button, I think we are going to have those signals. And sure, if we scroll down, we're going to see that a button can emit a clicked signal. And we have the ability to not specify a parameter here because we have a default parameter. Let's go back to our code. We're going to respond when the button is clicked. Okay, we're not going to specify anything. Let's make sure this is delimited correctly. Now we are going to specify the destination object. It's going to be the current widget object. Then we will specify a slot that is going to respond when this button is clicked here. The slot is going to be change text, and we are going to say change text. And we are going to set up something like this. The moment we set up a syntax like this, and I want you to be very careful about these parentheses and whatever. If you get them wrong, your compiler is going to complain. Make sure it is the syntax you see here. If you want, you can even copy the code and paste it in your Qt Creator instance, and you can learn from there because those errors can be really confusing. So now we have made the connection, and hopefully if we run, we will see our change text slot activated when we click on the button, and we are going to change the text. And you see this is happening here. Let's run again. Click, the text changes. Let's run again. Click, the text changes. We are making the connection here. Now you must be asking, how does this relate to what we did before? For example, before we could come to the form here and do right click and go to slot, and we would generate a function that is going to respond. Well, that was Qt setting up a slot for you, or a function that would respond to the signal when the button is clicked. And Qt has an internal mechanism of knowing which button to connect to the slot, but I don't want you to use that syntax because this one is much more explicit. You can use that for user interface component, but it's really not very easy. For example, let's try this. We can set up another button. I think it's going to be easier to talk about this with an example. So let's say button, and we will have button 2. And on this button, we can do something like this. We can do go to slot, and we want to respond when it's clicked. And if we do OK, we're going to have a thing generated for us by Qt Creator. And this is a connection Qt is going to do. It knows that we have an object called push button. Okay, it knows about that because we have that on the form, and it uses this built-in ugly syntax. I think it is ugly to say on, okay, on underscore, and you specify the object name, and you do underscore and say clicked. If you look at the syntax here, you're going to see on underscore, and you're going to specify the object name. Okay, this is the object name you should have on the form. You should have an underscore and specify this name of the signal. Okay, you can do something like this, and things are going to be connected up. When Qt sees this kind of syntax, it is going to make the connection for you. But I wouldn't really recommend relying on this. I only use this to get signals for UI components I have on my form. Otherwise, I like to make my connections myself. So let's go back and take out the button here, because I don't recommend that. And we are going to take out the slot that was generated for us by Qt Creator. We're going to take this out, and we're going to take out the implementation for that slot. And we should be back to square one with our own connection here. If we run, we should see a widget pop up, and if we click, the text is going to change, and our slot here is doing the job. Now, we have seen string notation, but we can also use functor notation with regular slots. And the syntax is really simple. Let's just go down and put in the code, and we're going to adapt it to work with whatever objects we have in our program. So our button is called my button, and the signal is going to be clicked, and the slot is going to be change text. Okay, this is going to be the thing. And if you do things like this, you're going to get the same kinds of connections. If we run, we're going to have our UI right here. If we click, we're going to see that this is going to work. We can also use a lambda function with functor notation. Let's go down and put in a piece of code to play with that. We can make a connection like this, and the button is called my button. Let me change this a little bit. And this is going to work. You see, we're going to create the label, we're going to change the text, and we should change the text to be the same. So let's copy that and go in and change text to be some other text from lambda. Let's say from lambda, to really be sure that our lambda is working. And the connection here is going to work. Again, I just want you to look at these things as just syntax. The important thing is to understand what they do. We are connecting an object or a signal coming from an object to another function. In other words, we are saying every time this button is clicked, my button is clicked, we want the function here to run. And we are basically connecting two objects and getting them to communicate in our Qt application. I can't tell you how good this is. If you try to do these kinds of things yourself, you will be setting up callbacks and whatever, and it's really ugly. Qt has a good design for communicating between objects and getting things to work. Let's run this and see it in action. We should see our widget pop up here. If we click, the text is going to change, and this is really what we want. Now that we have the thing working, I think we should make this look a little bit better. So we can apply a layout to the form. Let's click on an empty space here, apply a vertical layout, and we can resize this a little bit. And if we run, it's going to be a little bit better. And we click, the text is going to change, and we can resize this thing, and it's going to look nice because of the layout we just did here. This is really all I had to share in this lecture, showing you different ways you can make signals and slot connection. You can use string notation, you can use functor notation with regular slots, or you can use the functor notation with lambdas. And to be able to use signals and slots, your class has to somehow inherit QObject. We are inheriting QWidget here, and QWidget itself somehow inherits QObject. But we also have to specify the QObject macro here, and this is going to give us access to the signal and slot feature. Another thing I want you to be careful about is that your slots need to live in a section that is marked by private slots or public slots or whatever access specifier you want them to live under. If you want to know the difference between different signals and slot connections, again, you can visit this piece of documentation here. You can read this up. You can look at these examples. They are going to talk about these things in detail. But don't worry about QML, because this is something we don't talk about in the course here. I am going to be making Qt6 versions of QML, and you can learn about QML when you are done with the course here if you want that. I am going to stop here in this lecture, and I will see you in the next one. In this lecture, we're going to see an example of how you can use signals and slots to do something really cool. We are going to set up a user interface like this. We will have a slider, which is what we have on top here, and a progress bar. And as we move the little blue thing here, the bar, either to the right or to the left, we're going to see the value in the progress bar here change. The code is going to look something like this. We will have these things on the UI form, and we will set up a connection using string notation, just like we see here. We can use functor notation, just like we do here, or we can even use lambda functions. Let's head to Qt Creator and play with this. Here we are in Qt Creator. We are going to create a project pretty quick. It's a Qt application, a widget one. We are going to give it a name and save it somewhere on our drive. We are going to hit next. CMake is going to be our build system. We're going to hit next and use Q widget here. Hit next again. We want to use MinGW. We don't want get, and we are going to finish here. This is going to generate our project. Let's wait for it to get ready. And we will have our files here. We want to go to the UI form and set up our user interface. We want a slider and we want a horizontal one. If you want, you can use a vertical slider. And we want a progress bar. I think we're going to find that right here. And we can set these things up and put them in a vertical layout. We're going to click on the empty space on the form here and hit the button that puts them in a vertical layout. We are going to resize this a little bit and we can run the application and it's going to be here. But as we move the slider, we see that things don't go accordingly. We want that if we move the slider, the progress bar is going to follow. For that, they need to be working in the same ranges. So let's say we are using the slider here. We click on the slider and we scroll down on the properties here. We are going to see that it's going to go from 0 all the way to 99. If we look at the progress bar, and it's going from 0 all the way to 100. Let's make sure the maximum is also 99, or let's make them 100 and the minimum a 1. Okay, we should also go to the slider and make the minimum a 1 and the maximum 100, if I can type this. And now they are working with the same ranges. We want that if you move the slider, the progress bar is also going to follow. We also want the default to not be 23. I think we can change this somewhere. The value is 23. Let's say the value is going to be 0 in the progress bar by default, or a 1. Why not? Why is it saying 0 here? I don't know. Let's not worry too much about this. So let's say enter here. And now we want to connect the signals to the slots. We want to connect signals from the progress bar. We want to connect signals from the slider to a slot in the progress bar here. Let's do this. But before we do, let's look at the documentation for these things. We can look at QSlider. It is the class after the slider we are using on the UI form. And you can look at this. So it emits a value change signal, and it is what we are going to be using. This signal is going to pass an integer. You can see that right here in the documentation. We will capture this signal in a slot of the QProgressBar class. Let's look at QProgressBar. We can do that. And let's look at public slots, and we have a set value, which is going to set the value to our progress bar. So what we are going to do, we are going to connect a signal from the slider to this slot in the progress bar. Let's head to the widget CPP file, and we are going to go down and use a string notation here. So we are saying UI horizontal slider, whenever you emit a signal of value changed with this integer value, we want the slot from progress bar to capture the value. And we want to use that to set the value in the progress bar. Let's comment out the other connection we are doing here. We are going to talk about this in a minute when we have this working. So we can run this thing. And now, hopefully, if we move the slider, we're going to see the progress bar following. And this is really cool. How cool is this? I love this. This is really amazing. I can't tell you how happy I was the first time I was able to do something like this in Qt. That's when I was hooked. And I use Qt all over the place this time. So let's close this. Let's look at this connection we are doing here. I think what I wanted to tell you when I set up this example is that you can also set up your own slot to respond and have this slot take an integer. Let's set this up. We can go in our private section, or our private slot section, I should say. And we're going to set up a slot that says void respond, and it's going to take an integer. Let's call this value. And let's put the implementation in the header. This time it's going to do. Or let's take out the implementation here. I don't like implementations in the header files. So let's put this in the CPP file by refactoring and adding definition in widget CPP. And now we can include QDebug because I want to debug output the value. And we are going to go in our slot or our respond function here and say QDebug. And we can say the value is value. We can see it printed out on the console. That's what we want to see. So let's run and make sure we can see application output because we want to see the values printed as we move the slider. Now we have two things responding to the signal from the slider. We have the progress bar, which is going to show the output as we move here. You see it's going, but we also have output from our other respond slot that we connected here. You can see you can connect a single signal to multiple things, and this is really cool. So let's see how we can do the same using the functor notation. Because we are learning here, we should explore as much as we can. So we can go down here and put in the code, and I am going to uncomment this, and it should work. If there is any problem, we will try and fix this. And this is the syntax for functor notation. Don't forget these ampersand symbols, and you have to reference the correct class name. And if you follow these rules, this is going to work without a problem. Let's run. And if we move the slider, we're going to see what we expect. The progress bar is going to change, and we will see values changing in our output here. We can also use lambda function notation. And before I show you that, try to set that up yourself to really make sure you learn these things. Do that as an exercise and see if you can set up the same thing using the functor notation with lambda functions. So give it a go. Now I am going to show you my solution here. So let's uncomment this and we will connect the slider to a lot of things. Now we will have a lambda which is going to respond when the slider is moved. Now we will change the value explicitly in our progress bar, and we will be using the value we get from the horizontal slider. So this is a bit convoluted, but it is going to work. Then we are going to explicitly call our respond slot here. Okay, and we will pass the value we get from the horizontal slider. If we run, we are going to see that the code is going to work. We move this, the progress bar changes, and the value is changing. And this is something cool you can do by connecting signals to slots. And I can't really stress the importance of using the documentation enough. This is your best source of information. Make sure you know how to use it. Take some time to read about the components you are using in your application. You are going to save yourself hours, if not days, of frustration. And as you use this, you're going to gain experience and be able to find solutions to your problems faster. This is really all I had to share in this lecture. I hope you found it interesting. We are going to stop here in this one, and I will see you in the next one. In this lecture, we are going to build a calorie counter application, and it is going to look something like this. So we will let the user specify the time they have been working out in hours. They will specify the weight, and we will capture all these pieces of data in a bunch of spin boxes. And we will let the user specify the slope of the area where they are working, if they are working straight on a level space or if there is some kind of slope. This is something we want to take into account. But in this application, we will suppose that they are working on a level surface, something like this. So they will also specify the speed. And if they put in all these pieces of data, the application is going to automatically compute the number of calories they have burned. And we are going to be using a formula I have stolen from this website here. The formula is what we see here. So the number of calories the person has burnt is going to be equal to this number multiplied by the speed squared to the power of 3 minus this number multiplied by the speed squared plus this number multiplied by the speed plus this number. And all this is going to be multiplied by the weight of the person and the number of hours they have been working out for. This is the formula we're going to use. If you want, you can go to the website and look at that. So the calorie counter is here, and they have a user interface that doesn't look like ours, but the formulas they use are here. And we're going to be using the one for the level condition when the user is working on a surface without a slope. So if you want to improve the application later, you can take into account all these things, but we are going to keep things simple and only use this formula here. Okay, we are going to set up a class that is going to model the person. This is really a design issue. If you wanted, you could model the weight in your widget, but I am going to take into account that you could later add other things to the person. For example, the age, the gender, or whatever. And we are going to encapsulate all the data about a person in this person class here. But all we really want from this person is their weight so that we can use this in our formula a little bit. So the formula again is going to be this. The widget class is going to look something like this, and it is going to have a bunch of methods. We have a method to calculate the calories. We have a method that is going to be triggered whenever the weight changes. And this is going to be a slot that is going to be called. We have one that is going to be triggered whenever the time changes. We have one that is going to be triggered whenever the speed changes. And notice that they all take input. This is something worth noting here. We have a few member variables. We have a person, we have the time, we have speed, we have calorie count, and all these other things are doubles because that's how I wanted to model this. If we go down, we're going to see the implementations for some of these methods. Whenever the weight changes, we're going to store the weight in our person object, and we are going to recalculate the calories because the calorie count depends on the weight. Whenever the time changes, we are going to save the new time and compute new calories. Whenever the speed changes, we're going to store the new speed and recompute the calories. Now, let's look at our function to compute calories. It is really simple. We are just rewriting this formula in C++ code. And the value we get is going to be stored back in our calorie count. And after we do that, we are going to emit a signal. And I think this is new now. We have never emitted our own signal, but if you want, you can set up your own signals and emit them in your C++ program. And we are going to be connecting to this signal to know which calorie count to show on the user interface. I think we do that in the constructor of our widget, and the connections are going to look something like this. We are going to connect to the UI components. Whenever the weight changes, we are going to trigger the weight changed slot. Whenever the time changes, okay, value changed, we're going to trigger the time changed slot. Whenever the speed changes, we are going to trigger the speed changed slot. And remember, all these are going to recompute calories and emit the calorie changed signal. So what we do down here is to connect the calorie count changed signal to our slot, which is a Lambda function really. And the slot is going to change the text in our label, and it is going to use the string number function to display that as a string in our text label. And to glue all these things together, we will need to set up a user interface, and we will set it up like this. We will have a calorie count label. We will have the text here. We will figure out a way to make it red. We will do all these kinds of crazy things. And I just want you to have a nice example in which you can put your knowledge about signals and slots to good use. Let's head to Qt Creator and do this. Okay, here we are in Qt Creator. We are going to create a new project. It's going to be a Qt widgets application. We are going to call this calorie counter, store it somewhere on our drive. It's going to be a CMake project. We want it to be a Qt widget application. And next, we want to use the MinGW kit. We don't want Git here, and I think we should finish. This is going to generate the project. Let's wait for it to be ready. Okay, the project is here, and the first thing we want to do is to set up the user interface. So what do? We are going to use a label. I think we need a label here, so let's put one label here, which is going to say calorie count. It's going to show this. We may make it a little bigger. Let's select this, and we can select this guy and go in our properties here and change the font of it. I think we can do that. Let's change the font to something bigger, maybe 20, and make it bold. And if we do this, it's going to show up like this, calorie count. And we can move this a little bit here. And we're going to add another label, which is going to show the real count. Let's say 100 as a placeholder to make sure it shows the data correctly. And we can change it to, let's change the font also. We can change it to be also 20. Why not? Maybe 25. Do we see 25? Let's use 24 and also make it bold and make it big enough to show the data. So we have these things here. How do we change the color of this? I think we can use a style sheet. So what do? We can go to style sheet here. We're going to cheat a little bit. We haven't learned about style sheets, but this is a way you can change the look of your thing. And what we want to do is to add a color to our thing, and we want this to be red. Okay, the moment we do this and hit OK, the text here is going to change and be red. Just follow the instructions here. We haven't learned about style sheets yet, but we will get there in the course. Now we have our calorie count showing here. Let's put in a bunch of other labels. I think we will need 4 more labels. According to the design we had in the slides, we can go back and pick a little bit. We need time, weight, slope, and speed. Time, weight. This is going to be the time in hours. What else? Let's look. We have the weight in kilogram. We have the slope, and we have the speed in kilometers per hour. I think this is what we had. And all these things are going to be modeled as spin boxes. Okay, double spin boxes. So we're going to do that. Let's bring in a bunch of double spin box. Again, I know this because I have experience. As you use these things, you will know which component to use for whatever piece of data you need to display. And we will have a chance to learn about all these widget components here. Let's find another one which is called the combo box, which allows us to display a list. And it is this little guy here. We're going to grab it and we're going to double click on it and add a piece of data and say level. And it's only going to have this option here. This is what we want. Now we have everything we want. And now what we're going to do is to put some of these things in layout. We are going to select the time, but before we do that, we're going to name these things. Otherwise, we're going to be very confused. The first one we're going to do is to name the calorie count label here. Let's do that. We're going to call it calorie count label. We will name the time spin box, and we will name it the weight spin box, and we will name it the speed spin box, and we will name it the slope combo box. This is a combo box component. We are going to grab the weight things and put them in a horizontal layout because we want them displayed from left to right. We're going to do the same thing for slope. We're going to do the same thing for the speed here. And we will grab all these things. I think we can, what can we do? We can use the right property panel here. And we're going to grab these layouts. We don't want this. We want the one for time and slope. And we're going to put them in their own horizontal layout. We can do something like this. And we're going to grab the one for speed. The one for speed, and this is really hard to follow. So let's go down. We need the one for speed. And the other one, can we select these layouts? These things are really hard to get a handle on. We can select them like this. I think I can click on the form and select all these layouts, and I can put them in their own horizontal layout. And I am going to grab the labels for the calorie count. I am going to make them horizontal as well, put them in a horizontal layout. And I can click on the form here and put everything in a vertical layout. Now I can resize this and you can see that it looks much better. Okay, Let's run and see how this looks. Okay, we have the thing here. It's not bad. Let's change the title here to calorie counter. We can click on the form here. Let's make it a little big. And click somewhere here on the form. And we're going to change the title, which I think is somewhere around here. Window title, calorie counter. And now that we have the user interface, we can move on to put in our slots. We're going to go to the header file. Or before I put in the slots, I am going to set up my person class. Because I have that already set up, I don't want to type all this and really waste your time. I am going to go where my project is stored on the drive. So let's do that. It is this location here, and I am going to paste in the person class. You can get this from the source code of the course if you want to do what I am doing here. Now that I have this, I can close this, go back to my cmake list.txt file, and make sure person.h is n and person.cpp is n. Once I do that, I am going to rerun cmake as we have done before, and we have the class magically appear here. And it has our member variable, which is the weight, and we have the implementation for the class here. I think we don't need all these things. So let's take this out. And this is the class we need. We can go to the widget header file. And what we are going to do is to include our person class. Let's do that, person. And we are going to set up a bunch of member variables. We're going to set up a member variable for person, for time, for speed, and for a calorie count. We want a bunch of slots, and we're going to put them below our destructor here. And this is going to be called to calculate calories. We want one to be called when the weight changes, when the time changes, when the speed changes. This is what we are doing here. We also want to emit a signal. And when you set up a signal, you put it in a signals section. You say signals. This is a thing that is required by Qt. And we are going to name our signal void calorie count changed. I think we can do something like this. And this is going to take a parameter of the new count for the calories. This is how we want this to work. Okay, we can implement these functions here. So let's do calculate calories, refactor, add definition in the CPP file. We're going to do all of these, refactor, add definition in the CPP file, time changed, refactor, add definition in the widget CPP file, and speed changed, we're going to refactor and add definition in the CPP file. To compute the calories, we're going to use this function here. And the formula is what we have seen in the slides. We just set up that we're going to be computing based on the speed, the weight, and the time, and store the value in our calorie count. I don't think we needed this parameter here, so I am going to take it out, because we're going to be reading that directly from the mCalorie count member variable. This is the design we have chosen. And after we have a new calorie count, we're going to emit a signal saying that the calorie count has been changed. So what we are going to do, we are going to connect to this signal and make a change in a piece of code that is going to change the calorie count on the user interface. But before we get there, let's put in these slots here. So when the weight changes, we want to store the new weight in our person object and compute the calories. When the time changes, we want to store the new time and use that to compute the calories. And when the speed changes, we want to store the new speed and calculate calories using this new speed here. Now we can head over in our constructor and do the connections we need to do. The first thing we are going to do is to initialize the members with the values from the user interface. And we are going to initialize the weight, the time, and the speed. And let's see the names for the UI components here. Let's see UI, and what is the name of this? Time spin box. So we're going to say UI. Let's go to the widget CPP file here. I think we can ask Qt Creator to help here. So we're going to say UI weight spin box value. That's what we want here. We're going to say UI time spin box value. Let's do this. UI time spin box value, not validate. And we're going to say UI speed spin box value. We're going to do something like this, and we will have our values initialized here. After we do this, we need to connect the spin boxes. And after we do, we will need to update the calorie count when necessary. So we are going to do our connections here. So let's do that. And we have our naming issues, weight, spin box, and we need to say time, spin box, and speed, spin box to get this to work. Okay, whenever the value changes in the weight spin box, we want the weight changed slot to be executed. Weight change is going to store the new weight and compute new calories. This is what we are doing here. And we are doing the same for time and speed. After we have this wired up, we want to update the calorie count whenever the calorie count changes. And remember, whenever the calorie count changes, we are emitting this signal here. So what we are going to do is connect to that signal that we are emitting ourselves. The signal is calorie count changed. We will set up a lambda function that is going to respond. And again, that lambda function is this thing here. Okay, this is our code that is going to respond. And what we are doing, we are saying UI calorie count label is set and setting the new text. Which text are we setting? We are grabbing the new calorie count and using that as a string in this calorie count label here. And we are done. But before we go, let's call calorie count changed, so that the first time the application runs, we display the calorie respective to the values we got from the user interface here. So let's do calorie count changed or compute calories. That's what we need to do. Calculate calories, I think that's the function here. We're going to call it. And now we should run. Let's see what we had in our design as default values. Time was defaulted to 1, weight defaulted to 10, speed defaulted to 6. Let's do 1, 10, 6. Let's go back to the user interface here. So this is going to default to 1. The value, we're going to change that to 1. Value. Let's go. Where do we change the value of this thing? The value is 0 right now. We're going to change that to 1. And this is going to be 10. Let's change this to 70. Let's say you are 70 kilograms. Your weight is 70 kilograms. And the speed was 6 kilometers per hour. This is the defaults we want to use. Let's bring this down to being small. And we can run. If we have no compiler error, this is going to run. Seems it to run. Now we have a default calorie count, and every time we change any of those things, we're going to see the calorie count change. And this is really a good use of signals and slots in your Qt application. We can minimize this and really keep playing with this however we want. But the bulk of it is to be able to know how to wire your signals and slots. You saw that in this example, we had a chance to even emit our own signal. This is something I am glad we had a chance to do. And to emit your own signal, you just use the emit syntax here. I think you can even omit this and it is going to work. Let's try that. Okay, let's see. It is going to still work, but emit is going to make it very explicit that you are emitting a signal in your Qt application. This is really all I had to share in this lecture. I hope you had fun setting up this calorie counter application. I would challenge you to even improve on it and make it support different kinds of slopes. And what you would have to do is to make this level thing work. You would put a lot of slopes in here and use different kinds of formulas depending on the slope chosen by the user. If you can't do it now, you can do it later when you know a little more about Qt. But this is certainly going to be a good exercise for you to practice your muscles in using the Qt framework to do all kinds of crazy things. I am going to stop here in this lecture, and I will see you in the next one. In this lecture, I wanted to introduce to you a thing called property bindings in the Qt framework. And this is just another way to get objects to communicate in Qt, but it is something that came from the QML way of doing things in Qt. And in Qt 6, they ported this thing to Qt widgets. We can use it from the C++ side of Qt. But this is a new thing. It is not widely supported. I am myself not very familiar with it, but I really wanted you to know that this is a thing. And if you want to learn about it, you can go to the Qt blog here. I think they have a good example. Let's go there actually. And you can learn a lot about property bindings in Qt 6 using this example here. So they say that it is something that came from QML. Again, we are not talking about QML in the course here. You can set up a class in Qt and get it to automatically get updates without doing any explicit signal and slot connection. Instead, what you use are a bunch of bindings here. I don't really want to go into too much details. I prefer to use signals and slots, and I don't really have all the experience I need to be able to explain these things to you in any meaningful way. So I am going to leave you to read this blog post here if you are interested in property bindings on the C++ side of Qt in Qt 6. And I am going to stop here in this lecture, and I will see you in the next one. In this chapter, we had a chance to learn about signals and slots in the Qt framework. And we saw that this is a way we have in Qt to set up connections between things. For example, we have a button again here on the left, and we have a piece of code we want to execute when the button is pressed. We can use signals and slots to set up this connection here and say, whenever somebody clicks this button, I want the code here to execute. And we saw that we could do that using string notation. We could use functor notation with regular slots, or we could even use the functor notation with lambda functions, and that was really cool. We also had a chance to do a bunch of demos. We did a connection between a slider and a progress bar. We also did a calorie counter application, which really stretched your brain if you are just getting started with Qt, but I wanted you to see the workflow, and I hope we achieved that in this chapter here. We are going to stop here in this lecture, and I will see you next time. In this chapter, we will be learning about the dialog classes we have in the Qt framework. And these are classes that allow us to pop up windows to show temporary or transient information to the user. For example, you want to do something and your application decides that the thing you are about to do may be dangerous. And we pop up a dialog to ask the user, do you really want to do this? Then we give the user the option to either say yes or no. We're going to be able to do things like this in this chapter here. We will learn about the QDialog class, the QDialog button box class, which allows us to set up buttons in a way that they show up better on different operating systems. We will learn about file dialogs, font dialogs, and all kinds of crazy things. And this is going to be really fun. So let's head over to the next lecture and get started. In this lecture, we are going to learn about the QDialog class. And QDialog is the mother class of all the classes that show information transiently. Something like we did with QMessageBox. And you can think of QMessageBox as a special dialog that is predefined to let you do things. But you can build your own dialogues, and that's what we're going to do here, and it's going to be a lot of fun. Here we have an example of a dialogue I got from Qt Creator. I think this is what you see if you go to tools and options, and something like this is going to pop up. And you can see that it's really complex. You can set up crazy user interfaces. You can set up a bunch of tabs, and you can really do all kinds of crazy things. And here we're going to learn the basics that would allow you to do something like this. Let's just go to Qt Creator and show you that if we go to tools and do options, we should see a dialog pop up, and it is this thing here, and you can really see that it is complex. And you can build something like this if you need to in your Qt application. Now, as I said before, dialogues allow us to show temporary information to the user. We want the user to select something or tell us some kind of information, and we want the dialog to go away as the user is done doing whatever it is they are supposed to do. A good example, and this is actually what we are going to be building, is a widget that we pop up when the application runs. there will be a button to let the user provide information. And if you click on this button, we're going to pop up a dialog, and that dialog is going to be this thing here. We are going to ask the user to tell us what they do in a company. For example, they might type, I am a manager, I am whatever. You can type whatever you want in here. Then we're going to ask them their favorite operating system. Once they have provided the information, they are going to either click OK or cancel. If they click OK, we want to capture the information or process the information to see if it is something useful. If they click cancel, that's usually an indication that they didn't put anything useful in here. So you're just going to discard whatever information comes from this dialog here. Once the user chooses and hits OK and they have some information here, we will show that information in this text label. This is the design we're going to do to learn about dialogues. So there are two ways you can show a dialog. You can either show it as a model dialog, and that dialog is going to block other pieces of input to the application. So if you try to click around and do things, you are going to get some crazy sounds, and you want to be allowed to do things while the dialog is still on top. A non-modal dialog can allow you to go and do other things while you are still doing things in the dialog. And if this doesn't make sense, please bear with me. We're going to do an example and you're going to see what this exactly does. It's going to be very clear. Now let's see how we can set up our own dialog. We're going to set up a class. It's going to be inheriting QDialog because QDialog gives us the basic infrastructure on top of which we can build our own things. This class is going to have a built-in constructor here. We will put in a bunch of variables to store the information we are interested in. So we are interested in storing the position and the favorite operating system. If you remember, that's what we had on our dialog. And we want to respond when the user has clicked on OK and when the user has clicked on the cancel button. And we have a bunch of getters to get the information. We can use this however we want. Here you see the form we are going to design. We will do this in a minute when we hit Qt Creator. And another thing you should know is that once the dialog has popped up, you really have two options as the developer. You can either accept the dialog to mean that you did successfully whatever the dialog was meant to do. For example, you got correct data, or you can reject the dialog, and that's going to send information to whoever initiated the call of the dialog. So they can say, if the dialog was accepted, I can do something useful with the information in the dialog. If the dialog was rejected, I have nothing useful to do with the information in the dialog, so I can reject that. That's why we have these kinds of things here. And this is going to make sense in a minute when we use these things. Okay, here we see the code that is going to respond when the OK button is clicked. So we will grab the position in our form for the dialog, and we will check to see if the position is empty. If it is not empty, we are going to grab other things. We are going to check if any of the other radio buttons is checked, and if either is checked, we're going to set the text for the favorite operating system, and we are going to accept the dialog here. So this is going to close the dialog, and whoever initiated the call of the dialog is going to be able to read this information here. They are going to be able to read the position, they are going to be able to read the favorite operating system, and this is conveniently going to use the getters that we set in our class here, and this is going to be really cool. And when the cancel button is clicked, we are going to reject the dialog, and this is going to send information that we have no useful information in the dialog. I know this can be a lot to take in, so we are going to head over to Qt Creator and build this step by step. Okay, here we are in Qt Creator. We are going to create a new project. It's going to be a Qt widgets application. I am going to store this somewhere on my drive, and I am going to give it a name. Hit next. Choose CMake as the build system. We want to use a Q widget here because we're going to do something simple. We want the form, so let's hit next. And we don't want any translation. We want to use the MinGW kit. We don't want the Git version control system, and we are going to finish here. We will have our project generated, and let's wait for it to finish. Okay, the project is done, and we can head over to our UI form, And it's going to be really simple. So we're going to put in a button that says provide information. And when this button is clicked, we want to show information in a label. So let's do label, and we want to drag and put a label here. Okay, I think this is going to do. And we can put these things in a vertical layout. Let's do that. And we can resize this a little bit. So we want a user interface like this. We want to give this button a name. We are going to call it provide info button. And we want to respond when this button is clicked. So we can say go to slot by right clicking, and we want to respond when it's clicked. And we want to go back to the UI and give the label here a descriptive name. So we're going to say info label. I think this is going to do. And this is all we want. Now, what we want is to go in this slot and pop out a dialog and use that dialog to get information from the user. But we don't have any built-in component we can use. We really need to build this dialog on our own. So what we are going to do is go to the folder here for the project and add new. We're going to add a new class. So let's go to C++. It's going to be a C++ class. And we want to call this info dialog. This is what we had in the slides. And we want this to inherit Q dialog. And we don't have this right here. So the best we can choose here is dialog. If we do Q widget, for example, this is not. So let's do Q dialog. We're going to do custom. I think this is why they have custom here. And we're going to say Q dialog. Okay, this is what we want to inherit. And we can hit next. I think this is going to do. Let's do next. And I think that's also going to give us a form. We don't want to get. And we are going to finish. And we want to copy these guys. And we are going to go to the cmake_list.txt file, which is directly opened here. And we're going to paste in whatever it is we got. And this is not going to give us a UI form, which is regrettable. So let's go back and take this out because I want to get a form, which is going to make my life a bit easy. So let's go to where this thing was generated. We have trouble live here, but we are going to get out of this. So let's get this info dialog out. We're going to delete this. And we're going to try and find a way we can add a class and get a form. So let's see what is happening here. File, dialog, demo, info dialog, CPP has been removed. Do you want to save it under a different name or close the editor? I want to close the editor. Close the editor. And it's gone. Now let's try and add again. Sorry for this. So we are going to say add new. And be careful this time. And let's see, Q designer. We are going to go to Qt. Okay, and we want to choose Q designer form class. And this is going to create a designer form along with the matching C++ class header and source file. This is what we want. Okay, we had to make a mistake to get to know how to do this right. So if we want to add a class along with the form, we need to choose Qt and Q designer form, and we will see this generated for us. So let's choose here, and we want a dialog. I think we need an empty dialog because we're going to be setting things up on our own. So let's do dialog without buttons. I think this is going to do. And we are going to hit next. It's going to be named dialog. The class name should be info dialog. This is what we want. And we are going to hit next again. We don't want to get, and we are going to finish. We want to copy all these things and go to the cmake_list.txt file so that we can edit it. So we're going to paste. You see, everything that we added was copied on the clipboard conveniently. And we can run cmake again. And we should have our things here. So this is our info dialog. And if we go to the UI form for it, you're going to see it is empty. And we need to populate it. So let's do that. We are going to put in data. I think we have a label for position and we need a line edit that is going to grab the position. So let's say line edit, and we need the group box. Okay, and in the group box, we're going to put in a bunch of radio buttons. This must be becoming second nature now. And we're going to say Windows, Linux, and Mac. And we want to say position line edit, position line edit. Okay, and text label doesn't really need to, it needs to say position for one. And we have a colon here. So this is going to do, but the group box title is going to be favorite OS. We can do something like this. And we want to name these radio buttons here. Don't forget that. So Windows radio button. And we want Linux radio button. And we want Mac radio button. And we want two buttons. But before we put buttons, let's put the radio buttons here in a vertical layout inside this group box component. So make sure the group box component is selected and hit vertical layout. This is going to be laid out nice and neat. We should also put position and the line edit here in a horizontal layout. This is the design we are after. But we also need an OK and cancel button. So let's do that. OK and cancel. And we need to name these buttons. So OK button and cancel button. Let's do that. Okay, and we need the horizontal spacer to push this button as far as we can to the right. So we're going to use a spacer here, and we're going to put all these three things in a horizontal layout. I think at this point we can add a vertical layout to the entire form so that things are laid out nicely. So we can click on the form here, and we are going to click on the form and do vertical layout, and everything is going to be laid out nicely. I think we can resize this as far as we can. And we want to respond when the user clicks on OK. So let's say OK button, go to slot, and respond when it's clicked. We're going to go to the UI for the dialog, cancel, right click, go to slot, and we respond when it's clicked. And when the user clicks on cancel, they usually want to reject the dialog. They don't want to do anything with it. What we can do is call the reject method. So we can call reject on this dialog here. And if you want to know this method and what it does, just select and do F1, hides the model dialog and sets the result code to reject. Okay, this works for model dialogs. And I am going to tell you the difference between model and non-model when we get to show this dialog here. For now, let's go to the header. Okay, and we are going to put in a private section. And we are going to put in a bunch of strings. The first one is going to be M position. And the second one is going to be Q string, M favorite OS. This is what we want to do here. And we want to add a bunch of getters. So let's do, what do? We go to class. We can select the class and right click refactor. And we're going to add, can we do that? Rename symbol, create getter and setter member functions. This is what we want. And we want to do this for M position and favorite OS. We want getters for these guys. And I think this is going to do what we want. We just want getters. We don't want setters. So let's see. We can select all these members. Here they say select the getters and setters to be created. And this says create getters for all members. It's not really all members. We just want these two. Maybe they mean all selected members. But let's see. Let's see what happens. So let's do OK. And if we go to the header, we're going to see we have position and favorite OS, and these are methods we can use to get the data. Let's go to the CPP file and see if it generated those. You see they are generated, the implementations for these guys, and this is really cool. Now, when the user clicks on OK, they think they have provided all the information and they want the information to be used in the application. So the first thing we're going to do is to grab the position they typed in the line edit, and we're going to store that in a string locally in the function here. So let's say user position, and we are going to say UI position line edit, and we're going to grab the text in that component here. Now, we are going to check and see if it's not empty, just for some error checking here. So we're going to say user position empty. I think we have a method saying is empty for a string. So if the string is not empty, we are going to process here. If the string is empty, we're going to fall in this else block, and we know that we don't have useful information, and we are going to reject the dialog anyway. Once we are in here, we know that we have the correct position for the user, so we're going to store that in our member variable. So we're going to say mPosition, I think that's what it's called, and it's going to be equal to user position. And the rest is really going to be to check which checkbox is checked. Okay, so we are going to go in the UI and check to see, this is not the correct UI form. We want to check if the Windows checkbox is checked, or the Linux radio button is checked, or the Mac radio button is checked. I think here they have to choose one, but if you wanted, you could have used checkboxes. We have used radio buttons. It doesn't really matter. So let's go in here in the CPP file for our dialog, and we're going to say mFavorite OS. I think we can autocomplete here and copy and say here, Control V to paste. Yeah, if the Windows radio button is checked, we're going to store the favorite operating system as Windows, and we're going to do the same for Mac and Linux here. This is what we are doing. Now that we have collected all of the information, we need to accept the dialog. This is really important because this is going to tell whoever initiated this dialog that there is correct information that can be used in this dialog object here. So we're going to say accept. Okay, we're going to call this method here. And if you want, you can look at the documentation for this. It's going to hide the model and set the result code to accepted, meaning that this guy has been accepted, and it is really cool. So I think the dialog is done for now. We can handle the OK button clicked. We can handle the cancel button, and we have a bunch of getters we can call to get the information. Now we are going to go to the widget CPP file and include the dialog. And you can see this can be convoluted, but it works. Once you have the dialog, you're going to be using it all over the place. So include info dialog, we're going to include our header. And when the provide info button is clicked, we can create an instance of this dialog here. So we're going to say info dialog. I think we can do that. And we're going to call it dialog. We don't want to get any fancier. So dialog. And we're going to say new dialog. New dialog, and we're going to give it a parent. I think it can take a parent, and we should say info dialog here. Let's go back to the header. You see it takes a parent. It was generated with the proper constructor, which is right here. So that's what we're going to be using. And now I want you to see something. We can show the dialog model, and we show it in a model way by calling the exec method. Let's do that. We're going to say dialog and say exec. We're not going to do anything fancier. For now, I just want you to see what happens when a dialog is shown model. So let's wait for this to come. When we click on the provide info button, we should see our dialog pop up, and this is really cool. You see it right here. But if we try to click on the parent window here, we see that we can't really do anything. Okay, so this is what you can do with model dialogs. When the dialog is popped up, you can't do anything with the window that initiated the call of the dialog, if I can say it like this. But we can type in data, let's say manager, and say our operating system, and if we hit OK, that's going to be stored in the dialog. If we hit cancel, it's going to go away. This is a model dialog. If you don't want the dialog to be shown in a modal way, you can show it in a non-modal way. And you do that by calling the show method. And you say dialog and show. And in this way, it's going to be shown non-modal. Okay, this is what is meant here. So if we run, we're going to have the thing here. And if we do, you see that now we can manipulate the parent window without a problem. So this is going to be a choice you need to make. Do you want your dialog to show modal or non-modal? So let's go on with the plan to use it as a modal dialog. Again, if you ask how I know these things, I read the documentation. So I would really recommend going to the documentation, saying Qt dialog. And if you go to more information, you're going to learn about all these things. You see, they talk about modal dialogs, default buttons, and all kinds of crazy things you can do with dialogs. This is your best source of information. All I am doing here is giving you the basics to give you the confidence to feel like you know enough to be dangerous and learn even more than I can tell you in a course like this. So let's use our model section here, show the dialog model. We should say this, the dialog model. So we're going to do exec, but if you go to the documentation for exec here, let's do F1 and open in help mode, shows the dialog as a model dialog, blocking until the user closes it. The function returns a dialog code result. We want to use this result here. And we can click on this to see what can be returned here. So we can return whether the dialog was accepted or whether the dialog was rejected. We're going to use this. So we're going to say auto ret, and we're going to say equals, and we're going to be grabbing the return value in this ret variable here. And we can check and see if ret equals Qt dialog accepted, and let's double check the documentation. If the A is capitalized, yes it is, because these things can be confusing. If it's not accepted, it is rejected. Okay, and we want to do something else. Now, if the dialog is accepted, we want to do a bunch of things. We can store a bunch of strings here. So we're going to grab the position and the OS. I think the method to get the position from the dialog was position. Okay, it is here. And we have favorite OS. This is the method we generated in the dialog. If you go back again, you're going to see that we have position and favorite OS. This is what we are trying to use here. And we can split these guys on separate lines so that we have a better chance of following up. Okay, so we are going to grab the position from the dialog. We're going to grab the favorite OS from the dialog, and we are going to set this information in our information label. If you remember, if we go to widget UI, we had a text label here that is going to show the information. So that's what we're going to be doing. We will set this information to be shown in our info label component. We're going to say your position is position and your favorite OS is OS. And this is going to be shown in our user interface. If the dialog was not accepted, we're going to say that the dialog was not accepted, and we can say that in our UI here. So we're going to say UI info label. This is bad design, but you can do that. We are learning here. So set text, we're going to say dialog rejected. Okay, we can do something like this. And now if we run, we're going to be able to fully use our design here, and this is going to be really cool. So let's do that. We're going to provide info. We're going to show the dialog model. So if we do here, that's not going to work. But if I say manager and I say I like Windows and say okay, you're going to see the information shown here. If I run again and reject, you're going to see dialog was rejected, and we are now able to create our own dialog and use it to do all kinds of crazy things, and this is really cool. Now we can also choose to show this dialog non-modal and still capture information from the dialog when the user hits OK or cancel. So to show that off, we're going to comment out our model code here. Okay, so what we are going to do here before we even show the dialog, we're going to do a bunch of connections here. This is the strategy we're going to use here. So we are going to connect to the accepted signal of the slot, which is going to be called when we call the accept method in the dialog here. So this is what we are doing in our widget CPP file. And we will respond to that using a lambda function that we are doing here. Don't worry about these errors. I think we can get rid of them by saying position. This is some code I had prepared, but I have changed my naming convention on the fly here. That's why we have these inconsistencies here, but we can fix this. So favorite OS. So the point was we are going to respond in this lambda function, and we are going to do the same thing we did before. We will grab the information and we will show that information in our info text level. Since we are using connections here, we are going to need to do another connection when the dialog is rejected. And it is what we are doing down here. So nothing complicated here. Now that we have done this, we can show the dialog. Okay, let's bring up the code to show it. And we're going to show the dialog here. Okay, when the dialog is shown, it's going to pop up on the screen, non-model, so the user will be able to still use the original window. But when the user clicks OK, we're going to accept the dialog. When the user clicks cancel, we're going to reject the dialog. And the connections we did here are going to trigger a call to this lambda function here and do all kinds of crazy things that we are doing in here. I really hope you understand this. So let's run this, and hopefully it is going to pop up an issue I want you to be aware of. So we're going to provide info, and we can see the dialog here. We can still see the original thing. We can even resize it, which is really cool. If we do manager and say Linux, for example, and hit OK, we're going to see the data, and we have the data on our debug output here. If we do again, we're going to do Mac, or we don't even want to select anything. We're going to do cancel. And it is not doing anything, but it is saying dialog rejected here. So what we can do is go back in our connection for the rejected signal and do the exact same thing we did before. For example, we can copy the code and put that in here. And if we run, now we should see when the dialog is rejected. Let's run and do cancel, rejected. We can see that right here. And I am just trying to show you different ways to work with these things here. Now, sometimes you will need to raise this dialog and activate it so that it has focus. We didn't have that issue here, but I have had those issues in other applications that I have built. So to really make sure that it is going to show up, you need to do dialog, raise, I think we have this method here. And you need to say dialog, activate window. I think we have those methods here. Activate window, this is going to give it focus. So that you can type, and the keyboard strokes are going to be put in this dialog here. And the raise method is going to put it on the top. Okay, this is what we are doing here. So let's run. Again, I do encourage you to look up all these little methods we are using here in the documentation, because at this point, I think you are mature enough to be able to look up some of the things we are talking about here. And I really can't stress enough how important it is to be able to use the documentation. You're going to save yourself days, if not weeks of frustration, because everything is really explained in there. Let's provide info, and we are going to choose Mac this time. We are a manager, or let's see if we are empty. Okay, let's leave the position empty and hit OK. You see it's rejected because if you remember, in the CPP file, we only grab information if the position is not empty. This is really cool. Let's run again. We're going to provide info, and we are going to say Windows, and we want to be a manager. Why not? And we're going to say OK, and it's going to work. Okay, if we provide info, the dialog is going to be on top and it's going to have focus. This is what we have ensured, at least tried to ensure, by issuing a call to raise and activate window here. This is really all I had to share in this lecture. I apologize, it turned out to be a bit lengthy, But we had a lot of things to do, for example, to set up our own class and make sure we do all the wiring to get the design we really were after. One thing you should remember is really that you have the option to either show your dialog model or non-model, and you should know by now what that means. We are going to stop here in this lecture, and I will see you in the next one. In this lecture, we're going to look at the QDialog button box class. And this is a class that allows you to arrange your components in a way that you are going to respect the rules of styling of each platform where your application is going to run. Here is a screenshot of the documentation for Qt. You see that for different desktop environments, buttons are laid out in a different way. For example, there is this group of buttons here. There's this group of buttons here, and you see that they are laid out differently on the GNOME desktop environment. On KDE it's different, on Mac it's different, on Windows it's different. So if you want to lay out your buttons in a way that you conform to the style of the desktop environment where your application is going to run, QDialog button box is going to be your friend. Okay, so this is what this component does. And when we use this component, we don't have to worry about the layout of the buttons. We only specify if we want them horizontal or vertical, so you can use this component in vertical or horizontal mode, and the rest is going to be decided by the operating system. I have to say that this is just a way to lay out buttons. It doesn't really work for complex user interfaces, and you can use this if you want to take advantage of this feature. To use this component, you drag it and drop it on your form, and once you do that, you have a bunch of properties. For example, if we go to QDialog button box here, we see we have the option to specify which buttons we want this button box to have. So for example, if we want the save all button, we're going to put that here and check it. If we don't want a button, we're going to uncheck it, and this is going to work. I know this may be cryptic, but in a minute we're going to head to Qt Creator and play with us. Another thing I want you to know is that to respond to each button being clicked, you have to set up a simple slot, and it's going to be one slot. You see here we have on button box clicked, and we have a pointer to the button that was clicked. What we do in this slot here is we grab that button. So we're going to say UI button box standard button, and we're going to get a standard button here, and we're going to check which button it was. So if it was the OK button, we're going to do whatever we need to do. If it was the cancel button, we're going to do whatever it is we need to do. And we can handle all these different buttons to do whatever it is we want to do in our application. For example, if it's a no button, you're going to do whatever makes sense in your application. If it is a retry button, you're going to retry to do whatever it is the user was trying to do. I hope you get to the point here. Now that you know this, I think it is time we headed over to Qt Creator and played with this component. Okay, here we are in Qt Creator. We are going to create our project. It's going to be a Qt widgets application as usual. We are going to give it a name and save it somewhere on our drive. Let's hit next. It's a CMake project, and it's going to be based off QWidget like we usually do. We don't want translation. We want the MinGW kit, and we don't want the Git version control system. So we're going to opt out of that. Our project is going to be generated. So the first thing we're going to do is really mimic what we did before in the last lecture. And what I think we should do, instead of recreating the classes and going through the process to do all that, we can go to the last project, QDialog demo. So let's go where it is. Let's find the source files. And we are going to right click on the main CPP file and do show in Explorer. I think this is going to work, and it is a good way to reuse your code and not have to redo what you have done before. So we're going to steal info dialog, all the three files, the header file, the CPP file, and the UI file. I think this is all we need here. So we can copy these. I am going to close out of this, and I am going to go back in my current project, which is QDialog button box here. You can see the name of the project, and we are going to right click and show in Explorer. And we are going to crack this open and paste in these three files. And what I am going to do, we are going to go back to the cmake list.txt of the first project we did, and we will steal these files. I don't want to type all this. I am that lazy. And I think I can close out of this. I have copied whatever it is I needed. And we can go to our cmake list.txt file and paste these in. Because we have copies of these in this project here, let's expand everything so that we see what is happening. We are going to rerun cmake. And we should have these files now as part of the current project. And we are going to modify this a little bit by using QDialog button box. We're not going to redo info dialog from scratch like we did before. We are going to use QDialog button box here. Let's go to the widget UI file where we are going to create an instance of that button. And we are going to put in a button. Let's say show info. You can put in whatever you want. And let's give it a name, show info button. This is a good practice. Name your components. You're going to thank yourself for that. So show info button. And we are going to respond when this guy is clicked here. So let's go to slot. We want to respond when it's clicked, and we are going to do OK. I think we should lay out these things nicely. So let's do a vertical layout. This is going to do, and we can resize this a little bit. We don't want to do anything fancy. Now, in the implementation file of the widget, we are going to create an instance of info dialog. So let's do that, info dialog. And we just want to say info dialog. We want to create an object of this. And we're going to say new info dialog. And we want to give it a parent of this. And once we do that, we want to do dialog show or exec. Let's show this model. Okay, any of these is going to do. Let's run and see what we get. We're going to get exactly or something that looks like what we had in the last lecture. And this is going to save us a few seconds. Compilation is good. If we do this, we're going to see this pop up just like in the last lecture. Now, what we're going to do is go to the UI form of info dialog, and we're going to take out everything. Let's take out everything. I think we can kill the layout here. We can kill all the layouts. Click on any component and click on this little button here that says break layout. So we're going to break the layout. We're going to break this layout, and we are going to clear everything out of this component here. I think we can do Control A and hit the delete button. Every component in this form is going to go away. We want dialog button box, and if you look on the left here, we already have it. You can see it right here. So I am going to drag and drop it on the component on my UI form, dialog button box. Okay, so let's do that. And you see the class behind this component is QDialog button box. So let's go to the documentation and look at this. And we can go to help and type in QDialog button box. Okay, we wanted this. And if we go to more, it's going to tell you what this class does. Dialog and message boxes typically present button in a layout that conforms to the interface guidelines for that platform. So different platforms show buttons or groups of buttons differently. And this is just a way to plug into the style of the operating system or desktop environment where your application is running to make things show up better. For example, here you see examples on different environments, and your buttons are going to behave according to the rules of styling of the environment where your application is going to run. And I think down below they are going to give you a few examples. You can see pieces of code you can copy. This is how you can create this guy in code, but we are just going to use the one on the UI form. I think this is going to do better. And now we have this little guy here. If you wanted, you could put some text here. Let's go and grab a label. Okay, so you can put some text here just to make this a little more fun. Okay, you can do something like this. And do you want to continue? And you can give the user the option to say okay or cancel. And let's put this in a vertical layout here. So let's click on the form and do vertical layout. And we are going to bring this all the way to the top. Okay, we can do something like this. And if you run now, I think we should clean up a little bit, because in info dialog, there are a bunch of slots we don't have anymore. Okay, we don't have these components, and we don't have the OK button anymore. We don't have these guys anymore, so we can take them out. And if we go to the header, we don't have these buttons anymore, so we're going to take them out. But I think the rest is going to work as it did before. So let's try to compile and see if we didn't introduce any problems that we haven't noticed. Since the build is good, we can run. If we do show info, we're going to see, do you want to continue? The user has the option to click OK or cancel. Now, I want you to see how you can add other buttons in this button box if you want. For example, you can click on this component here. If you go to properties and go to standard buttons, I think we have an option for standard buttons. You see, we have the OK button and the cancel button checked by default. But if you want, you can do save. Let's check this. And if you do, you see that we have a save button. Suddenly, we have save all. You can check this. We have open. We have really a lot of buttons. And you can add these guys to respond to whatever makes sense in your Qt application. In this case, it doesn't make sense to handle them more, but I think we can do this just for the fun of it. Now that you have these buttons, you can run. Okay. And if we do show info, you see we have all these buttons here. Now you must be asking, how do I select which of these buttons to show in code? We can go to the documentation for this little guy again, and you see when you create a component for dialog button box in code, this is how you would do it. You will specify buttons that you want here. And you see they say by default they want the OK button or the cancel button. So you can keep adding other buttons by logic, by bitwise or eng with all the buttons that you want. For example, if you want the save button, you can do that. If you want all other buttons, you can add them in code and they are going to show up. And how would you respond? Well, you can connect slots to the signals just like we are doing here. You can give this a try if it is something you would really want to do. But for now, we're going to go back to our code and we are going to respond when our dialog button box is clicked. And you see we have an option to go to slot when we right click on this guy. So we can do that, and we want to respond when this guy is clicked. Okay, so we are going to respond when this guy is clicked. And why do we have this problem here? Let's go to the top and make sure. Let's include Q abstract button here so we can copy this to save some typing seconds. And hopefully the problem is going to go away. Let's include this guy and see if Qt Creator gets to be happy. It is happy, and it should be happy now. So what we are going to do, we are going to check which kind of button was clicked. And you can ask your button box which kind of button was clicked when we hit this slot here. And we use the standard button method. And again, you can read the documentation to find this out. We're going to store this component here, and we are going to check and see which button it actually was. If it was the OK button, we are going to accept the dialog just like we did in the last lecture, and we are going to say OK button clicked. Let's see if this works. Let's run. We should see a message on the console. So application output should be opened when we click OK. Show info, we're going to see this. If you click OK, you see that you know that OK was clicked. Now we need to respond to save all, open, and cancel. So let's do that. All we have to do is copy this, okay, and go in here, and we're going to say save. I think we have this option here, and we're going to say save button clicked. Nothing special really. We're going to go down. We don't need to accept for save. We can leave it as it is. You can do whatever makes sense in saving in your application. So we're going to say save all. I am just showing you different ways you can respond to those buttons being clicked. Save all, I think we have this option, so let's do save all here. And we're going to go down, and I think we have cancel also. When they click cancel, we don't want to accept on save all, but we want to reject the dialog, if you remember this from the last lecture, when the user does cancel from the user interface. So cancel button clicked, and we can run and try this out. Okay, and what we do, click show info. Okay was clicked, show info, save was clicked. It's not rejected or accepted. Save all clicked. Open is not handled, but cancel is handled, and you see the thing goes away. So what didn't we handle? Open. So let's do that. And open is between save all and cancel. So let's do that, between save all and cancel. We're going to put the open button to respond to everything we have on our user interface. So let's do open. I think this is what we have to do, and we have open button clicked. And if we run, let's open application output here to be able to see what is happening. Show info, okay clicked. Show info, open button clicked, but it's not going to close the window because open is not doing anything. It is just debug outputting this message here. But if we hit cancel, the dialog is going to go away. This is really how you would use this. On different operating systems, you're going to see these guys laid out differently. One thing worth noting here is that by default, the operating system is adding the space here. Okay, and this is a benefit we are getting from using QDialog button box. If it was just a bunch of your own buttons, it wouldn't work this way. And on some operating systems, this might not be the case, so buttons may fill all the available space here. So this is going to depend on the desktop environment where you are running your application. And the QDialog button box allows you to ignore all those choices of different operating systems and do things in a unified way, and your buttons are going to show up in a way that makes your desktop environment happy. I think that's the best way I can put it. This is all I had to share in this lecture. I hope you found it interesting. We are going to stop here in this one, and I will see you in the next one. In this lecture, we're going to learn about the QFileDialog class. And this is a dialog that allows users to select files, directories, and things on your operating system. Here we have an example of one you can use to open a given directory if you needed that in your Qt application. And it is really simple to set up. So here is a simple example of how you can do that. You can call a static method on QDialog, and this is going to give you an existing directory. You see we give it a parent. I think this is a parent. You tell it the text it is going to display. You tell it the directory it is going to open by default on your system. This is what it is. And you specify how you want the dialog to behave. If it shows only directories, if it shows system links, and things like that. And we can print the directory that was chosen. We're going to run this in Qt Creator in a minute, and you're going to see how this works. Hopefully now you are getting a hang of how to work with Qt, and it is a really great framework. Here we see how we can get a file from the system. I think this is what this method does here. So you get a file that you probably want to open and do things with in your Qt application. And you say get open file name. The rest is really the same. You specify the extensions for the file here, and this is just the syntax you have to follow, and then you can print that file that the user has chosen. And one thing I should specify is that most of these guys are going to return a string that you can then work with in your Qt application. Here is an example of getting multiple files. Okay, so this is something you can do if you want. You're going to specify the parent, the text in the dialog, the directory it's going to open by default, and a list of extensions you might want this directory or this file dialog to handle. And once you run that, you are going to get the result as a list of strings or a string list. This is what this class does here. You can print the string list immediately, or you can loop through it, printing each string in the group. You can do whatever you want here. Here is how you can get a file you want to save, and this is a way you can implement the save as functionality. You can use this method, and it is going to initiate a dialog that is going to allow the user to type in the name that you would like to save the file as. I think this is the use for that. Okay, this is really all we have to talk about in this lecture. So let's head over to Qt Creator and show this in action. Okay, here we are in Qt Creator. We are going to create a new project. It's going to be a trusty widgets application. Okay, we're going to name this QFile dialog. We're going to save this somewhere on the drive. It's a CMake project. We want to base this off QWidget. We don't want any translation here, so we are going to choose MinGW as the kit. We don't want Git as the version control system, and we are going to generate our project here. Let's wait for it to come up. So we are going to go to the UI form and put in a button. I think a single button is going to do, so let's do that. We're going to grab a push button and say choose. And we're going to say choose button. We're going to give it a descriptive object name. And we are going to lay this in a vertical layout on this component here. We don't want this to be any more complicated. We are going to attach a slot to it. Okay, and we want to respond by initiating a dialog to do all kinds of crazy things here. So let's go to the documentation and look at QFile dialog. I think this is something good to do in this lecture here. So let's go to more. And this class enables a user to traverse the file system in order to select one or many files or a directory. And this is really the best way to put it. You can use a bunch of static methods, for example, get open file name. This is something I showed you in the slides. We can do all kinds of crazy things, but I think if we go to the top, we're going to see all the static public members that we can play with. So we have get existing directory URL, get open file content, get open file name, and you can really play with this. If you want to have more details, all you have to do is to click on either of these, and they are going to tell you what it does and things you should really know. What I am going to do is pop up a few of these dialogues and show you how they look. Let's go back to our code and include QFile dialog first. QFile dialog. And we want to try out get existing directory. I have some code prepared here to speed things up a little bit. I don't want you to waste time watching me type all this. So let's use the code here. So we're going to get a string from get existing directory. We're going to specify the title for the dialog. This is where this is going to go by default, but if it can't, it is going to choose a location on my operating system. This is something specific to Linux, this way of writing paths, but I think we can even leave this. Let's look at the documentation for this. If we don't have any default, so let's hit F1 while we have this selected, and we are going to see that the directory is an empty Q string. Okay, this is the default location where it's going to go. So we can also put in a Q string or an empty Q string. So let's do that. We're going to say Q string and make it an empty one, stealing ideas from the documentation, and this is really cool. So let's do that. Because the path I had there was really Linux specific, and I don't want to confuse you here. So let's run this. When we run this application and click on the button, we are going to run this thing. This line is going to pop up a dialog, and depending on what we do with that dialog, we're going to get a string. Okay, if you choose a directory in your system, the path to that directory is going to be returned into the string we have here. The path to that directory is going to be returned into this string here, and we can print it out to see what is happening. Let's run to really give you an idea of how this works. Let's go to compile output to see the process of our build. The build is good. We have this running already. Let's go to application output and bring the application again. If we choose, we're going to see something pop up. And the first thing we see is the title of this thing. Okay, the title is right here for the dialog, and it is what we specified here. Don't worry about the TR here. This is a way to make your strings translatable, but you can leave out the TR here. Actually, let's go back and do that because I don't want you to be confused. Some of you are going to ask, how do you do that? Okay, and we can do something like this. And if we run, okay, and you see your chosen dir is empty because we didn't choose anything. How creative. So we're going to run this, and if we don't choose anything again, we see empty because we didn't choose anything, so the string returned here is empty. And if we run again and choose a directory somewhere, it's going to store that in our string. So the first thing you see is that it's going to open this in a direct. The first thing you should notice is that by default, this is going to open this in the directory where our binary was built. And if you want, you can specify a default location, and you're going to put that in this string here. And there are ways to get standard paths in your operating system, and you can do a search to find that out if you really want to go that far with this example here. For now, I am going to go in my C drive, why not, and choose, let's choose something. Let's go in Ninja, for example. Suppose I want that folder, and you see it's going to say the folder that I have chosen. If you wanted to be a little bit safe, you would do something like this. You would go down and say, if not dir is empty, okay, and you would put a message like this, and else you do something else. For example, q debug, and say you didn't choose any folder or anything. You didn't choose anything. I think this is much more generic. Okay, you can do something like this if you want it. And let's clean up a little bit before we run. And if you hit the green button to run, now we are going to choose, and if we do, let's go to C again and choose our trusty Ninja folder, and we're going to see that it was chosen. If we do this and don't choose anything, we're going to see you didn't choose anything, and this is something you might do in your Qt application. So let's bring this up again and show you the title. I don't think I really emphasized that enough, so let's run and look at the title here. So a few things to note is that the folder you select is going to show up down here. The title you specified right here is going to show up in the title bar of your window. And yeah, I think this is really all you need to know about. If you select a folder and the folder doesn't have any problem, the return value from this dialog is going to be stored in our string here, and we can use it in our program. I think this is really all there is to talk about here. So let's comment this out and see a bunch of other methods we can play with. We can get open file name, and let's make sure this is not commented out. And again, if you don't want to type all these things, you can either go to the documentation and steal from the documentation. That's a perfectly legal and a thing. That's a perfectly good way to learn from these things. You can see a bunch of examples you can copy and paste in your code, or you can just copy from the resource section of the course. I am going to share the source code here on GitHub, and you can download and do whatever you want with the code here. So get open file name. Again, we give the same pieces of information. Let's take out the tr thing here to not confuse you, and we are going to use the default, let's say q string. Here it's going to be an empty q string, and we can run this, and this is going to let the user select a file that you would probably want to open in your application and do things with. That's how you would use this dialog here. Let's run. Okay, we see the thing here. We can choose, and it's going to say open file. Again, this is the title. Let's bring this thing down a little bit so that you see. So the title we specify here is going to show up here in the dialog. If we go in and select something, a file, it is going to show up here. And if we hit OK, that file is going to be, or the path to that file should be specific, is going to be stored in this string here, and we can do things with it. So for example, let's go to my C drive again, and let's go to Ninja and see if we can find any file in there. We don't have any file in here. We only need images here. So this is something you should be careful about. When you use this dialog, you specify the extensions of the files that you are looking for, and this is pretty cool. So for example, we need PNGs. So let's go in a folder where I have images. I think I have a few images on my desktop. Don't laugh at me. I have funny images here. So let's do open. And you see The path is going to be printed out here because we grabbed it. And this is something you can do if you wanted. We're not going to do error handling because you already know that. So let's comment this out and look at the next dialog type. We can put out. We can also let the user choose multiple files. I think that's a funny thing to look at, or a more interesting thing to look at. Not funny, sorry for that word. And you use get open file names, and it is interestingly similar to what we did before. Let's take out this and say QString to be consistent with what we have been doing in this lecture here. So QString, and we don't want TR, I think it's already taken out here, and you can specify the extensions. You see, you can choose images. This is how you can put multiple things. You can say you can also handle text files, you can also handle XML files. You can do all these things here. And let's comment out the for loop here to just show you that you can also print a QString list immediately. So let's do that. Okay, and we are going to run. And if we do choose, making sure application output is shown here so that we can see our things. If we do choose, we can go to desktop and choose several files. For example, this guy and this guy and this guy and this guy, we can choose them and we can do open. Now you can see that my chosen files are stored in a list, and we have the first one, machine specs, we have the second one, officer, we have the third one, review, we have the fourth one, subs. You can do all kinds of crazy things here. Okay, so if you wanted, you could loop through the list with your own loop and print each of these guys. This is something you could do. And your chosen files, not your chosen file. Sorry for this. So let's do that. We're going to run, and this is going to come up. We're going to choose, and we can go on my desktop and choose a bunch of files here. So let's do this and open. And you now see that they are printed in my list here. And this is something you can do. You have to do whatever makes sense for your application. Let's comment this out. I think we have one last thing I want you to see. And that is that you can use get save file name. And these names can be a bit confusing. Sometimes I had to play with these in code to make sense of them. But I think this is what you use when you want to get the name you want to save a file under. Okay, for example, you are doing things in your application and you want the user to save. So you're going to pop up this dialog and let them specify the name you're going to use to save that file, if it makes any sense here. So let's take out the TR thing here. Again, I don't want this to confuse you. For this, we can use the default. I think this is going to work as well. QString, and we don't want anything fancy here. And this is going to be looking for ways to save images. And we are going to print out the name chosen by the user. So let's run and see how this behaves. We have the thing here. We can go up. If we choose, we're going to see a dialog. Okay, and we are going to go in a folder. For example, let's go to desktop. Let's go to my desktop. And then I am going to specify a name. Let's say some file.png. And if my application was handling images, I would save my thing under this name, under the path that I have selected here. And if I do save, you're going to see that it's going to go in my folder and specify the name of the file and the extension. This is really how you would use this path to save data in your application if your application is doing some saving. This is all I had to share in this lecture. I hope you found it interesting. Let's stop here and I will see you in the next lecture. In this lecture, we're going to look at the Q font dialog. And as the name says, this is a dialog you use to choose fonts for use in your application. And if you pop it up, you're going to get something like this, ready for use. So you're going to let the user choose the size, the font style, and the font, and all kinds of crazy things here. Once you have this popped up, this is going to return a font, and you can use it in your code. Here is a simple example of how we are popping up a font dialog. We use a static method getFont. We specify a Boolean variable that is going to store the result, and the result is going to be whether we have a valid font or not. So if we have a valid font, we're going to grab the font and use it. This is what we are doing here. If we don't, we're going to put some message out saying that the user didn't choose any font. This is really how you can use this. And we are going to apply the font to a label that we will have on our user interface. This is really simple. So let's head over to Qt Creator and show this in action. Here we are in Qt Creator. We are going to create a new project. It's going to be a widgets application as usual. We are going to give it a name and save it somewhere on our file system. It's going to be a CMake project. We want this to be based off QWidget, and we don't want any translation thing. We will use the MinGW kit, get rid of the Git version control system, and we will finish here. And the first thing we want to do is to go to the UI form that is going to be generated for us. We're going to add a label. Let's grab a push button first. Then we're going to search for the label because I can't find it on my own. And we're going to say label, and let's say some text here. Okay, and if we want, we can change the font in the UI here. For example, we can say, let's give it a size that is a little more visible. Let's use 12 here. Okay, if we do that, this is going to be a bit bigger. We have our button, and we're going to say choose font. And we are going to give it a good descriptive name. This is something you should do by nature. So choose font. And we are going to put these guys in a layout. So let's do something like this. I think this is going to do. And we are going to respond when this button is clicked. So let's do that. And we want to go in the documentation and look at Q font dialog. And we're going to see what this dialog does. So a font dialog is created through one of the static get font functions, and you can see where I got my example here. Okay, you're going to pop it up, and if the user chooses, the result of the dialog is going to be stored in OK, and that result is going to be whether the user has something useful from the dialog or not. If we have something useful, we're going to use that. If we don't have anything useful, we're going to put out some message or just ignore the thing coming from the dialog. Okay, so they also say a bunch of things here, but what we really want to do is to grab the font and use it to do things. I think we can even copy from the documentation here. I am using the documentation here not because I am lazy and I don't want to do other examples, but I really want you to see that the documentation is an invaluable piece of information if you are going to be using Qt. I use this as much as I can. So let's just paste in the code here, and we're going to adapt it. So let's do Q font dialog. We're going to include that Q font dialog. And what we are going to do, you see, this is going to work immediately. And if you want to know these parameters, you can just look at the documentation. So let's do get font F1. You're going to see that the first thing is the OK button, and it is a pointer. So that's why we pass the address of this variable here. So we have an initial font, which is the second parameter that we are passing here. The third thing is going to be the font size, I think. And the font is going to also have a font size. Let's see, what else do we have here? We have a parent, okay, which is this pointer here. Okay, in this case, it is null pointer by default. You can specify a title, you can specify a string, you can really specify all kinds of crazy things. And you can read about this to see how to use this static method here. So what we're going to do, when the user selects the font and we know we have a valid font, we're going to say UI label set font. I think we can say set font. We have a way to set a font to the label, and we will pass the font. How cool is that? And if they don't select a font, we're going to debug output a message. So let's do that, qdebug, and say user didn't select any font. We can say that, qdebug. See how I am using the building blocks from the documentation? This is something you should take advantage of. So let's say user didn't choose any font, and we should be done here. Okay, so let's run. We're going to run this and see if it actually works. We should see the font we have selected applied to this label here. And let's say choose font. Okay, select font. You see we have this thing here. And please take some time to appreciate how easy it is to use these dialogues. try to think about the work you would have to do if you had to set up something like this on your own. It's not really hard to do it, but it is going to take your time away. And here we are just using the components provided by the Qt framework. So let's choose one of the fonts here. I think I am just going to change the size so that we see what is happening. Let's make it 28. And if we do 28, and this is really cool, we can apply a font that we get from the font dialog to our label, and this is really cool. If you want to learn more, I encourage you to use the documentation and really try to turn these things up and down to really make sure you can make them do whatever it is you want. We are going to stop here in this lecture, and I will see you in the next one. In this lecture, we're going to see how to work with the QColor dialog. And by the name, you can see that this is a dialog that is going to allow us to choose color in our Qt applications. And if you have gone through all the lectures in the chapter, now it must be becoming second nature that we are going to use a bunch of static methods to choose colors. So here is a simple example of how you can initiate the color dialog. You are going to say QColor dialog get color, and you will specify the default color that is going to be in your color dialog. You will specify a parent, and you will specify a piece of text here. And the color the user chooses is going to be saved in your QColor object. And the QColor is simply a class that allows you to work with colors in Qt. If you want, you can check the documentation to learn more about this class here. And here is a check we can do. If the color is a valid one, we're going to set that. And in this case, we want to change the color of the text in the window. If you remember, we have used QPalette before. Remember, it is a thing you use to decide how your component is going to look. And in this case, we are interested in manipulating the color of the text and the color of the background in the label component. That's why we are using this label here. So once we have the color in the palette, we are going to set the palette to the label to get our color to be shown in our label component. So we can change the text color. This is what I am after here. We can also change the background colors, and it is really the same thing. The only thing is the kind of the palette that we want here. So the palette is going to be manipulating the background color, and we are going to apply the palette to the label. Now it is time to head over to Qt Creator and see this in action. Here we are in Qt Creator. We are going to create our Qt widgets application as usual. We are going to give it a name and save it somewhere on our drive. It's going to be a CMake project. The usual really, Q widget here. We don't want translations. We want the MinGW kit. We don't want to Git as the version control system, and we are going to finish here. And what we want to do is to set up a label on the UI form. The label which is going to be manipulated through our code, and we are going to manipulate the text color and the background color. And I think we can also manipulate the font. Why not? We know how to do that already. So we are going to put in some text. Let's say some text here. And I think we can give it a good starting font. So let's go to font here and choose 16, why not? 16 is going to be okay. And we want a bunch of buttons. So let's put in 3 buttons, and you're going to see what I use them for here. The first one is going to be manipulating text color. The second one is going to be background color. And the third one is going to be for the font. Let's really make this a bit interesting. We learned about QFont dialog in the last lecture. So let's say font here. And the text color button, we're going to give them descriptive names. So text color button, and we're going to say background color button, color, and we're going to say font button. So let's do that. And we are going to lay these guys out, but the buttons are going to be in horizontal layout, but I think we can also add a horizontal spacer to make this a little bit nice. So let's add that and put them in a horizontal layout, just like we do here. We are going to apply a vertical layout to the form by clicking, and then we are going to resize this and give this as less space as we can. So let's text color, go to slot. We want to respond when this guy is clicked. Let's go back to the UI form. This must be becoming second nature now. Go to slot, respond when it's clicked. go back, font, respond when this guy is clicked. This is what we want. And to manipulate the color, we will need to use Q color dialog, which is the main subject of this lecture here. So let's do Q color dialog. We can look at this dialog and you can learn all you want about this dialog, but we have a bunch of static methods we can use, and one of those is get color. Okay, we can use this guy, and if you call it and specify all these things, you can specify the initial color. It is white by default. You can see that right here. And again, the documentation in Qt is really priceless. We have a parent we need to specify, at least null PTR by default. You can specify the title, which is going to be empty by default. And there are color dialog options, and if you want, you can display them. And if you want to learn about these options, you can click on this, and it's going to show you these options. You can really dig more into these things if you need them, but the defaults are usually going to be okay. So let's go back in our code, and I am going to put in some code I had prepared. Okay, we are going to go on the text color slot here, and we need to include the Q color dialog for this to work. So let's do that, and Q color dialog. And let's resize this a little bit. So we are setting up a palette, and again, a palette is a thing that allows you to control the look of your component. In this case, we are interested in the looks of our label component here. So we are going to apply a palette to it. So we are going to grab the palette that is in there by default, and then we are going to get the text color for that label component. This is what we are doing here. So we are going to get the palette that was already in this label. So this palette is going to be an object in your program, and this palette is going to contain a bunch of things. One of those things is going to be the color for the text. So we are going to grab that color and store that here. Okay, and it is the color that we are going to be passing as the current color in the color dialog. Hopefully you can see the logic we are trying to do here. Now, we are going to initiate this dialog. The user is hopefully going to choose a color, and when they do, we are going to store that in our chosen color variable here. We are going to check and see if the color is valid. If it is valid, we are only going to modify that text color in our palette that we have here. So the rest is going to stay the same. We don't want to use a completely new palette because that's going to clean up everything we had before, because the text color is not the only component of a palette here. If you want to learn about QPalette, I do encourage you to read the documentation, but this is what we are using it for here. So the line here is just going to modify the text color in our palette, and the rest is going to stay the same. I really want this point to be clear. So we're going to set the color, and that's going to be our text color. It is what we are specifying here, and that's going to be our chosen color. Once the palette is ready with our new changes, we are going to reapply the palette to the UI level. Then we are going to say that the user has chosen a valid color. Let's say chose a valid color. I think this is much better. Okay, and this is really how this is going to work. Let's see how this works. Let's run. We're going to compile, and we can look at our compilation output here and see things happening. The thing is going to run. Okay, this is cool. And we want to click on text color. If we do this, we're going to get a color dialog, which is really cool. It's very colorful. And you see the default color is black at this moment. Okay, so this is the default. But if we wanted, for example, we can change the text color to green, or let's use, what do we use here? Let's use a bluish color. Green is cruel, so green was too harsh on my eyes. So let's do this, and you see the color is going to be applied to this guy. If we do text color again, you're going to see that the color we had in the palette is going to be as the current color. I really want you to say this. This is something many beginners ignore, but this is something you can do to make your application much more useful to your users. This is happening because we are grabbing that color when we grab the palette, and we are using it as the default for our color dialog that we are popping up here. I really hope this makes sense. So now that you know this, let's see how we can modify the background color of our label. Okay, let's go down and do that. We're going to put in a piece of code. We are going to grab the palette. Again, same logic, but this time we are interested in the background color, and we use QPalette window, this property here, to say that we want the background color, the color of the background, if I can say it like that. So we're going to grab the color and we are going to use it as the default color in our dialog. We will initiate the dialog with getColor. We will get the color chosen by the user in this variable. We check if the color is valid. If it is, we will set that color in our palette. Again, this is going to only modify the background color in the palette, and we will leave the rest as it is in this palette object. After that, we will reapply the palette to the UI level and we will see the changes. And if the user didn't choose any valid color, we are going to land here and put out this message. Let's run and see this running. The build is good. We can see our thing here. We can change the text color. Again, let's use this green here. So let's do that. We have the text color, but we can also change the background color, and let's use a white. Why not? Let's see how this works. Let's use a background color, and we're going to use the yellow. Let's see how yellow works. And this is not applying to our label. What is going on here? For this to work, we have to remember to set the autofill background property to true for the label. Let's do that. We're going to say UI label set autofill, and we're going to set this to true. And I think if we run now, our background color is going to be applied to the label. Let's do this. The build is done here. And let's choose a text color of blue like we did before. And if we choose a background color of orange, for example, let's do that. We will see that applied to our thing here. And this is really cool. This is something you can do if you want it in your Qt application. Again, the point here is to be able to use QColor dialog. Let's apply a font here. And you already know how to work with fonts from the last lecture. So let's include a QFont dialog. QFont dialog, and we will just put in the code to do that. Okay, we're going to get the font and we will apply that to our label. Nothing complicated here. And if we run, our application should be fully functional, and that's going to be really cool. So let's bring this guy. I think we can go to the UI form and bring this down. No need for this to be super long in width, and this is going to be enough. And if we run, this is going to show up much smaller. We can change the text color to our blue. We can change the background color to orange. Why not? And we can change the font to a... Why not? Let's make 48 and see how this works out. You can do things like this. This is really all I had to share in this lecture. I hope you found it interesting. We are going to stop here in this one, and I will see you next time. In this lecture, we're going to learn about QInput dialog, and this is a helper dialog you can use to choose values between a given range. For example, you want the user to specify a number between a given range. You can pop up this little thing, and it's going to allow the user to give you a number, and you can use it without having to set this up on your own. I think this is really overkill. If you need something like this, you can build it on your own. But again, my job here is to give you the possibilities. What you use and what you don't use is going to be your choice. Here is how you can use this little guy. You can also use it in text mode to let the user type something and you can get the value. I am going to show you how to do that when we hit Qt Creator in a minute. So you initiate this dialog by calling this static method here. So you pass the parent, you pass the text, you pass... What is this? This is probably the text that is going to show up in front of the number that you are going to choose. And I think this is the default value that is going to show up. And we will specify a range between minus 10,000 up to 10,000. And what is the value here? Maybe this is the steps. If you go up, it's going to go up by 2, by 2, by 2. And OK is the variable that is going to store whether you have something valid or invalid in this guy. The return value is going to be stored back in this D variable here. This is how you can use this then. You can also specify to use this in text mode. And it is going to really work like a combo box. So if you want, you can use it like this, and you can get the string and use it to do things in your application. And this is how you can grab the string. For example, you can set up a string list of things you want shown. You're going to pop up the dialog in text mode using the getItem method. You will specify the parent, the text that is going to show up in your combo box. You specify the string list. And if you want to know all these other parameters, I would encourage you to look at the documentation. I don't keep these in my mind. So if I really need to know what these parameters are, I look in the documentation. And using the documentation is not a weakness, it is a strength in my opinion, and I really encourage you to use it. Our minds can really store so much information, so make sure you just store pointers to information, if I can say it like that. And if you need specific information, you can just always check the documentation. Now that we know this, we're going to head over to Qt Creator and play with us. Okay, here we are in Qt Creator. Let's create our project. It's going to be a widgets application. We will name it QInput Dialog and save it somewhere on our drive. Let's use CMake here. This is going to be based off QWidget. Let's do next, next again. We want the MinGW kit and we hit next. We don't want get, and we will finish here. Okay, let's open up the UI form and we will put in a button that is going to trigger a call to our input dialog. This is really all we need to do. Let's change this to click. So let's go to the object name property here and say click button. This is a very creative name. So let's apply a vertical layout to this guy. And we can go to slot and respond when the button is clicked. And what we want is to use QInput Dialog. So let's do that in the documentation. We need to look up this class first. So QInput Dialog here. If we click on more, we can see different ways we can use this. And let's see. So we can use get text, get double, get item. You see, we have a bunch of static methods that we can use to play with this. But the examples I have shown you are just for get double, which is right here, and get item. But you see that you have a bunch of other choices you can play with if you really want to. Let's look at the example here. So we are getting text, and we will let the user type some text. I think this is what we are going to do. And down here, they have examples of how this looks. For example, if you use this in text mode, you will get a combo box. If you use this in double mode, you will get a number. If you use this in int mode, so this is int mode. I had reversed this. So this is int mode, this is double mode. And you can let the user type a piece of text. So you can really use this in different ways. So let's go to our code and use this in double mode and item mode. So we will get a double spin box and a combo box. Okay, let's go down and put in a piece of code I had prepared, which is going to look strikingly similar to what we had in the documentation. So let's include QInput Dialog on top, include QInput Dialog. We have this class here. And again, you see this works, but if you wonder what any of these parameters is, you can just hover over the method here, I should say, and you're going to see all the parameters. So what can we do here? Let's make sure we bring this down just to be able to see things nicely, and we will grab the screen. And you see the first thing is going to be a parent. This is what we see here. Okay, so this is our parent and we are passing this as a parent. The second thing is going to be the title. It is what we are passing here. The third thing is also going to be a string, which is going to be a label. It is right here, and our label is going to be amount. It is probably going to show up in front of our double spin box. The following thing is going to be the value that is going to be shown in our label. We will have the minimum value, which is going to be this. We have the max value, which is going to be this. And you can specify the decimals. And in this case, we want 2 decimal points. The OK variable is going to be a Boolean that is going to store whether we got something valid. And you can specify the Windows flags, but in this case, they are just using the default They are not specifying this. And you can see, if you really want, you can read the documentation and figure out these things without having to remember them all the time. Your mind or your brain is not a hard drive. Your brain is a CPU, and use it for computations and don't use it for storage. That's what I can tell you here. So let's go back and clean up. And now we can run. Hopefully now you understand what is happening here. Okay, so let's click. I didn't click. And you see we have a double spin box. Okay, and we can use this to choose a value. You see the default value is specified down here, is plugged in here by default. And if you want, you can change this. You can go up, you can go down, you can really do all kinds of crazy things. If you hit OK, you will get the value and you will get it printed out here. This is how you can use this thing. So this is going to give us a double spin box. Let's call this Q double spin box mode. And we are going to comment this out and use our input dialog in combo box mode. We will have a bunch of items we want the user to select from. So what we will do here is set up a string list of things we want the user to choose from. And we will pop up the dialog using the getItem method. We will specify the parent. Okay, this is our parent, the text, the label, the list of things we want the user to choose from. And you can read the documentation on all these other things. I am not going to do that for you. I really want you to be able to use the documentation on your own. And we will check if OK contains a true value, and if the list of things is not empty. When all these conditions are true, we are going to land here and print the item chosen by the user. Let's run and see how this looks. And we will click our trusty button here. Let's click. And you see we have a bunch of things here. So we can choose summer. If we click OK, we see that we chose summer. Let's run again and click. If we choose, let's choose winter and do OK, we're going to see this printed out here. We can choose again and do fall and do OK. We're going to see this printed out here. And again, I am getting these inspirations from the documentation. I just want you to be able to put things together. And please spend as much time as possible trying to use the documentation. Anytime you want to use something in Qt, please come in here, put the class in, and learn all you can about that component. That's going to save you a lot of time going forward in your Qt development career. We are going to stop here in this lecture, and I will see you in the next one. Congratulations on hitting the end of this Dialogs chapter, where we wanted to see ways we could show temporary information to the user. We show different ways we could do this. You could either go down and row and implement things on your own using the QDialog class. We saw how we could do that. We also saw a bunch of built-in dialogues we can use in our Qt application, and the choice is going to be yours. If you want to learn about this, again, I would recommend reading the documentation on QDialog. I have this opened up in my browser here. Let me resize this a little bit. And you can really see all the things you can do with this class by reading the documentation. For example, we saw that we could either open our dialog in a model way, and that's going to prevent you from using the parent window that popped up the dialog. And if you want the parent window to stay active, you can start your dialog in a non-model way. And we saw that we could do that using the show method in the chapter here. We are going to stop here, and I will see you next time. In this lecture, we are going to look at the Qt resource system. And this is a way we have to package files and other resources that our application may need to make them available in the binary executable. That way, the application doesn't need to browse through our file system to find things it needs. And as you might think, this has benefits and drawbacks. The benefit is that your application is going to find everything it needs in one place. It doesn't even need to go to the file system. Everything is going to be bundled into your application binary. But the problem is that this is going to increase the size of your binary very fast. So make sure you use this carefully. So resources in your applications are going to be stored in a file with the QRC extension. This is a Qt thing. And this is an XML file format that lists files on the disk and optionally assign them a resource name. And these files are going to be fetched through that name that we have in the resource file here. Here is a simple example of how a resource file in Qt might look. It is really simple if you know XML. So you're going to see the prefix thing here, and this is really a name under which you can go and find things. And you have seen that in the resource files I have created, I used this resource to mean that I need to go to the root of my thing and start looking for things. So if I need to look for this image, for example here, I will go in this location and look for images and for minions, and I am going to find this image here. I may set up other prefixes depending on what I need. For example, if I need my prefix to be file, then if I need this Qt icon file, I will do /file /images and go and find this image here. This is something you can do. So you may organize things, for example, in a logical structure according to where these things might show up in your menus. For example, this is what I was going for, organizing these files this way. Another thing I want you to see is that you can set up an alias, and an alias is a different name through which you can access a file. And why would you need something like this? So suppose we have our cat icon here, and it is going to be used when our application is running in English. But it is possible that when the application is running in French, we might need another icon, for example, showing the French flag or whatever. If you need something like that, you might set up an alias and you do something like this. So if the application is running in French, this thing here is going to be used. And when the user is looking for the cat icon, we are instead going to give me the cat icon specialized for French. You can do something like this with aliases, but I am not going to do that in the course here because we are really not doing translations, but it is a possibility to do something like this. Okay, this is what prefixes and aliases do. You can read this if you want. So the resource file you use in your Qt applications must be mentioned in whatever project file you have. If you are using Qmake, you will put that in the PRO file. If you are using CMake, that's going to show up in the CMake lists.txt file. And Qt is going to handle that resource file. It is going to generate a QRC application CPP file, which is going to have a binary representation of all the resource files you have in your application. And your binary is going to reference that binary section to get to those files. And that's how this works. We don't really want to get too much into the details of how that works. All we really want is to be able to use resource files in our Qt applications. But I want you to have an idea of how this works under the hood. Here is a simple example of what we might have in our Qt application. For example, we have a main window application. It's going to have a bunch of images. And once we create the resource file, we will remember to add that to our list of source files in our CMake list.txt file to make CMake know that it needs to care about this file here. This is what we are doing. I don't think there is much to talk about in the Qt resource system, so we are going to stop here in this lecture. In this one, we're going to set up a simple project and play with the resource system a little more. In this lecture, we're going to play with the Qt resource system, and we will create a project like this. So we will create a resource file, which is going to be wrapping around images in this images folder. And we will make them available in our main window application. For example, we will have a bunch of menus and toolbars. We can do all kinds of crazy things. So let's head to Qt Creator and do this. Okay, here we are in Qt Creator. We are going to create our new project. It's going to be a widgets application as usual. We are going to give it a name and store it somewhere on our drive. Let's use this as the default location because we are in a new chapter here. We want to use CMake as the build system, and we will base this off QMain window because we want menus and toolbars. Let's hit next. We don't want any translation. We want MintW, and we don't want get. Let's finish. This is going to generate the application, and it is going to be a bare bones main window application in Qt Creator. If we run, we should see an empty window pop up on the screen, and it is right here saying main window. Now we can go to the UI form and add a toolbar. If you remember, you have to right click. I think you have to go to the top here and say add a toolbar. This is going to give you a toolbar, but we don't want to play with this yet. What we want to do is to go to the location where we have this project. And we are going to do that by coming to the main CPP file, right click, show in Explorer. This is my trick to not have to browse through endless folders. And I am going to paste in my folder of images. If you want, you can get this folder from the resource section of the course. I am going to set up a Git repository where you can download these things. Now we have the images and we wanted to use them in our application. So what we can do, we can create a resource file that is going to be wrapping around those things. So let's do that. We're going to go to our project here, make sure you have this thing here selected, and let's right click and add new. We want to add a Qt thing, and we want to add a Qt resource file, as you see right here. So let's select this and we're going to hit choose. We are going to give it a name. Let's name this resource like we always do. And we are going to hit next. And we don't want to add this to Git. And we are going to finish here. And we want to copy the path to this resource file and add it to our cmake.list.txt file. Qt Creator is helpful here. And if we go to the project again, right here, okay, right here, and right click and run cmake, we're going to see the thing generated and we have our resource file. But what do we do with this file? But before we really do anything with it, I think we should look at this file here. So let's go and open it with another editor I have on my system here. And if we do this, we're going to see that it has some XML in here, doc type, RCC, things we don't really know about, but we can do things with this file. So let's come to the project again, and we are going to manipulate this in Qt Creator because this is a Qt thing. Most other applications are not going to be able to manipulate QRC files. So we are going to right click and say open in editor. The first thing you see is that we have a bunch of buttons. We can add a prefix. We can't add files yet because the Qt resource system needs a prefix. If you don't need to specify a prefix, you can do something like this. You can click add prefix and take out anything that is in the prefix line edit here and hit enter. What this is going to do is to create a prefix for you, and you can add everything under this prefix. So let's try and do that. So we are going to go in this prefix that is selected on top here. Okay, you can see it right here, the root prefix. This is what I call it. You can do add files, and you can go in images and add all the files in here. Let's say the quit action is going to be leaving under that prefix. We can do something like this, and we don't want to add it to Git, and it is going to show up under that prefix. But let's say we wanted to organize our prefixes like we have menus on the main window here. So let's go to main window and say we have a file menu and say we have an edit menu. You already know how to work with this, and we have a help menu. Okay, suppose we want to organize things in edit menu and help menu, and icons for the edit menu are going to show up under an edit prefix, and icons under the help menu are going to show up under a help prefix. This is what we want to do here, just to play with this thing. So let's go back to our QRC file, and we are going to add a new prefix. That's going to be edit. Let's see what this does. We will have an edit prefix. We will select it and add files under this prefix. So we can add files and go in images, and we want copy, cat, paste, undo, and redo. Okay, these things are going to show up under that prefix, and we don't want to get, you see, these guys are under a different prefix. We can set up another prefix, so let's add another prefix, and that prefix is going to be help. Okay, and once we have this prefix, we are going to add files under it. So we are going to go in images, and we are going to say help or about and about Qt. I think this is what we did. So let's do no to get. And now we have our things. And if we save, we can hit Control S and save this thing. Now, if we go back to our file system and go to resources and right click and open this in any editor that can open this, you see that things are now organized in these prefixes. And if you want to access the Qt icon image, your path is going to be /images/Qt icon png. If you want to access any of these edit icons, your path is going to be /edit/images/copy icon and all kinds of crazy things you see down here. And this is really what we can achieve with resource systems. And I wanted you to be able to see this. So what we can do now, we can go in File and add an action. We're going to say quit. Okay, we're going to go in Edit and do the usual copy. And we're going to add cut. We're going to add paste. And we are going to double click to add a separator. We want undo. And we want redo. And we can go in help and say about. And we're going to say about Qt. And do something like this. And now that we have done this, we will have a bunch of actions generated for us, and we can put icons in these actions. For example, the Qt icon, we can double click on it and go to the 3 dots here. Now you see that we have our prefixes. We have the edit prefix, we have the help prefix, and we have things living under the root prefix. So for the Qt icon, we want this guy in the root prefix, so we're going to add it here. And for copy, that's going to be living in the edit prefix. So we do images and we do copy. You can see that this is just a way to organize things in your resource system, and it is really cool. I wanted you to be aware of this. So we're going to do copy and cut. Let's not cut this out. I am going to do this live. Copy, cut, and okay, and we're going to do paste again, images, paste. We want okay. Okay, we can do undo, redo, and about. I am going to do these and come back when they are done. I don't want to keep wasting your time. Now we are going to do the about thing here. So let's go to the 3 dots and we are going to go in help because that's where these guys are going to live. And we will have about and about Qt. So let's do about here and okay. And we will do about Qt, double click, go to this guy and in help, we're going to do about Qt and we will have these guys available. Now, as you already know, we can just drag and drop into the toolbar here to make this nice and neat. So we can do copy, for example, and drop into the toolbar, cut, the same, paste, the same. We can add a separator by right clicking and adding a separator. Undo, we're going to drag and drop. Redo, we're going to drag and drop, and we will have a nice looking user interface using resource files that are grouped in prefixes as we did in our resource file. This is something I wanted you to see. So let's run this and see how this works. Compile output, we can look at this. And if we run, it's going to show up. If we do file, the Qt icon is going to be living in the root prefix. The edit menus are going to be living in the edit prefix. The help menu is going to be living. The help icons are going to be living in the help prefix. And you can organize things like this. So to make this a little bit fun, let's add a label. So what we are going to do here, we're going to add a text edit. Let's put a text edit just for the fun of it. So text edit, we're going to put this component here and we will grab a label. Okay, and we're going to say label here, and we can put these guys in a horizontal layout. So we can apply horizontal layout to this form. We can do something like this. And now we want to add an image that is going to act as a pix map to this label here. So let's go back to our resource file. We can go in and open this in editor like we did before. So we will select the root prefix. So before you add images, you have to select which prefix you want to put that in. We want this to live in the root prefix. So we are going to add files. And if we go in images, we are going to find a minions file. So we're going to add that. We don't want get here. And we're going to save. So if we do file and save all, this is going to be saved. You can hit Ctrl S to save this. Now what we can do in the CPP file, the constructor, is grab the label and apply a pixmap to it. And you see, we are going from the root prefix. This is what we are doing here. Again, if you want, you can go in the resource files and go in the root prefix, find the image you want. It is minions.png here. So you can right click, you will have a context menu, and you will see paths you can copy. So we're going to grab this and we will put that right here, so we can take this out and put it in here. And it is going to be loaded by the label because we set this as a pixmap and we want this to have this size here. This is what we are doing. We can run this and we should see our text edit and our minion image, and it is what we have here. So this is just an example of something you can do with the resource system of Qt, and I hope you found this useful. So thanks for watching. We are going to stop here in this lecture, and I will see you in the next one. In this lecture, we are going to explore different facilities we have to style our Qt graphical user interface applications. And what I mean by styling is things like colors, borders, and things like that to really control the look of your graphical user interface. Now, one of the basic styling classes we have in Qt is QStyle, and this is going to allow you to define how the application is going to look. You can use this class, for example, to control how your application is going to look on Mac, Windows, and different Linux distributions. You can use this class. One thing you should know, however, is that this class is a little bit involved to work with. There are a lot of moving parts you need to be aware of. And we are really not going to go into the details of styling in this course here. But I am going to show you the fundamentals and tell you things you need to be aware of as you work with styles in your Qt applications. So QStyle is going to look the look and feel of your application. The way your application looks is going to depend on your desktop environment. So things are going to look differently if you are on Windows than they look on Mac, for example. And here are a bunch of classes you can use to manipulate the look and feel of your application. This is not an exhaustive list, so you may have to check the documentation for a full list here. But we have seen already how you can use QPalette, for example, to control the text color. You can use QFont to control the font of the text. You can do all kinds of crazy things. If you go down here, you're going to find QStyle. And this is really a base class you can use to generate all kinds of styles in your graphical user interface application. Again, this is a bit involved and we want to go into the details of how you use this. But down below here, you can see a bunch of classes you can use to control styles in your application. And as you progress in your career as a Qt developer, you may need these things. And in most cases, you will need to read the documentation to know how all these little pieces come together. So if you want to set the style for your application, you may set it application-wise using the QApplicationSetStyle function here. You can also specify the style as a command line option when your binary is being run. So this is something you can do. If no style is specified, Qt will choose the most appropriate style depending on your desktop environment. And you can see that it is really flexible to decide how you apply the style to your application. You can apply it to the entire application, or you can use different widgets on which to apply your style. And this really fits into the design of Qt, because if you think about your Qt application, it's going to have a parent widget, and that parent widget is going to have its child widgets, and you can have an endless list of nested widgets between widgets. And if you want, you can apply the style to the entire application. So the style is going to be picked up by every child widget in your application, or you can single out a single widget on which to apply your style, and that style is going to be used there only. You can do things like this, and it is really flexible. So styles are not something you're not going to need a lot. You are mostly going to need this when you are designing your own custom widget, and you need to decide how that thing is going to look. But in my career as a Qt developer, I have been doing this for a lot of years. I have never had the need to write my style, but take that with a grain of salt because that is going to depend on your line of work. You may need to write these styles, and if you are down that path, I would recommend reading a lot on styles, and you're going to find a lot of resources in the Qt documentation. Now, QStyle is a bit involved, but what are we going to do in this chapter? Well, we are going to look at a few styling classes we can use to see how things work. At this point, we have used QPalette to control the text color of a widget. For example, we used QPalette to control the background of a widget, and we're going to do that in this chapter. But we are going to see that sometimes QPalette comes down short. And in some cases, it's not going to do what you want because the behavior may be inconsistent depending on the operating system you are using. So the results are not going to be very predictable. And if you need something consistent, you may need to use style sheets. And style sheets are something that is very similar to CSS in web development. If you have been building websites and whatever, you must know about CSS. This is the same thing we have in Qt, and we can use this kind of language, if I can call it a language, to control how each component in our application looks. Here is a simple example of how CSS looks. For example, you can say, I want every line edit in my application to have a yellow background. You can say something like this. Or I want the text in my checkboxes to be red. You can do something like this. Okay, this is the basic syntax for style sheets in Qt. You can set style sheets at application level, so you can set a style sheet that is going to be used by the entire application. You can set a style sheet to a parent widget, and that's going to be picked up by every child of that widget. So this is something you can do. Or you can say, I want this style sheet to apply on a single widget and specify that widget here. So again, we have a lot of flexibility in how we set style sheets to our Qt widgets application. Another thing you should know is that style sheets are loaded at runtime, so they are going to override anything you had in place to control the look and feel of your application. You should know that. Okay, this is really all I wanted you to know in this lecture. I hope you have an overview of things you can use to style your Qt applications. We are going to stop here in this lecture, and I will see you in the next one. In this lecture, we are going to play with the QPalette class a little more. And again, QPalette is a class that allows you to control different aspects of how the application looks. For example, you can control the text color, the background color, and all kinds of crazy things. We're going to see some of those things here. Another thing you should know is that each widget may be in different states. For example, if we have a push button, the push button can be active or it may be disabled. And these states have according styles that pertain to them. What do I mean? For example, if a button is active, we might want to give it a given color, and if it is disabled, it might have another color. And color is just one property. For example, we might want to decide how the text is going to look, how the background color is going to look, how the borders are going to look, and all these things are bundled into color groups of the palette. This is something I want you to know. And we are going to play with this in a minute. You're going to see what I mean here. Now, you can use QPalette to say which state your button is in. And we do that using this enum we have defined in the Qt framework. So for example, there is a palette that says that the button is disabled. There is a palette that says that the button is active. And we can use these different palettes. And again, you can think of a palette as a group of properties. So you can say, if the button is enabled, I want it to look this way using palettes. And if it is active, I want it to look this way. That's why we have these kinds of things here. And down here, we have a simple screenshot I stole from the Qt documentation. And the palettes can control all these things here. For example, we have a button text, we have the color of the button, we have 3D effects that apply when you hover over this and all kinds of crazy things. You can control all these things using QPalette. Here is a simple list of the things we can manipulate. For example, we can use QPalette window to manipulate the general background color. We have played with this. We can use window text to control the foreground color or the text color. And we have things like tooltips and tooltip text and all kinds of crazy things. You can really play with all these things if you need to go down to this level to control how your application looks in Qt. Now, to work with palettes, there is a bunch of things you need to do, and this is just a recommendation. You can use this if you want. What I like to do is to retrieve the current state of the widget. And why do I do that? Well, the palette is not just a single property. It's a bunch of properties that we are grouping into this palette. And in most cases, I am interested in modifying one of these, and I don't want to lose the others when I modify one I am interested in. So what you do, you retrieve the current palette that pertains to your widget. Once you have that palette, you can apply the modification to that palette. And for example, you can change the color from blue to yellow. Once you do that, you are going to reapply this modified palette to the widget of interest, and your changes are going to take effect, and you're not going to lose all the other properties you had in the previous palette, if this is making any sense. This is what I mean here. Here is a simple example of what we are about to do in Qt Creator. We will set up a widget and we will put in a bunch of buttons, 1 button, 2 buttons, and we will put a label. And what we are going to do, we are going to leave this button active, the one on the left, and we are going to disable the one to the right. And the way we're going to do that, we are going to go in properties and look for the enabled property, and we are going to uncheck this thing here. This is going to disable the button. Why do I do that? I want you to see different styles that are applied on active buttons and inactive buttons. And this is really the color group of the button. So we can then go in our code and grab the palette, for example, and we can modify it to have different colors. Again, we're going to do what we have been doing all along. We will change the text color and the background color of the label. We will reapply the palette to the label. But what I want you to see is that we can print the color groups and know if the button is active or inactive. And the way we're going to do that, we're going to grab the current color group for the active button. We will grab the current color group for the disabled button, and we will print these guys and see what we see on the console. So now that you know this, let's head over to Qt Creator and do this. Here we are in Qt Creator. We are going to set up a simple project. It's going to be a Qt widgets application. We are going to give it a name, save it somewhere on our drive, and we are going to hit next. It's a CMake project as usual. We want this to be a Qt widget application, and we will use MinGW here and say that we don't want get, and we will finish. This is going to create our project, and the first thing we want to do that I want you to see is to create these guys. So let's grab a label. This is going to be our text. We're going to say some text here as usual. Let's resize this a little bit, and we will grab 2 buttons. This is going to be the active button on the left. So let's say active button, and this is going to be disabled. And to disable this button, all we need to do is to come to the properties here, go all the way down to Q push button, and let's say active in the search here. If you are looking for something, you can come in this filter here and type something. So we're going to say active. Now we have an enabled property here. So this is what we need. We are going to uncheck this. And at the moment we do that, the button is going to be disabled. Let's give these buttons descriptive names. So let's take out the A here and go all the way to the top. The active button is going to be active button. The disabled button is going to be disabled button. Okay, we're going to do that, and we can align these guys. I think we can do that. So let's use a layout here, and we can resize this a little bit and apply a vertical layout. I like things to be nice and neat, so let's do that here. And what we want to see is apply a palette to this label and see it change the text color and the background color. That's something we already know, but we are going to repeat that here anyway because we are talking about QPalette. But another thing I want you to see is the color groups assigned to each of these buttons here, because that's going to be interesting to see. So let's go to slot and respond when the active button is clicked. And by the way, when a button is disabled, it's not going to respond to clicks. And I want you to see that this is a chance for me to show you that you will still be able to apply slots to those buttons, but if you click, nothing is going to happen. Let's try this. I think this is interesting. So let's do include QDebug, and we want to say active button clicked, and we want to grab the text here and go down in the other method, or slot, because this is a slot, and we're going to say disabled button clicked. Okay, we can run this and see what happens. And we want to see application output down below here. And when it runs, if we click active, we're going to see active button clicked. But if we click on the disabled button, we're going to see that we won't get any click because it's disabled. It's not responding. But if we go back to the UI and make it enabled, so let's make sure we go to this button here and enable it. Check this and run again and make sure we can see application output. And we can resize this. I think we can resize this to take as less space as possible and run this. I don't like clumsy user interfaces. So active, we're going to see it clicked. Disabled, we're going to see it clicked. We can see the message here. This is what I want you to see, and we are going to disable this again. Okay, now that you know this, we can go to the constructor of our widget CPP file and change a few things up. We are going to say we want to retrieve the labels palette. Okay, this is what we are doing. We are going to modify it and apply our changes. Then we will reset the palette to the label. This is a flow you want to follow if you need to manipulate palettes in your graphical user interface. So if we run, we're going to see that the window background is going to be blue and the text is going to be red. Hopefully, this is what we're going to see. Let's run and see what we get. Text is red, but the background is not applying, and hopefully you know why. It is because we didn't set the autofill background property to true. So let's do that. We're going to say UI label set autofill background, and we're going to pass in a true. And we don't need this comment. I don't think we do. So let's run this again and see if our blue background is going to apply, and here we have it. This is what we have. Now let's see if we can print the color groups of our buttons when the active button is clicked, because if you remember from our UI, the disabled button is not going to respond when we click. So what we are going to do is go in the clicked slot of our active button. Let's hide this. And we will take out the text here. We don't need this anymore. And we will put something in here. So what we are going to do, we want to grab the color group of the button, and we want to store that in this variable. Again, if you don't know what this color group thing is, you can select it and hit F1. You will be taken to the documentation and you can read about these things. Please use the documentation to your advantage. What I want you to see is different color groups that are going to be printed here. Let's run. And application output, we want this because our application is about to output something here. And it is right here, the application. If we hit active, we're going to see active button. It is an active button, but the disabled button, the color group is the disabled color groups. And this color group is going to have an assigned Q palette that decides how the button looks in a disabled state. I really hope this makes sense. And I want you to have these little pieces of information. And this is really all we had to do in this lecture. I hope you found it interesting. We are going to stop here in this one, and I will see you next time. In this lecture, we are going to explore style sheets. And style sheets are a way we have to style our applications in a way that is going to be independent from the operating system where the application is going to run. And if you are familiar with web development, this is going to be very similar to CSS or cascading style sheets. And it is going to be a texture specification of how you want the user interface to look. As we have mentioned in a previous lecture, you can set style sheets at the application level, you can set style sheets at a container widget level, or you can set style sheets on a specific widget in your Qt applications. The syntax is really simple. It is something like this. For example, you can specify that you want the Q line edit to have a yellow background. You can do something like this. You can specify that you want the text color of a checkbox to be red. You can do something like this. Now, here is something we are going to do when we hit Qt Creator in a minute. We are going to see that it is possible to set style sheets on your user interface components from the user interface form. So if you want to do things this way, this is an option, but it is also possible to do things in code. Again, you can set style sheets at the application level, and if you want to do that, you set the style sheet at your Q application object. If you look down here, you see we are setting our style sheet and we are specifying a textual representation of what we want the user interface to look like. So buttons are going to have a background color which is white, and they are going to have a red color for the text, I think. This is what we are specifying here. Again, this is done at the application level, and every single push button in our application is going to have a red text color and a white background. This is what we mean here. Now, we can also set this at the container level. Suppose we have a dialog class which has a bunch of components inside, and we set our style sheet on this dialog here. Every button in this dialog is going to be using this style sheet. This is what we mean here. But you can also target individual buttons and give them their own style sheet. So this is what we are doing here. We are saying this button in the user interface is going to have this style sheet, and you notice we don't even need to specify the class name because this is going to be applying to this specific button, but nothing prevents you from specifying Q push buttons. But I just wanted you to see different ways to do these things. Okay, now that you know this, we're going to head over to Qt Creator and play with this a little more. Here we are in Qt Creator. We are going to create our project here. It's going to be a Qt widgets application. We are going to give it a name, save it somewhere on our drive. We want to use CMake as the build system, and we want QWidget to be our base class. Hit next and choose the kit you want to use here. And we don't want to get as the version control system, and we are going to finish. This is going to create the project. And we are going to head over to our UI form. Let's close this little thing. And we can look for a label component. We're going to do 2 copies of this, I think. This is what we need to do. I think we might also need a button. So let's do a button here. We're going to see how this goes. And we're going to say text 1 for the first thing. We're going to say text 2 for the second thing. We're going to put the text in this button here. We're going to say click. And we are going to name this some button or click button. And we are going to respond when this button is clicked here. So go to slot and okay. This is going to do. Let's come back here and apply a vertical layout to this thing. And we are going to resize this and bring this really down. I think we can change the font of the text here for this to be a little more visible. So let's use 20 as a font size here. And we're going to do for text 2, we're going to use a font size of 20. So let's do that and hit OK. This is going to show up here. So we can resize this down a little bit so that text has some breathing room. So for the first text here, what we are going to do is change the style sheet from our properties here. If we go inside, let's go here in the search bar in the filter line edit here and search for a style sheet or set style sheet. You see we have an option for a style sheet here. And if we click on the 3 dots here, we will have a window like this. We can go in this window and specify things we want. For example, we want to add a color. And we want to add a color. And I think this color is going to be the color of the text. So for example, we can make it blue. Why not? This blue here. And we can also add a background color. And we are going to choose, what do we choose here? Let's choose yellow. as the background color. And all these properties are going to be reflected here in text. So we are going to see that this is a valid style sheet if we put another thing. Okay, so we have our properties here. The next thing we're going to do is hit OK. And if we do, you're going to see that the style sheet is going to be applied to our label. And this is something you can do if you want to do things this way. But it is also possible to do things in code, and that's what I am going to show you here. So let's head over to our constructor for the widget. And we are going to set the style sheet to a single button. We are going to say UI click button, and we are going to say set style sheet, and we are going to pass our style sheet in here. Let's take out these things. I think we have 2 of them. So we want the background color to be yellow, and the color is going to be blue. And now if we run, the button should have this style sheet applied on. So if we go back again, this is the button, and it is going to have the style sheet when we run the application. Please remember that style sheets are applied at runtime. So let's look at application output here. And when we run, we're going to see that the button has a yellow background and a blue piece of text. And this is really cool. The text looks a little bit black, so let's change the text color to red maybe. That's going to be much more visible. And if we run, okay, you see the text is red now. I think it is visible even on video. Another thing I am going to show you is that we can go to the other extreme and set the style sheet on the entire application. And we are going to grab our code here. So let's copy a little bit because I don't want to repeat this. And what we are going to do, we are going to head over in the main CPP file. Notice that we have an application object. So we can say a set style sheet and apply our button style sheet here. And what this means is that every single button that is going to show up in this application is going to have this style sheet applied. It's going to have a yellow background and a red color. To try this out, let's go back and put in a bunch of buttons here. We don't even have to put some text in. Okay, so let's do that. We just drag and drop and put in our layout here, and we can resize this a little bit so that our buttons have a good size. We can do something like this, and if we run, we are going to see that the style sheet is going to apply to any button in this application here. Even if we set up an independent dialog, let's do that. We are going to add a new form, so a Qt designer form class, and we want a form in the class. And if we do that, we don't want anything, so we're going to say dialog without buttons here. I think this is going to do. Let's call this some dialog. Okay, so we are going to hit next here, and we don't want to get, and we are going to copy this and go back to our cmake list.txt file. This is the usual thing really. So let's put this here, and we want to move these guys to separate lines so that it is easy to follow. And we can run cmake again to have this class available. Okay, now we can go to the UI form for this dialog. Is it this dialog that is open? Yes, it is the dialog that is open. So we can put in a single button, and let's say inside dialog, I really want you to see the extent to which this style sheet is going to go. So what we are going to do now is to create an instance of this dialog and show it. But before we do, I think we should put a layout in there to make this easier to follow. So let's apply a vertical layout, and we are going to bring this guy to the top. And now we can go to widget and include the dialog here, some dialog, and we can create an instance of it when the user clicks on this button. So let's do that. We're going to say some dialog, and it's going to be dialog equals new some dialog, and we are going to pass a parent, and we are going to exec and show this dialog. So let's say dialog exec to show this guy. And what we expect to see is that when this button is shown, it's going to have the style sheet from the main CPP file applied, because this is going to apply to any button inside our application And this dialog is living in our application, so this button is also going to be affected, even if it lives in a different class. So this is the point I am trying to make here. So let's compile and run. And you see we have our thing here. If we click, the dialog is going to come and it is going to have the style sheet applied on this button here. And this is really cool. This is what I wanted you to see. Another thing you should know is that if you apply a style sheet to a parent widget, the style sheet is going to apply to all the children of that widget. And what do I mean here? Let's go back to main CPP and comment out the style sheet we had. And we are going to say that we wanted to set the style sheet to the entire application. And we are going to copy the code here and copy. We can go to widget CPP. When we are initiating the dialog, we can say we want to set the style sheet to the parent widget. Okay, and that's what we're going to do. We're going to say dialog and set style sheet, and we will pass our style sheet in here to be applied to this dialog. And this is only going to affect things inside this dialog. This dialog itself and everything inside, because we are setting this to the parent widget, and it is going to apply to anything inside this widget here. This is what I mean. So let's pass this through the compiler and run. Okay, we have this thing here. You see that the widget component is not affected, but if we click, we're going to see that every single button in this dialog is going to be affected by the style sheet we set on the dialog component here. This is something I want you to see. Even if we go in our dialog UI and add a bunch of other buttons, let's do something like this and bring it down a little bit and run. This guy is also going to be affected because the style sheet is going to affect everyone in that dialog. You see that this is what we see here. And this is really what I wanted you to see. It is possible to set the style sheet to the entire application. You can set the style sheet to affect a single widget like we did here, or you can set the style sheet to a parent widget and it is going to apply to every single child of that widget. The last thing I want you to see is that when we set the style sheet to a single widget, we don't really need to specify which component we want the style sheet to apply to. So what we can do here, we can copy this and go down and we can uncomment this, and we need to take out this thing here that says Q push button, because we know we are putting this on a push button, so this style sheet is going to apply to a push button anyway. This is what I want you to see here. I think we can leave the rest as it is and we can run, and the click button is going to be the only thing affected by this style sheet here, and this is what we see. You see the dialog is now not affected because we have commented out the code to set a style sheet to this dialog here. This is really all I wanted you to see in this lecture. I hope you found it interesting. We are going to stop here and I will see you in the next lecture. In this lecture, we are going to learn about external style sheets. And before I even say anything else, I want to say that this is something I recommend. You don't want to use inline style sheets like we have been doing in previous lectures. I did that to show you that it is a possibility, but in practical applications, please do things like we are doing here. So what we are going to do, we are going to create a file in our project. We will call it style.css, but you can name it whatever you want. But CSS is a common extension. And we are going to wrap this in a resource file called resource here. And we are going to be referencing this file in the main CPP file. And we will use this as our style sheet. So what we will do, we will read from this file. We will get a string from this file. And it is that string that we are going to set as our style sheet. And inside this style file, we can do all kinds of crazy things. You can see different syntaxes here. For example, here, the syntax we have on top here is saying we want to target every button whose text is submit. And we are going to apply these CSS properties to that button. We're going to change the color to white. We're going to change the background color to gray. Every button whose object name is equal to OK button, we're going to apply these properties. Every push button whose object name equals to cancel button, we're going to apply these properties. Now, you must be asking, how do I know these things? Well, these are CSS rules in the Qt framework. And if you come to the documentation, I am using the web-based documentation here. You can use whatever you want. You can search for the style sheet syntax, and they are going to talk about all these rules here. If you go down, you're going to see selector types. So you can set a style sheet to everything in your application. It's going to match all widgets. You can target a given object, but you can just write Q push button, and it is going to target every button in your application. You can do that if you want. Now, you can also target a widget based on the property. For example, you can target every push button whose flat property equals false. And you can target based on a class selector. So this is something you can do. This is going to be like targeting every object whose class name equals to push button. You can target based on object names, and this is what we just talked about. Or you can target based on the parent. So here you are saying every push button whose parent object is a dialog. This is what we are doing here. And what I have just done here is use those rules to do something useful. Okay, the first question we have is, how do we read from a resource file? Well, here is a simple function I have put together to help you out. We haven't learned about how to read from files yet, but we will in due time. So for now, just take this function and use it as is, and we will learn about this later. For now, we just want to worry about style sheets. But this is a really good practical way to work with style sheets. So I want you to start doing things the right way the moment we are learning about style sheets here. So once we have the function, we can head over in the main function, and we will create our application. We will read the CSS file from the resource. This is what we are doing here. And we are going to get a string back from the function. We will set this string to our application as a style sheet, and everything in our application is going to be using this style sheet here. And we will be using those selectors we have seen before to target what we want the style sheet to apply to in our application. So even if the style sheet is set in the main CPP file application-wise, we still have the ability to target specific things using all these selectors we have talked about here. Now, please note that you still have the ability to set the style sheet application-wise or in a given container or in a specific widget, but doing it application-wise using an external style sheet is going to be beneficial in many ways. The first thing is that you have a single point of contact where you have to look for your CSS rules, and it is just good design. You don't have to run through your application hunting for CSS snippets. This is a really good way to do things, and I recommend it. Now that you know this, we're going to head over to Qt Creator and do this. Okay, here we are in Qt Creator. We are going to create our project. So let's do this. It's going to be a Qt Widgets application. We are going to give it a name and save it somewhere on our drive. It's a CMake project. We want to use QWidget, and we will not use translation. We want MinGW as the kit, and we don't want Git as the version control system here, so we can finish. This is going to generate our project. Let's wait for it a little bit. Okay, the project is here, and the first thing we are going to do, we are going to design an application like this. We will set up a form on our main widget here, if you can see it, this little guy here. And when the user clicks on submit, we will pop up a dialog asking them if they are sure. And we will use style sheets to target these buttons and make them look really like we want. For example, this one is going to be gray, the OK button is going to be green, the cancel button is going to be red, and we will be doing all this from the main CSS file, which is applied application-wise. So let's do this. The first thing we're going to do is set up the form in our UI form here. So what we can do is grab a bunch of labels. Let's search for label, and we will put 3 labels here. And we want line edits. Let's do that. Line edit. This is what we want. We want 3 of these, and we can do something like this. We're going to name them last name, and we want to extend this a little bit. So first name, and profession. And we want to name these objects here. So we're going to say last name line edit, and we're going to do first name line edit, and we're going to say profession line edit. And we want to align these guys nicely, so let's do that. Horizontal layout for the first guy, horizontal layout for the second guy, and horizontal layout for the third guys here. And we want a button, so let's grab that and put it here. The button is going to say submit, and we are going to give it a name. So it's submit button. And I think we can align everything in a vertical layout so that everything looks nice and neat. You can do something like this. And when the user submits, we want to pop up a dialog which is going to ask them if they are sure about the data they put in here. We are going to build the dialog on our own, so we add new. We want a Qt form class. Let's do that, and we will do a dialog without buttons because we want to do everything ourselves. We will name it this sure dialog, and we can hit next again, and we don't want get for this. And we want to copy the file names here and put them in our cmake list.txt file. I really want you to be familiar with this. That's why I am doing everything here live. It may take some time, but it is going to be helpful if you want to see the entire process of how I do things. Let's rerun cmake, and we will have our dialog here. So let's bring it up, and we will use a label. Let's look for label, and we are going to say, are you sure? In this label, we can do something like this. And let's expand this a little bit, and we can style this a little bit. Let's put a font that is a little bit bigger. I think 24 is going to do. We can expand this a little bit. Okay. And we want a bunch of buttons, so let's have a button on the left and a button on the right here. The one on the left is going to say okay. The one on the right is going to say cancel. Cancel is going to be called cancel button, the object name. So let's say cancel button. You can see that even designing simple looking user interfaces can take some time, but this is the process you have to go through. Okay button, this is the object name, and we want a horizontal spacer to push things a little bit, and we want a horizontal layout and a vertical layout, and we can do something like this to make it look better. Now that we have the dialog, we can go in the widget CPP file and respond when the submit button is clicked. So let's do that, submit. When it's clicked, we want to respond. And what we do is create a sure dialog instance. Sure dialog, that's what we want. And we want to create an object of this. Sure dialog, are you gonna come or not? Sure dialog. Here you are. So dialog and a new sure dialog, and we're going to parent this to the current widget, and we want to run that dialog. We want it to pop up, and we're going to say dialog exec. Okay, this is something you can do. You don't really have to catch the return value, but this is just muscle memory putting this here, and it's not going to hurt. So let's run. Let's run and see what the application here does. It took some time to build, but now we are going to get to the meat of style sheets. So we have the thing here. You can put in your last name, first name, and profession. If you submit, we are going to pop up a dialog, and you can hit OK or cancel. So let's kill this. We are not really interested in the functionality of this application. We just want to change how it looks using style sheets. So the first thing we need to do is to add a CSS file. And in Qt Creator, I don't have an easy way to create this file, unfortunately. So what I am going to do is use an external application and create this in the folder where this project is. So let's go there, and we will open this up here, and we will create a folder called styles. So let's do that. And inside this folder, we will create a file. So let's go to Notepad++, which is what I like to use to do things. And I am going to save this file as, okay, and I am going to choose where I want it to go in my application here. So let's make sure we can go up a little bit, and let's go up again. We can go to course code here, go to styling, and go to external style sheets, and we're going to go in styles. This is where we want to save it. We're going to say style, and we want to save this as a CSS file. Okay, and to make this work properly, we're going to go to all types here. Make sure you do this if you are using Notepad++, or you can do this in any other editor of your choice. The only important thing is that it allows you to save this with this extension here. So let's save. Now we can close this and go in Qt Creator. And what we are going to do is to add a resource file that is going to wrap around that styles folder that we just set up in this project here. So let's create a resource file. We're going to right click, add new Qt resource file. You already know how to work with resources, so let's say a resource here. And we are going to hit next. We don't want to get for this. And let's finish and copy the path to the guy. And we are going to paste that in here. And once we do that, we will need to rerun a CMake for CMake to pick up that resource file. You can see it right here. And we are going to open this in editor. You already know this. We need to add a root prefix. I am going to use a root prefix, but you can put in custom prefixes if you want. And once we have the prefix, I am going to add files, and I need to go in styles and select the style here. Now it is going to be available to me. I don't want to add this to version control. No problem here. The file should be available for use in my application here. Let's save. And once we do, you see that we can click on this little arrow here. And if you go down, we will find our style CSS file. If I want, I can copy its path and I can go in main CPP and save it somewhere. Let's put a comment here because we are going to use this in a minute. Okay, we have the style sheet. So how do we load it and set it as a style sheet? For now, I have a function I want you to use as is. We don't have enough tools to understand what is happening here. We haven't learned about QFile or QTextStream here, but we can use this as is to read the CSS file and give us a string containing our CSS that we can set to our application here. So let's include these things that are needed. Let's include QFile. I think it is going to bring all those things in. So include QFile, and it should bring all those things in, and everything is going to work now. Now what we can do, we can go down here and say QString CSS, and we're going to say equals read text file. Okay, and we need to pass the path to our CSS file. I am going to cut this out and put that in here. And now we want to check if the length of the string is not equal to 0. So we're going to say if CSS length. You can do that. This is just a simple check we do to make sure it is not empty. You can say if it's not empty. I think that's also going to work, but this is just a check I do for myself here. And we are going to say a set style sheet. And we want to pass CSS because that's what we're going to be reading from that file here. So now what we can do to test this is to go in our CSS file. We can open it in Qt Creator and we can say we want every push button to have a red color. So we can say color or background color of red. I think we can do something like this. Okay, so let's test this out. Again, in main, we are reading the CSS file from our resources. We are storing that in CSS, this variable here, and we are setting this application-wise. And again, this is the design I do recommend. Let's run and see if every button has a red background. Looks like it is working on the main widget here. If we do submit, you're going to see that OK and cancel are also red. We can read our CSS file, and we can set it as a style sheet to our application. This is really cool. Now that we have this, we can go back to the documentation and really read all those things here. So for example, we can use this property here and say we want to target every push button whose property equals to something. And if we go back in our Qt application and go to the widget here, and let's go to the UI form, I think that's going to be much better. So widget UI, and go to this submit button. We can look for any property really, but I think the most obvious one is going to be text. And if we go down, I think we're going to find it. Where is text for this button here? Where is text here? I can't find it. If I can't find it, I am just going to search text. And you see the text for this button is submit. So we can target this property here. So we are going to say, let's go back in our CSS. If I can get there, we are in our resource here, or we can open it from this window here. We can get there. We are going to say every button, we use a bunch of square brackets whose text property equals submit. Okay, we are going to say we want to set the background color to gray. We can do something like this. And now if we run, the change should only affect this main widget, the button here. But if we initiate the show dialog, we're going to see that the OK button and cancel button are not affected. And this is something you can do. Again, I know this because I read the documentation. Now let's see how we can use other properties here. For example, here is one we can use to target buttons with given object names. They are called IDs in the documentations, but they are really object names. So let's target the OK and cancel button, and we are going to change them a little bit. Let's come back to Qt Creator and go back to show dialog where those buttons live. We can bring up the UI form. OK button is called OK button. Let's kill our search here, our filtering. We can say go away, and OK button is called OK button, cancel is called cancel button. So we can target these properties, and we are going to say, let's go to CSS again. This is a bit cumbersome to go through. We are going to copy this and go down and say we want to target every push button whose object name equals OK button, OK button. And if the object name is equal to cancel button, we're going to do something else. So let's do that. Okay, and we want the background color to be green for the OK button, and we want it to be red for the cancel button. We can even set the text color to white. So let's say text, or I think it's color, and white for everything here, color to white. And let's go back to the top and say color. We want this to be white. Okay, this is the syntax we use to do these things. So let's run, and you see the color changes to white. And if we run this, you see OK is green because we targeted its object name. Cancel is red because we targeted its object name. And I do encourage you to really read all these properties here. For example, the one we have here can be used to target children in a parent. It's going to match all instances of Q push button that are direct children of Q dialog. And this is really cool. You can do all these kinds of things here. And this is really all I had to share in this lecture. I hope you have a strong foundation on top of which you can build your style sheets. And it is really a good idea to have your style sheet in a set of files where you control everything instead of having style sheet snippets spread through different source files in your application. We are going to stop here in this lecture, and I will see you in the next one. In this lecture, we want to improve on the last lecture's application a little bit. I think this is what we had. We had a main widget which had a form and a gray button, and we could click on submit and get this dialog to pop up, and we could target all these buttons and get them to do all kinds of crazy things. What we want to do is something like this. We want to style our form a little bit. We want to make the line edits here a bit bold. We want to have nice line edits with round borders and this yellow background. We want to do these kinds of things. And I want you to see that we can do that using style sheets. Let's head to Qt Creator and improve on that project. So here we are back to the project of the last lecture, and what we are going to do, we are going to go down and target line edits in our main widget CPP file here, or this UI form, if I can say it like that. So we're going to target these line edits and style them a little bit. If we look, they live in this widget here, and let's just say that we want every line edit in the application to have the style that we are about to apply. We can go back to our CSS file and we are going to target every line edit, Q line edit, if I can type this, and we want it to have a little more space around it. So we're going to change the padding. Let's do a 1 pixel padding here. And again, I know these properties because I know a bit of CSS. You would have to learn CSS a little bit to understand what is going on here, but it's really not that hard. We want the line edit to have a border, so we are going to say border. It's going to be 1 pixel. We want it to be solid and black. Let's make it 2 pixels. And I think a black color for the border is bad, so let's say gray here. This will do. And I think we can even run it before we do anything else. Did we save? So so let's try and change the border here a little bit. Let's try and make it's 2xpxc. I think this is the problem here. Let's do this again, and you see we have a border around our line edits. If you can see it, let's make it 10 so that you really see it. It's going to be ugly, but you're going to see that. And you see it's really big. Let's turn this back to 2. Okay, we can do something like this. We want a border radius of 8 pixels. Let's see how this looks. And again, this is based on experience because I work with these things a lot. So we have this little thing here. We can change the background color. Let's say background color, and make this yellow. And we can run this to see how it looks. Okay, looks a little more like we had in our design in the slides. And let's change the height of this guy to maybe 30 pixels, and let's see how this looks. And we can run, and you see this is much nicer. Okay, so we can do Daniel Gakwaya, I am a farmer, and if I submit, are you sure? Yes, I am. And we can really work with this application here, and it is going to do everything we want it to do. Another thing you might want to do is to make the labels here a little bit much more bold. I think it's not really visible here. So what you can do, you can target the labels inside our widget here. And if we go back to the documentation, I think we're going to find something we can use. We can use this thing here. So we're going to target labels that are direct children of our widget class. So how do we do this? And remember to be able to only target things inside this UI form here. We can use the object name of the widget here. So let's do that and find our object name. So this is this guy here. So we are going to say we want to target every child of a Q widget whose object name is widget. So let's do that before I forget, because these things can be confusing. So we want to target Q widget whose object name is named widget, because we just showed that in the UI form, and we are going to target children who are Q labels. Okay, and we are going to go in the body and put in our property here. We want to change the font weight, so let's say font weight, and we want to change this to bold, and we want the font size to be 20 pixels. Let's do that and run and see what we get. And this is much better. I think 20 pixels is overkill, so let's bring this down to 12 maybe, and run again. And this is much better. And this is really what I wanted you to see, to make this widget a little nice by using style sheets here. We are going to stop here in this lecture, and I will see you in the next one. Congratulations on hitting the end of this chapter where we were looking at the styling options we have in our Qt applications. We saw that it is possible to use the QStyle class, which is going to be controlling the style your application uses. And this is, for example, going to control how your application looks. Here we have a bunch of examples. For example, these are a bunch of styles we have. You see how your application may look on the Mac if you are showing a combo box, and these are different ways this is going to look. And all these examples here are using default styles on these desktop environments. And I believe on each operating system we have a bunch of styles that we may use in our Qt applications. We have different ways to set styles in our Qt applications. For example, we can set it application-wise, and the style is going to apply to every single widget in your application. But you can also set the style at a widget level, and it is going to apply on the single widget here. It is also possible to pass your style as a command line option when you start your application, but I didn't really want to go too far in this. If you want to learn more about styling, I do recommend checking out these classes. And I have to say this is not an exhaustive list, so you might have to check the documentation if you want a full list of these styling classes in Qt. Most developers are not going to be messing with styles, at least from my experience in my decade-long career as a Qt C++ developer. And you will need this if you need your widget to blend in and really look well on whatever operating system your application is going to run. We also had a chance to see that we could use QPalette to control how different parts of our widget looks. For example, we can control the text on buttons, the background color, and all kinds of crazy things you see here. And we saw that palettes aren't really that reliable, especially if the application is going to run on different operating systems. For example, you may set a color, and the color is going to work on Windows, but when you run your application on Mac, for example, or Linux, you're going to see that the color of that button is not controlled by the palette, but by the native style that the operating system is going to have, and things are not going to be consistent. So if you want things to be very consistent, one way to do that is to use style sheets. And we saw that we could do them in line, we could do them in a separate file, and we could set style sheets at different levels in our application. For example, we could do that at the application level, we could do it at the parent or container level, or we could even do it at the widget level. The choice is going to be yours now that you have this knowledge at your disposal. We are going to stop here in this lecture, and I will see you next time. In this lecture, we are going to learn about QSettings, and this is an object or a class we have in the Qt framework to allow us to save things and load them back in a cross-platform way. So suppose, for example, your application has a few settings, you have the location of the windows, you have a bunch of colors in, and you want that state of the application to be persistent when the application is closed and when the application is started up again. This is a good use case for QSettings. And this class is really simple to use. Here we have a simple example. So you set up a QSettings object, you give it a bunch of things. I think this is the name of the company and some string you use to specify who the settings belong to. And this is what Qt is going to use to store these settings in whatever way the operating system allows things to be stored. And a good use for this is to differentiate between different applications, because you might have thousands of applications running on your system and the system needs to know who the settings belong to. That's why you need these kinds of things here. And again, when we hit Qt Creator in a minute, we're going to look at the constructor here and see what these things are. Now, once you do that, you begin a setting group. And you do that by saying settings begin group and at the end saying settings end group. And within this space, you save your data. We are going to see the details of how you save data in a minute. But this is basically how you write settings in your Qt applications. Now, once you have the settings written, you might want to read them back, and this is the code to do that. Again, we set up a group like we are doing here, and inside the group, we are going to load the data. Now that you have an idea about this, let's see the details about saving and loading. Here is a piece of code showing how you can save the data, and really all you do within your group is to call the setValue method on your settings object. You call this method and give it a Q and a value. So for example, here we want to store the window size. This is what we are doing here. Size is the key, win size here is the value. We can go down here and see how we can save something else. Here we are setting if a panel is visible, and we are saving that within this group here. So you can do a logical grouping of different things you need to save in your application. So once you have the data stored, you might want to read it, and you read it by using the value method. Again, when you call the value method, you give it a key, and this is what we do here. For example, animal snake is our key. We are setting this. When we get to read this back, we need to pass the same key. And you notice we are also passing a second value. What is this value for? Well, this is for the settings object to return this value if it can't find something valid. So look on top here, we saved animal snake and saved in 58 here. If we try to read animal snake, we will get the 58 because it's in. But if we try to read animal zebra, it's not going to be found because nobody set this key in our settings object here. So the settings object needs to give you something. And this is a way to tell it, if you can't find something for the key I am giving you, please give me 1024. This is what we are doing here. And if you don't specify this default value that is going to be returned when nothing useful can be found, it is going to give you a default value. For int, it is going to give you a 0. If you are storing a string, I think it's going to give you an empty string. You might need to try things out to see how this behaves on different types. But it is a good idea to specify the default you want here. Then there isn't going to be any guesswork. Another thing I want you to notice is that we are doing this toInt thing. So some of you must be asking, why are we doing this? We know we are reading an integer. Why do we do toInt? Well, the reason is the value method isn't going to give you a specific piece of data. It's going to return a QVariant object. And a QVariant object is really like a union, if you know unions from C and C++. It is an abstract data type that encapsulates the actual type that you are interested in. So this was put in place to be able to work with things like reading data from the internet, reading data from the databases. You might read something and then decide what to interpret that thing you read as a specific piece of data. So we need to know what we are reading in this case here. We need to have information about the data type we want to get from the settings object. We know we put in an integer, so we will turn this guy to an integer. But it is possible for somebody else to try and turn this into a string, and they are probably not going to get what they expect. So if you return a value from the value method, make sure to turn it into the data type that you expect. That's why we turn this guy to an int here. Okay, this is really all I had to share in this lecture. We are going to stop here in this one, and I will see you next time. In this lecture, we are going to set up an example to use QSettings and see how useful this can really be. And we are going to design an application like this. This is going to be a bunch of buttons we have on the user interface. And what we are going to do, we're going to be clicking on each button and setting a color to it. And what we want is that when this application is closed, we can load the colors back. For example, here is a screenshot I took for the application. We want to do something like this. And the key is going to be in saving colors and loading colors in the slots that are going to respond to these buttons here being clicked. Let's look at some pieces of code that we are going to be using here. We will set up a function to save the color, and we will give it a key. And this is a design I came up with. You can really do this however you want. And once we get into the body of the function, we will break the color into red, green, blue component. And we will store these variables as integers here. Once we do that, we will set up a settings object and give it a bunch of data in the constructor. Okay, here you can really pass in whatever you want. A common practice is to pass in the company name and the software product name, and that's really going to be your choice. And once we have the settings object, we are going to begin the setting group and end the setting group. Within these two lines, we will do our saving here. And as you know from the last lecture, we save the values by using the setValue method. We need to pass in a key and a value, so the key is going to be the key we specified when we called the method here. And the value is going to be the red, green, and blue components that we have in here. But notice that to set the key, we are passing the key here and adding an R to mean that this is the red component for this key here. And the idea I have is that this key is going to be the name of the button. Okay, so you need to remember this. This needs to fit into our design of the application that we are doing here. You're going to see how all this comes together. Here is another function that is going to load the color. So this is going to do the reverse. We need to give it a key, and it is going to give us a color that we can then set to our push buttons. And we will need to read the red, green, and blue components. This is what we do to set them up here. And we set up a settings object. We begin the group and we end the group, as you see down here. Then we are going to read the red, green, and blue components, and we use the value method. We give it the key and the default value we want. So if it can't read a color, or if it can't read a color component, it's going to give out a variant object that wraps around 0. And once we read the value as a Q variant, we're going to turn that into an integer. That's what we are doing here. So once we hit this point here, we will have the red, green, and blue component. We will use them to set up a Q color object and return it by value. Okay, this is what we are doing here. And we will have a color that we can then use to do whatever it is we want to do in our application. Okay, we will need somehow to store the colors. So what we are going to do, we will set up a list of colors in our widget application, and we will populate this list in the constructor of our widget here. This is what we are doing. So when each of the buttons is clicked, we will set up a color dialog, and we will give it the current color for the button. This is what we are doing here. Remember, the colors are stored in our color list here. Once we have the color, we check if the color is valid. We will store it in our list, and then we will apply it to our button as a style sheet. This is what we are doing here. And we will set that color as the background color of the button. And this is really how you can set up the style sheet to do that. You say QString. Okay, this is one way you can use QString here. And we really want to be able to get the color from the QColor object and get the color as a string. So we will say background color, do a placeholder here, and the color name is going to go in this place, and it is going to be set as a style sheet to this button here. Please take some moment to read this. If you can't understand this, I do recommend to read the documentation of QString. You're going to see how to use these arg things here. Again, read the documentation for things you don't understand. That's why the documentation is there. Once we have the CSS, we will set that to the button and we will see the color appear. This is really cool. Now, when the save button is clicked, we will need to save the colors. And what we will do, we will save the color of each button. So we grab the color for button 0, we save that under the key button 1, and we keep doing that until we hit button 9, which is going to have the color at index 8 here. Nothing complicated here. When the load button is clicked, we will call the setLoadedColor method. And what this is really going to do is to read the color from the settings and set the color to the given button that we specify here. We're going to see how setLoadedColor works when we hit Qt Creator in a minute. Now that you know this, let's head to Qt Creator and play with this a little more. Okay, here we are in Qt Creator. We will create a new project. It's going to be a widget application as usual. Let's give it a name. We will give it a name and save it somewhere on our system. Let's hit next. It's going to be a CMake project. It's going to be based on QWidget, and we don't want to use a translation file. We want to use the MinGW kit, the usual ready. We don't want to get as the version control system, and we will finish here. So the first thing we need to do is to set up our UI form. Let's go to the UI form here and set up a bunch of buttons. So we will grab, let's grab a bunch of buttons here. Button 1, button 2, button 3, button 4. Okay, so the buttons below are going to say save settings, and the other one is going to say load settings. And we are going to name these buttons from 1 to 9. Let's do that. Okay, we have the buttons here. So what we want is to put them in a grid layout. Let's try and use a grid layout here and see how this behaves. You already know about QGrid layout. We have learned about it, but we haven't seen how to use it from the UI form, I think. So what we want to do is to go on top and click on this thing that says layout in a grid. If we click this, you see this is conveniently going to be a bunch of 9 buttons exactly laid out like we want. If you want, you can play with size policies and stretches to get these buttons to be bigger, but I don't want to go there. I just want you to see how to use settings here. So what I am going to do is to apply a vertical layout to this entire thing, and I am going to resize this so that it is small. Okay, or we can change the vertical size policy for these buttons so that they occupy or the available vertical space. I think that's going to make it much better. So what we are going to do, where is size policy? It is right here. So we want to expand this, and we want the vertical size policy to be expanding. Let's do that and say expanding. When we do that, you see the button is going to fill all the available space, and this is really cool. So let's do that for all the buttons. So vertical policy expanding, can do that. Vertical policy is going to be expanding for this guy here, and we want to do this for all the buttons. Let's go down and do number 4 expanding, and number 5 expanding, number 6 here expanding. We want this to be expanding, and number 7 to be expanding, and they are going to share the available vertical space, and that's going to be much better. Number 8 expanding, number 9 we want this to be expanding. Okay, once we have this, it's going to look much better. We want to name these buttons, so let's do button 1. Okay, button 2 and button 3. Let's do button 4. You can name these however you want. This is just my naming convention here. 5 and 6. Button 7. Button 8. And button 9. So let's set the object names for these buttons here. Save settings and load settings. Save button and load button. I think this is going to be enough. And we have our user interface here. We want to respond when these buttons are clicked. So let's do 1. Go to slot, respond when it is clicked. And I am going to do all the slots and come back when they are done. I don't want to waste your time here. Okay, we have all the buttons from 1 to 9. Let's do save settings here. Go to slot and clicked. We want OK. Let's go back and go to the load settings button and go to slot, and we want to respond when it's clicked. We have this right here. Now that we have these guys, we want to go to the header and set up our list of colors. We want to include the Q color here because we are about to use it. So let's include the Q color, and we can go down in the private section and set up a list of Q color. We're going to say Q list Q color, and we're going to say mColor list. I think we can do something like this. And we also want to put in our functions to save color and load color. And I am going to make them private because we don't intend for them to be used outside this widget class here. If you want, you can make them public and make them fit into your design. But for now, we're going to make them private here. So let's implement these. We're going to click Refactor, add definition in widget CPP file. Let's go to the top again and go load color. And this is not following our naming convention, but we're going to change this in a minute. So we can refactor and add a definition in widget CPP, and we can rename the methods. I think we can do that from Qt Creator. Let's see if we can do that. We can refactor and rename symbol, and it's going to be renamed throughout the entire project, and this is really cool. So we're going to replace this with save color with the underscore. Can do something like this, and you see Qt Creator is going to conveniently tell you the files where this is going to be applied, and this is really cool. So let's do that. We are going to click replace, and every instance of save color for this function or this method is going to be changed to this naming convention. So let's go to the top and do the same for load color, refactor, rename. And we want to name this to load color with an underscore, and we're going to replace like we did before, and this is exactly what we want here. How cool is this? This needs to return a value. We're going to do this in a minute. The first thing we are going to do when we want to save a color is to break the color into red, green, blue components, because we want to save integers in our application here. And if you want to know about QColor, I invite you to use the documentation. Let's type QColor, and we are going to see all we can do with colors, and colors have different components. They have a red, blue, and green component, and that's what we are doing here. And we can break our color into these components. So on our color, we can call the red method to get the red component. I think we can call the green method. If we go down, we're going to find green. Can I find green? Now that I am looking for it, I'm not going to find it. But you see, we can set red, for example. Where is green? Green is here. I found it. And we also have a blue method just like this. So we can use these methods to break our color into red, green components. Once we have these components, we will find a way to save them using our settings object. To use settings is exactly like we saw in the slides, so I am just going to put the code here, and to be able to use this, we need to include QSettings. So let's go to the top and do that and come back. So include QSettings, and if we go down back to our method, we are setting up a settings object here, and if we want, we can read this in the documentation, QSettings. And we click to more. We're going to see what this does. I do invite you to read this, but if we go to the top and look at the constructor, you see that the first thing you pass can be a file name. If you look in our list of constructors here, you're going to see that we have one that takes two strings. The first thing is going to be the organization. The second thing is going to be the application. That's why I said this might be the name of the company, or this might be the name of the application. I was referring to this constructor here, and this is what we are going to use in our application here. So the first thing might be the name of the company, and this is going to be the name of the application. And after that, we will set up a group. And this is what we are doing here. So we will begin group and end group. And in this group, we will set our values to our keys. And notice what we are doing here is taking the key and appending the R to mean that the key here is for the red component of the given key that we passed here. And we're going to be using this technique. So we will have a red, a green, and a blue component saved in settings. And once we do that, this is going to be saved by the Qt framework. We don't really have to worry about this is done under the hood. If you want, you can read the documentation to see how this is done on different platforms. If we go in, let's see, users normally expect an application to remember its settings across sessions. This information is often stored in the system registry. So on Windows, this is going to be stored in the Windows registry, and in property list files on macOS and iOS. On Unix systems, in the absence of a standard, many applications use INI text files. You see, different operating systems save these things in different ways, but Qt is going to unify this using the QSettings class, and it is going to be really cool. Your application is going to run on Windows, Mac, and Linux, and you don't have to worry about all these differences here. And this is really cool, if you ask me. Now that we are done with the save color method, we are going to look at the load color method, which is going to do the reverse of what we just did here. And I am just going to go down and put in the code because I don't want to waste your time typing this. So what we are going to do is set up a bunch of variables to read the colors, and we will set up a settings object. And notice that the things we pass in the constructors for these settings are the same. Again, the things you saved are the things you read. That's why these guys need to match here. So after we have a settings object set up, we begin a group and end a group, and within this group, we are going to read values using the value method. We are going to be reading the keys that we set for red, green, and blue. And we want to turn this to integers because we expect these guys to be integers. And we will use these components to set up a color object that we return from this function here. And again, if you want, you can read the documentation on QColor to know how that works. Okay, now that we can save and load color, let's go to the top and make sure we can initialize our list of colors. If you remember, we have a list of colors here, and we need this initialized with whatever color we choose. I am going to use black because that's a good default color. So let's go to our constructor here, and we are going to set up a loop that goes from 0 to 9. So this is going to go 9 times, and it is going to be adding a black color at each slot in our list. So we need 9 colors for 9 buttons. That's why we do this. And you see we have a squiggly line here. Let's say M color. I think this is what we did in the header, and this is going to be happy. We also need a method that is going to set the loaded color to a given button to make our design a bit easy. So I am going to put this right here, and I am going to rename this set loaded color with our naming convention here. And you see it needs a Q push button pointer. We need to include the Q push button here. Let's do that. Q push button. And what this is going to do, it is going to load the color at this key, and it is going to set that to the push button at this index here. This is what we want to do easily in our application. So let's refactor and add a definition in the CPP file. So we are going to put in the implementation for this, and I am going to explain as I go. We need to say load color here. Color. This is what we said, and our color list is M color list. Now this should be happy. So we are going to load the color at a given key using our load color method. We will have a color, and we will set that as the color, and we will set as the color at a given index in our color list. Now, after this, we will need to set this to the button to be shown, and we will set this as a style sheet. And again, if you are rusty on using this arg thing, I would recommend reading the documentation on QString. So let's say QString here. And if we go to more, we will have a bunch of sections on using that arg thing, if I remember correctly. So you can go down. Let's go to the top and go to arg. I think that's going to be much easier. So QString arg. I think we can find that. You see there are a bunch of arg methods, and if you go to the documentation, they will tell you how to use this. This is just a way to get to replace placeholders in our piece of text. And this is something you see in things like printf, if you know printf from the C programming language. Let's go back to our code, and by now, if we call this method, our button is going to have the color applied as a style sheet, and this is going to be the background color, and this is going to work really well. I think now we have all the pieces in place to respond when each of the buttons in our list is clicked. So let's do that. But before we do, let's include QColor dialog because we are about to use that. Include QColor dialog. And we will respond when button 1 is clicked, and we will put in a piece of code to do that and apply and adjust this a little bit. mColor list, and we want to say mColor list 0 and use autocomplete here, and we want button 1, I think that was the name, button 1. And what we are doing here is really popping up a color dialog with our color as the default here for button 0. If the color is valid, we're going to save it in our list, and we will set it as a style sheet to our button 1 here. I am just going to copy this and reapply the same thing to all the other buttons. So for button 2, we will go to index 1. I think this is the only thing we need to change. So index 1. And we need to change the button we set this guy to. So we are going to say button 2. And I will keep going until I am done. Then I am going to try this. If you want, you can see the code in the source code that I have shared for the course here. Okay, I have all the buttons done. This was a lot of work. So we have button 1 here. You can take a look at it. Button 2 for a few seconds. Button 3. And button 4, and button 5, and button 6, and button 7, and button 8, and button 9. But we haven't done the save button and the load button, and this is going to be super easy now. On the save button, we are going to save the color for each button, and we will adjust our color list thing here. So let's do that. And we will grab this and use that as the name of our list here pretty quick and fix this. And we need to change this to save color. And we want to copy this again and fix this. So let's do that. And to save colors, we will need to save the color for each button, and we will do it like this using our method. And to load the colors, all we need to do is to set each loaded color to a given button. So we will pass our buttons here, and everything is going to fall in place. You can see that there was quite a bit of design that went into this application, and it really took long to get this working, but it is going to give you an idea on how you can really use settings to do something fun and interesting. Let's compile and see if this actually works. We have written a lot of code up to this moment. The build is surprisingly good, so let's run and see if this actually works. It is super big. We can resize it to this size maybe. Now let's set the color for the first button. You see, 1. Let's set the color for the second button, 2 and 3. Let's use the green here for 3. Let's do 4. And I use this color. I am going to do this until I fill up my buttons here. I want to enjoy this as much as I can because I took a lot of time to set up this. So let's fill up our buttons here to make sure you can see things happening. Okay, we have all the buttons filled. Now what we want to do is to save the settings. We're going to click Save Settings. And if we do, we have the option to load those settings if we close the application here. So let's close it and run it again. Okay, we have the application here. You see, it's not going to have any color applied, but if we want, we can load settings here and our colors are going to come back. How cool is this? If you want, you can even load the colors when the application starts. So what we can do, let's see on load button clicked, you're going to see it's going to be loading colors for each guy. And you remember, if we read the color that isn't there, we are going to get zeros in our load color button. So we can call the onLoad button clicked method here as a hack. So let's do that. We're going to say onLoad button. Okay, we're going to call this when the application starts. And if we don't have any color, the color is going to be black by default. But we are going to have colors because we already have the settings stored for our application here. So if you want this to go away, you can go in your registry and delete this, but I am not going to go down that path. What I really want you to see is how to use QSettings to do all kinds of crazy things. Let's change the colors again. Maybe we can change the colors to this blue for the first row here, just to have some fun with the application we built here. Okay, we're going to close it. Remember the colors, we have bluish on the first row and the third column here. We close, oh, we didn't save. We didn't save the settings. You see how things can go wrong? So let's save again. We're going to do something like this, and this for the second button, and this for the third button. And you can hit save settings. Now the settings are going to be saved. If we load again, you're going to see our settings, and this is really cool. This is all I had to share in this lecture. I hope you found it interesting. We are stopping here, and I will see you next time. In this lecture, we are learning about the QFile class. And this is a class we can use to read and write files. And this is a common thing that is needed in application, so you need to know how to do this. And one thing you should know is that there are different ways or different modes in which you can manipulate files. Files may be stored in binary format. And by binary format, I mean that the data is going to be stored in the form of zeros and ones. And to read a binary file, you kind of need to have meta information or information about information you're going to be reading from the file. For example, you need to know how big each data chunk is going to be, whether it's 1 byte, 4 bytes, 8 bytes, and things like that. So reading binary files is a bit involved. But it is also possible to manipulate files in text mode, and that's what we're going to be doing in this lecture here. And what we are going to be building is an application like this. It will have a text edit component, and we will have a bunch of buttons to write and read. The write button is going to write to a file on the system, and it's going to be writing to the file that we specify in this line edit here. So the full path for the file is going to be here. We will also see how to copy files, and these are a few things you can do in Qt using the QFile class. So before we do anything with this class, let's head to the Qt documentation and look at QFile, because this is really your best source of information. You can read about it, okay? You can read files, you can write files, you can do all kinds of crazy things. And again, take some time to read this detailed description here to see what is going on and how you can turn this to your advantage. Okay, so let's see how our application here is going to work. When the right button is clicked, we are going to pop up a file dialog to let the user select the file they want to save our thing as. This is what we do here. And if the string we get is empty, we are going to get out of this function. But if we get down here, we will have a valid string pointing to a file on our system. So we will use that string to create a file object. We will open the file, and we need to specify the mode in which we will open the file. We will open it in write mode. We want to write to the file. We will be writing text. And if the file already has things, we want to append to those things. We don't want to overwrite those things. And again, you can look these things up in the documentation and see what they mean. If we fail to open the file, we are going to get out of the function. Okay, so this is really a good way to do error handling. And if something goes wrong, you're not going to keep using unsafe data. This is a way to do things in C++. I think there is also a way to do this in other programming languages. After this, we are going to create a text stream object. And this is a class that is going to allow us to manipulate our file object in an easy way. So if we want to send something to the file, we will go through this stream. And what we are really doing here is we have a file object, okay, sitting here. And after this, we have a stream object that is really going to take the data and forward that in the file that is sitting on the operating system. So this is our file. For example, this is the Q file object pointing to this file on the system. And we have a stream, which is going to make it easy to write to the file, for example, using an output stream operator. We can do something like this. So the stream is going to be set up and we will write to the file. What we write to the file is what we read from our text edit component, and we will use toPlainText method here to get the data and write that to the file. And one thing you don't want to forget is to release your resources in your C++ application when done using those resources. And make no mistake, many people think of resource as dynamic memory on the heap, but files are another great resource in your C++ applications. And I can't stress enough how many people forget to close files they have opened, and that's really a recipe for a disaster, because somebody else is going to try and use that file and it is opened in your application and things are going to blow up. It's really not a good thing. So whenever you open a file like we are doing here, make sure you close it, just like we do down here. Okay, now you know how to write to a text file, and you're going to see this in action when we hit Qt Creator in a minute. Let's see how to read the data back. So we will read the data in our read button clicked slot here. Again, we will let the user select the file name, and if it is empty, we will get out of here. We will have a file object. We will open the file now in read mode. Again, you can really put this thing in the documentation to know what it means. And we will be working in text mode. This is what we say here. If we can't open the file, we will get out of here. We will use our stream, and we will set up a string in which we are going to be reading data. We are going to be reading data line by line. So here we have the first line, and we will keep looping, checking to see if we didn't read something empty in this line. Okay, we will keep looping, looking if we haven't reached the end of the file. This is really what we mean here. Each time we get into the body of the loop, we will append what we read in the line to our file content string. And when we hit the end, the loop is going to stop. We will close the file and we will write the data in our plain text component, and we will see things appear in our user interface. This is really how you can do this. Another thing we can do is copy files, and let's look at how we do this. This is really simple. We will set up our source file name, the destination file name, and we will check if they are not empty. If either is empty, we get out of here. We set up a file object, and we call the copy method on the source file to copy and paste into the destination file. This is really what we mean here. And if this succeeds, we show a message box. If this fails, we show another message box here. Let's head to Qt Creator and do this. Okay, here we are in Qt Creator. We will create our Qt widgets application pretty quick. We will give it a name, and we will save it somewhere on the system. Let's go into our chapter here and mark this as the default location for the chapter. We want to use CMake, and we want to use QWidget here. We don't want any translation thing, and we want MinGW as the kit, and we don't want get. Let's finish. This is going to give us the project, and we are going to set up our UI form pretty quick. Let's grab a text edit component. Now you know these things, so I am going to do this a bit faster. And we want a bunch of labels, so let's grab a label, and we want one here and another down here. And we want line edits. Let's do that. Line edit, we want this guy here, and we want this guy here. And we want a bunch of push buttons. I think we can do that here. So let's put push buttons. And the first one is going to be write. The second one is going to be read. And the third one is going to be copy. Okay, we can do this. And the first one is going to say source file. And the second line edit is going to say destination file. And we want to name these components. The text edit will stay text edit, but the source file line edit is going to be named. So let's say source line edit, and we are going to say dest line edit for destination. And we have our write button, let's do that. Read button, let's do that. And we want our copy button here. We want to lay these guys out, so I think I need a vertical spacer to align these buttons. I am going to put all this into a vertical layout. I am going to grab the things on the top, put them in a horizontal layout. Let's do that. And I will do these guys, the line edits and the labels, and put them in a bunch of horizontal layouts to have things laid out nicely. You can see that putting together a good layout is a bit of work, but we want to do that. We are learning here, and we apply a vertical layout to the form, and this is going to look much better. We can run this and see how it looks. If it's not so big, the default size, that's what I am looking for. I think this is enough. So we can accept this. And we want to respond to these buttons. So let's go to slot and respond when either of these buttons is clicked. Let's go to slot for copy and clicked. Go to slot, clicked. We want to do that. Oh, the design we just did is a little bit different from what we set out to do in the slides. So let's change this a little bit. We are going to break our layout. Okay, so let's do that. We are going to break the layout here. And we want to also break the layout here. Okay, we break everything and we move the copy button all the way to the bottom. So this is something you can do. We also need another button. Let's say select file, and we want to name this button and we want to respond when it is clicked. We don't want to forget that. Let's come back to our UI form. We grab the write button, the read button, the spacer, we put them in a vertical layout. We grab everything here and put that in a horizontal layout. And we break the layouts here. Okay, we can do these. I really want you to see how to play with this. So we made a mistake of doing what we didn't set out to do, but we are learning more from this mistake, and I really like this. So let's do horizontal layout. And a horizontal layout for these guys, and we want to apply a vertical layout to the entire thing, and we can resize this to really make it tiny. Now this is going to look much like what we set out to do in the slides. Let's run and see how this looks. Okay, this is much better, and we can type stuff here. So we want to see how to write a file. I am going to copy the code I have prepared because I really don't want to waste your time watching me type this. And we are going to learn about this as we go. We need to include Q file dialog for this to work because we need to pop up one to let the user select the file they want to manipulate. Okay, so this is what we have here. And if we have the string, we will go down here and create a file object. We will open the file in write mode. We want to be writing text, and we want to open this in append mode. And if you want, you can really look these things up in the documentation. So select one, hit F1, and let's look at QIO device, F1. And we can go in help mode and look at the modes that we have for QIO device. So we can look at open mode, okay? And if we go to open mode, we can see all these modes here. So you really need to be familiar with how you navigate the documentation to look for what you want. And you can read the explanations for all these modes. For example, the append mode, the device is opened in append mode so that all data is written to the end of the file. It's not going to be written to the start of the file, potentially overriding whatever data was in there. So this is what we mean here. Once we have the file, we're going to set up a text stream object. And again, if you want, you can learn about this object here. So let's open the documentation for it. We can look at more, and you can read all you want about this class. It is a class you can use to write text data to different kinds of input-output devices. Once we have the text stream, we will have the ability to use this operator, which is very familiar and popular in C++. And what we write is going to be the data we get from our text component. And we do that by calling the toPlainText method here. Once we do this, we will have the ability to write data to a file on our system. So let's try this. We will run. This is going to build and run our application in one go. So let's wait for it to come up. We will write some data here. So the sky is blue, my friend. Go away. Can say something like this. And if we want to write, we click the write button and nothing is happening here. Did we do that in the right button? We used the wrong slot. How not? Oh, I was too careful here. So let's take this to the right button. This is just going to be a matter of copying and pasting. And now we are going to run and look at application output or compilation output here. This is going to come up. Now if we hit on write, we will see a dialog pop up, and it's going to pop up wherever our binary is located, and there is right here. Okay, so we need to choose the file name, and we are going to put this in this location. If you want, you can put it somewhere else on your file system. Let's say my file with an underscore and .txt. This is what we want to save this as, but before we save, let's type something here because we want to see the data. So we're going to say hello there. How are you doing? Okay, we can do something like this. And if we write, we're going to have the pop-up dialog, and we want to say my file.txt. And if we hit save, this is going to be saved. You don't see anything printed out or whatever. But if we go to the location where the file was, remember it was in the build directory of our project where the binary is. If we go to projects and go to build directory here, want to make sure you say this because some people are going to miss this. You want to copy this entire thing and open a window of File Explorer, and you are going to go in the address bar here and paste in that path. If you go there, you will find my file here. What is this? If we open it, we're going to see our data, and we have successfully written to a file using our Qt application, and this is really cool. Now let's see how we can read data, and we will be using the read button here, collect slot. This is going to be exactly what we said in the slides, so the code won't need much explaining. But before we talk about the other thing here, please remember to close your file. I had forgotten to stress this. If you forget to close your file, that's really bad programming practice. You don't want to do that. So be a good programmer, be a good C++ citizen, and close your files when you are done working with them. So reading is really not any different. We will set up a file name for the file we want to read from. So we are going to select it with our dialog here. Once we have the file, we will open it for reading text, and we'll set up a stream object which is going to help read from the file. We will read the line, keep looping, reading lines, and each data we read in the line is going to be appended to this string here. And at the end, we will close the file, clear the text edit so that it doesn't have any content, and then we are going to set the plain text to be shown in our text edit component here. Let's run this. It's going to be really easy to follow now that you know how to work with files. We should see our window pop up here. If we want to read, we will need to select a file, and again it's going to open by default in our build directory, and this is conveniently where our file is stored. So we select it, it is what we want to read, and if we read, you see the data is going to show up back here. So if we want, we can really play with this a little more. So let's type some other text. Okay, we can write this to the same file. I think we can select it, .txt, let's say my txt. And if we want to write, I think the operating system is going to say the file already exists, so we are going to overwrite it or replace it. And if we take out the data here and select our file and open, we're going to see all the data here because we appended. Remember, we append to this file, we don't delete the data that was in when we start to write, and that's controlled by the flag that we passed in here, QIO device append, in our write method. Now that we know how to do this, let's see how we can copy. The way copying is going to work, we are going to select the source file. we will copy that file and save it as another file on our system. We want to do this to really show you different things you can do with QFile. Okay, so to make this work, we need to make the select file button work. So when this button is clicked, we will pop up a dialog to let the user choose the file they want to copy, and we will put the path to that file in our source line edit. And when they click on copy, we will copy from the source file and paste into our destination file, and we will get the destination file from our destination line edit. You're going to see how this works in a minute. So when the user hits on copy, we will store the files in here. So the source file, the path to the source file, I should say, is going to be stored in source file name here. The path to the destination file is going to be stored in this variable here. And we will check if neither is empty. If neither is empty, we will set up a file object pointing to the source file, and we will call the copy method on the source file. And this is going to copy the data we have in the source file and paste the data in our destination file. Here we can refactor a little bit, but before we do, let's include a Q message box to get rid of these errors. So let's include Q message box. We can do that. And if we go down, we can refactor src file name, refactor, and rename a symbol. So let's say source file name. How is this working? Can we do that? We're going to select this and say src file name. You can see that this is really cool. This is going to replace every instance of this in this method here. So let's do that for dest file name with a right click, refactor, rename symbol under cursor. We will select the entire thing and say dest file name. This is really cool. This is really. So now we have this. We will call the copy method and paste in our destination file here. And our method is done. Let's try it. We're going to run. And what we want to do is to set the source we want to copy from. We will select that. It will be my file. Okay, and the path is right here. And what we want is to select this path and paste it in destination file. This is one way you can do this. If you want, you can let the user select the destination file and then paste into that. But here we are just going to say my other file, and use an underscore. This is what it looks like. I don't know if you can see it on screen, but this is the other name. And if we do copy, we're going to see copy successful. If we go in our build directory, I think we can go there. We're going to see my other file, and it is going to contain the same content we had in the source file. And this is really cool. Is it the same content? 3 lines? Yes, it is the same content. And this is really all I wanted to share in this lecture, showing you a few things you can do with QFile. Again, I do recommend checking the documentation to see all the possibilities, and please use this to your advantage. Let's stop here in this lecture, and I will see you in the next one. In this lecture, we are going to look at QDir, which is a class that allows us to work with directories in our Qt application. We will set up an application like this, and we will let the user choose a directory of choice. That's going to be our sandbox directory in which we can create things and really see how this works. So the user is going to, for example, point to C and a name of directory, for example, temporary or whatever. Then in that directory, we will create another directory, and we will go to whichever directory they chose. We will set up another path in that directory, and we will hit the create button here. If the directory exists, we will say that the directory already exists. If it doesn't exist, we will create it. And we can check to see if the directory exists using this button here. We will do this kind of functionality. Down here, you see we have a button to check if something is a directory or a file. We're going to be able to check this in our Qt application, and we can list all the folder contents. We're going to see how you can use QDir to do all these kinds of things here. And down below is a list widget, which is going to be listing the folder contents to make this a little bit nicer to work with. So let's see some code. This is how you create a directory. Let the user choose a path, okay? And that path is going to be stored in this line edit. We will grab that path and store that in this string here. If the string is empty, we will get out of here. We will create a QDir object using that path. And from here on, we will be able to use this dir object to do really cool things. For example, we can check if the directory exists or doesn't exist. If it doesn't exist, in this case, we will create it, and we create a directory under another one by using the mkpath method here. And you can find this in the documentation. So we will pass the path that we want to create, and if this is successful, we will fall in here and put out a message box. If we fall down here, we will know that the directory already exists. If you want, you can put an else block to say that creation of the directory failed, but we're not going to go down that path here. And this is really how you can work with QDir. Again, you can check the documentation to see all kinds of crazy things you can do with this. Here we see how we can list the contents of a directory. This is something I want you to see here before we head over to Qt Creator. We will clear our list widget because it might contain some things, so we will delete all the data in there. It's going to be empty. We will set up a dir using our path in the line edit, and down here we will have the dir, and we're going to be calling a method called entry info list. And what this does is going to give you a list of all the things you have in your directory, be it a file, be it a directory, be it the dot thing you see to mean that this is the current directory. You're going to get all those things in this list here. And what this is going to give us is a list of QFileInfo object. And this is a good chance to go in the documentation to see what QFileInfo is. It is a class that is going to give you meta information on a given file on the system. And we're going to be looping through this list of QFileInfos, grabbing each one and printing its absolute path on our list widget here. This is what we are going to do. Now that you know this, let's head over to Qt Creator and set up our application and see how this works out. Okay, here we are in Qt Creator. Let's create a new project. It's going to be a Qt Widgets application. We are going to call this QDir demo and store it somewhere on the system. Hit next. It's going to be a CMake project in our case here. It's going to be based off QWidget. We hit next. We want the MinGW kit, and we don't want Git as the version control system, and we are going to finish here. Let's take a look at our design here. So we have a line edit on top. We have a list widget down below here, and we have a bunch of buttons. So 1, 2, 3, 4, 5 buttons. Let's do this. We are going to open up our UI form, and we want a line edit. We're going to put that down here. We want a list widget. Let's put that here, and we need 5 buttons if I remember correctly. So let's do that. 1, 2 down, 3 down, 4 down, and 5 buttons. The first one is going to say choose dir. The second one is going to say create dir. The third one is going to ask if a directory exists. And the other one is going to say dir or file. And the last one is going to list folder contents. Okay, we have our things here. I don't think we need to name the line edit and the list widget here, but we need to name these buttons because we will have a bunch of slots and we need to know what each of the slots does. So let's do choose dir button. This is not very hard. Create dir button. And we want to do dir exists. We want to do dir or file button, and we want to do folder content button here. And you need to decide how to lay these guys out. I think I am going to put in a vertical spacer to push these buttons up, and I am going to put them in a vertical layout because this is how I want these things laid out. So let's do a vertical layout. And what do we do with the rest? Well, we want to put these guys in a vertical layout and then apply horizontal layout to the entire thing. This is going to give us the design I had in mind. Okay, so we can run to see how this looks, but the goal is not really to do cool user interface here. we want to learn about QFile. So when the user chooses dir, we want to respond, or let's respond to all these buttons. Let's put in the slots and then fill in the code for each of those slots. I think that's going to be much easier to do. So let's do that. Go to slot. Okay. Come back here, go to slot on all these guys. And we want to folder content here, go to slot, and we can respond. When the user chooses dir, we want to pop up a file dialog and let them choose a file path to the directory that we are going to be manipulating, or a dir path or a directory path if I need to be explicit here. Let's do QFile dialog. And we will go down here and put in the code. I don't want to waste your time watching me type this. And we will have the file name stored in our line edit here. So let's clean up and run and see this working before we go any further. So let's do that. I think I am going to go in a folder on my system somewhere. So let's do, so that we can play with that folder. Let's go in my E drive and go in sandbox, and I am going to create test dir. Okay, and this is going to be our directory here. Let's close this, and we want to choose dir, and I will go in that location on my system, E sandbox, and go test dir. I think that's what we did. Test dir. Let's choose this. We can select this folder and start manipulating this folder here. So what we want to do is to create directories under this folder. For example, we can say folder 1, and we want, if we create dir here, we want this folder created in that folder on our system, and we want to be able to manipulate that. Okay, so this is what we are going to do when the user clicks on create dir button. So let's fill in the code. It is really what we have talked about in the slides. When the user clicks create dir button, we will get the path for the folder that we want to create. If the string is empty, we want to get out. We created dir object. If it exists, we're not going to create it. We're going to say it already exists. If it doesn't exist, however, we're going to call the mkPath method on the dir object and create that new directory. And for this to work, we need to include QMessageBox to pop up all those little messages. So let's include QMessageBox. And let's try this out and see if it works as we designed this to do. So let's bring this up. We will navigate to our location. We go in E, test, sandbox, test dir. And this is going to be our folder that we want to manipulate. And we will say folder 1. And if we create dir, we're going to see that directory created. And if we go there, okay, and we see we have a folder 1. How cool is this? Let's say folder 2. To create a bunch of folders, you can create folders in your Qt application, and this is really cool. So we see directory created, and if we go there on our file system, we have folder 2. We can even go in one of those folders. So for example, we can say in folder 2, we want to create folder 2.1. Play with this and really see how far you can go. Folder 2.1 create dir. It's going to be created. And if we go in folder 2, we will have folder 2.1. And this is really cool. This is what I wanted you to be able to do. Now, we are going to check and see if a directory exists, but you really already know how to do this. So this is just going to be a repetition. So let's go down and fill in the code, which is going to grab the path we have in line edit, use that to set up a dir object, and we can use this to check if a directory exists or not. If it exists, we will pop up a message box. If it doesn't exist, we will pop up another message box. Nothing special here. So let's run this, and we will navigate to our location using choose dir, E, sandbox, test dir, and let's go in folder 1, for example, and we want to check and see if this folder exists. If we do, it exists already, but if we change this, for example, to put in some junk data here and see this doesn't exist, you can do things for example, you want to put things in a folder, it is a good idea to check and see if that folder exists. And now you have a code snippet you can use to do that. Okay, we are going to skip this a little bit and work on folder content here. Let's put in the code which is going to list the contents of a given folder. What this is going to do, it is going to get the list of things we have in the folder using the entry info list method. This is going to give us a list, and each of these QFile info objects is going to be information about a given file on the system. And if you want, you can really check this in the documentation. So let's hit F1 on this, open in help mode, and you can read all you want about it, but this really gives you meta information about a file. Let's come back, and what we really want is the absolute file path of each file we get from this folder here, and we want to list them in our list widget. So we are going to be looping around, putting everything we get in our list widget, and we will see everything listed. So what we can do, we can go in our folder of interest here. So let's go in test.dir. And we can create a bunch of files. So new text document, we will put this here, text doc. Okay, we can create a new, or you can go in a folder that already contains things. So let's do a Word document. So Word doc. And we can create another thing. Let's make it a few things. So what else can we do? We can create a zip archive and say zip file. We can do something like this. Then we're going to list the contents in our test.dir. This is what we are after here. Let's come back to our code and clean up a little bit, and we're going to run. The application is here. We're going to choose our test.dir. So let's go to E and sandbox and test.dir. This is the folder. We're going to choose it. Okay, we have the folder path here, and we're going to list the content. And you see, we have the same folder listed. We have the sandbox folder, and we have everything in this folder here. So why do we have the folder itself and the parent folder as the content here? Well, this is because when you list things, the folder knows about itself, and it's going to store that information in the list of things it knows about, and it's also going to store information about its parent. So that's why we have these things here. If you want, you can eliminate them if you want to show the contents to the user. But now we have these things, and it is really cool. So it contains folder 1, folder 2, and we have a bunch of files in here, and we can list them in our list widget here. This is really cool. Now that we can do this, we can go even further and click on each of these things and ask our application, is this thing a folder? Or is this thing a file, like text here or Word doc or zip file? Let's do this. And that's going to be what we do in this slot here. So this is going to be a bit convoluted because we will go through a file info object. So we will set up a file info, which is going to be pointing to the file that is currently selected in the list widget. This is what we do here. And then we are going to ask our file info object, is this thing a directory? We have an isdir method, and you can check this in the documentation if you want. So I am not going to go there. You can do that already. If it's a directory, we're going to print a message. If it's a file, we're going to print a message. If it is neither of these guys, we're going to say it is something else using our message box that we are going to be popping up here. This is really cool. We can do all kinds of crazy things with Qt, and I want you to be aware of this. So let's run this. And to use this, we will need to go to our location. So let's do E sandbox and do test.dir. This is going to be our folder. We select it. It is going to show up here. We want to list the folder content to be able to see everything here. Now we can click on our zip file, for example, and say, is it a directory or a file? If we click, this is a file. Okay, our application is working here. Let's click on folder 2 and see what it is. Dir or file, this is a directory. Let's click on ourselves and see what we are. We are a dir. Let's click, oh, we just used our parent here, but we can click on ourselves, the current directory we are in, and check what we are. This is a directory. If we go to test doc file.txt, dir or file, this is a file, and you see we can really do all these things. This is really all we set out to do in this lecture, and I hope you found it interesting. We are going to stop here in this one, and I will see you next time. In this lecture, we are going to look at what Qt has to offer in terms of network programming. And before we do that, let's look at the network programming stack a little bit. And if you have learned a bit about network programming, you know a figure like this. And this is going to give us different levels things go through as your packets or as data goes from one computer to another computer through the internet. And we have a bunch of layers here. So this is probably the application layer. This is the TCP layer. This is the IP layer. And this is the physical layer, if I remember these things correctly. And your applications, for example, a Qt application is probably going to be living at the application level using one or more of these protocols here. And as you send data, it's going to go from the top all the way to the bottom to the physical layer, which is down here, where it's going to be turned into ones and zeros. And then the data is going to go from your device, which is your computer, to the nearest router or whatever device is responsible for transferring data throughout the internet. So in the middle here, you can think that we have something like a cloud, and that's the worst cloud I've ever seen, but let's work with this. So your data is going to go from the top all the way to the bottom. It's going to hit the physical layer, and it's going to be sent down the wire here, and it's going to go throughout the internet. The other end is going to pick up the data, and the data is going to go through a reverse process. So you're going to be starting from the physical layer, and it's going to go all the way to the top and hit the intended recipient application at a given port at the given IP address here. And this is not meant to be a network programming primer. It is really giving you an overview of what happens here. And the goal is to ultimately show you the tools that Qt provides to do network programming. And we're going to do that here. So here we have a bunch of classes that Qt provides to work with different networking technologies. For example, we have a bunch of classes to work with TCP, and you can see QTCP socket and QTCP server. We have classes to work with UDP, DNS, SSL, HTTP, and we will look at a few of these. I think we will have a chance to work with HTTP through Q Network Access Manager and Q Network Reply. And what we will do is downloading data from the internet and be able to use that data in our own Qt applications. And I do recommend reading the documentation on Qt network programming if you want to go down that path. And you can do that by coming to Qt Creator here. So let's come here and go to help. You see I have this documentation here open. If you want to hit this, just type network in the search bar here, making sure that you are working in index mode, which is what we have on top here. And you're going to see network programming with Qt. If you open that up, you're going to have a piece of documentation you can read, and I really do recommend reading this if you plan to do some network programming with Qt. I think they even provide a list of Qt networking classes. So let's click on this link here, classes for Qt network programming. You can see the link here. It may not be visible on screen, but let me highlight this so that it is super clear. If we click on this, we're going to see a bunch of classes here. And you don't really have to know about all of them. Just pick the common ones, things that work with HTTP, maybe TCP and UDP. And all the other things are going to be building on top of either TCP or UDP to do network programming. For example, SSL is just going to add encryption to the pipe that is already provided by TCP or UDP. And you really need to read more on network programming. Again, my job here is to show you some of the tools that Qt provides to do network programming. Okay, let's look at some of the common classes that Qt provides. And the first pair of classes we will look at is QTCP socket and QTCP server. And these classes can be used to set up a lasting connection between the client and the server. And you can think of it as if there is a pipe connecting these two guys, and you can send data from the source Okay, the data is going to go through the pipe and it's going to come out of the other end and hit the destination. The destination can respond through the same pipe. So we send the data and the data is going to go back to the source here. This is how you can think about QTCP socket. And you see, we also have a server. So a client is going to be talking to the server, but we can even have multiple clients talking to the same server. So this is the idea with TCP. We have a bunch of connections from client to servers, and we may have multiple clients connecting to the server. And this is something the internet is probably built on. For example, if you have a web server, it is going to be powered by some kind of TCP server class in whatever programming technology you are using, and clients are going to be powered by some TCP socket technology that is going to set up a client to talk to the server. I can't really go into too much details here. This is worthy of a full course, and if I have time, I will do a network programming course either with Qt or plain C++. But we can't really do that here. I just want you to show you the tools that Qt provides to do network programming. Another technology that is usually used is UDP, and this is not going to set up a lasting connection. One end is just going to send the data and hope that the data hits the destination. And this is going to bring up a main difference between TCP and UDP. UDP doesn't have enough error handling built in. So you send the data and hope that the data is going to get there, but it is possible that the data is not going to get there. And this makes sense in applications like network streaming, where you don't really care about one packet. All you care about is having an uninterrupted consumption of the packets that you send on the other end. So for example, if you are watching a video over YouTube or any other video sharing site, you don't care about losing a single frame, which is going to give you a frame you see on the screen. If you lose one frame, it's just going to be replaced by the next one, and the user isn't probably going to notice. But if you are using TCP, for example, to do chat, it's going to be very bad if you send a message and the recipient doesn't receive it. So some applications are more suitable to do with TCP, some applications are more suitable to do with UDP, and the choice is going to be yours as the developer. So this is really all I had to share in this lecture, showing you a bunch of classes that Qt provides to do network programming. We are going to stop here in this lecture, and I will see you in the next one. In this lecture, we are looking at the Q Network Access Manager class, and this is a helper class we can use to download stuff from the internet using HTTP. HTTP is a rather complex protocol, and if you set things up on your own, it's going to be very involved and it's going to take you a lot of time. So Q Network Access Manager is a class which is meant to ease that load. So it's going to make it easier to get stuff from the internet and use that data to do things in your Qt application. We are going to have a chance to read about this in the Qt documentation. And here we just show you how to use it. You set up a bunch of pointers, and you see it is not the only networking class we are using here. We are also using QNetworkReply to set up an object we are going to be using to manage replies. So this class is conveniently named. We will send a request and we will set up an object which is going to allow us to know when we have some data from the other end so that we can act on that data. We will also use this QByteArray object to store the data that we read from the internet. And if you know a bit about network programming, you know that when you send a request over the internet, you don't get the whole data in a single batch. Things are going to be coming in piece by piece, and we will use this buffer to read every piece that comes. And when we have all the data stored in this buffer, we will read the entire data set and use it to do things in our Qt application here. So that's why we set up the constructor of our widget like this. We will initialize our objects, we create things on the heap, and we remember to have a memory management strategy. So you see we are setting up this data buffer and it doesn't have any parent or whatever. So we need to remember to release this memory here. If we don't, we will be leaking it. This is something you should always keep in your mind. When we go down, we set up a request, and you see a request is really going to be a wrapper around the URL you're going to be looking for from the internet, and we will send the request. So we will say net manager get and pass in our request. And this is just the way Qt provides to do these things. And when we send the request, the get method from our network access manager is going to give us a reply object, which we will store in our net reply here. So we are going to do a bunch of connections to know when we have data, and the reply object is going to have a bunch of signals we can work with. Two are really more important. We have a ready read signal, which is going to be fired every time we have a small piece of data from the internet, and we can use this to grab that little piece of data and store that in our buffer. So this is what we are doing here. You can think that we want to get the entire piece of data, but what we really get from the other end is little pieces by piece. And each piece we get is going to be stored in the buffer. We're going to keep going and keep going until the entire data set is done. Then we will know that we have something worth reading in our Qt application. So every time we have a piece of data, ready read is going to be fired. We're going to read that in our buffer. And when the entire data set is there, when there is no more data to read from the other end, we are going to fire the finish signal, and we will respond to it in our Qt application here. Let's go down and look at these slots that we are going to set up to connect to those signals. Whenever there is something to read, we will append that data to our buffer, and we read the little piece we get by calling the read all method from our reply object. And we say that some data is available. We're going to see this in a minute when we run this in Qt Creator. And when data read is finished, we will try to read everything we have in our buffer. So if there was some error, we will say that we didn't manage to get the data. But if we didn't have any error, we are going to build a QString object from our buffer and set that as the text to our text edit here. And it is going to show up in our user interface. And I realize I am throwing a bunch of classes to you right now, but this is what you're going to be meeting in real life. Again, I recommend if you find a class that you don't know the purpose for, use the documentation, look at a few examples, and you are probably going to make sense of what is going on behind the scenes. So now that you know this, we're going to head over to Qt Creator and do this. Okay, here we are in Qt Creator, and what we are going to do is look at Q Network Access Manager, and I think we have this somewhere in the list here. Q Network Cache, Q Network Access Manager. We have that right here, so we can read about it. If you want, you can type Q Network Access Manager in the search bar here. It is going to pop up, but I am going to open that here. And if I read more, this is going to give me enough information to start using this class here. So the Q Network Access API is constructed around Q Network Access Manager. So this is a very important class you need to know about if you care about network programming, and you're going to be reading about that. And you see that they start introducing other classes that are going to be working together with the Q Network Access Manager to let you do things. And now you must be recognizing the code here, because this is what I just showed you in the slides. And you can really read and see how to use this guy here. I do recommend you take a moment to do that. Okay, so now we come to the Edit tab here, and we are going to create our project. It's going to be a widgets application as usual. We are going to give it a name and save it somewhere on our drive here. And it's going to be a CMake project. It's going to be based off QWidget as usual. We don't want any translation, and it's going to be a MinGW based project. Let's take out get and finish. The project is going to be generated, and if we run it, we should see a widget pop up here. Okay, so this is the widget. Now we want to do some network programming, and we need to make sure we include the network module, because that is what is prescribed by the documentation here. And we are using CMake, so we need to take care of these two things to make this work. We need to go to our find package command and make sure we are finding the network module, and we need to target link libraries and make sure we are linking to the network libraries of Qt to make this work. When you are using QMake, all you need to do is to add network to your libraries, and everything is going to work here. So let's go back and do that. We will go to our cmake list.txt file and make sure we find packages, including network here. We are already finding widgets because it is a widgets application. But for network, we need to explicitly state that we want the network module of the Qt framework. So let's do that. Network here and network. And we need to go to the target link libraries command that we have down here and say that we also want to link to the network libraries of Qt. For that, we need to copy the entire thing here, copy, and go after widgets. You see where the cursor is blinking, hit enter, go to the next line, paste in the thing, and say that we want to link to network here. This is something you can do. Okay, let's make sure we can run cmake to make sure the libraries are available for use. And cmake is going to generate the project. If you look at general messages here, you see that the build files have been generated. Let's try to build again and make sure the build is good. So compilation output here, the build is good, and we can still run this. And let's try to include the QNetwork Access Manager in our header to make sure we have access to these things really. So we can do include QNetwork Access Manager. And if we build again, that's going to build just fine. Okay, so the first thing we're going to do is to put in a bunch of objects we are going to use. We will need the QNetwork Access Manager. We create an object of that here, but we also need the QNetwork reply that we are going to be using to manage replies to our request. We also set up a buffer, which is a qbyte array object here. And this buffer is going to be storing data as we read it back from the internet. One thing you should know is that the data is not going to come in one batch. For example, if we want to get this entire piece of data from the internet and we send a request using QNetwork Access Manager, we are going to be getting data in little pieces. So data is going to come piece by piece, and each piece we get is going to be read into our buffer here. So we will be increasingly reading data until the entire thing is read into our buffer object. That's why we have this little buffer here. So let's go to the constructor and initialize these guys. We are going to say initialization here, and we want to initialize the network manager object, the reply, and our data buffer. And notice that we are allocating for this buffer on the heap, and this should be a red flag that you should have a memory management strategy. In this case, we are going to do things row and delete this explicitly in the destructor. So we're going to say delete m data buffer when we are done with using it. And we do this in the destructor of our widget. And now that we have these guys, we can send out the request. For that, we will need to set up a request object. And this request is going to be encapsulating the URL we want to look for. And if you want, again, you can read the documentation for these guys. All you have to do is hit F1, and you're going to be reading about all these guys here. I really do recommend doing that. But for now, this is going to be the thing we use to send the request out. And you see, we send the request by saying network manager and calling the get method. The get method is going to give us a reply, and that reply is going to be stored back in our net reply object. And this reply is what we're going to be using to read the data as it comes out from the internet here. So we need to do a bunch of connections. The first one, let's look at the documentation for the net reply class. So what do? Let's find that here and hit F1, QNet reply, and see the signals that it has. If we go down and look at signals, we have a ready read signal. I think we have that. We should have a ready read signal, encrypted, redirected, and whatever. That signal must be coming from what we are inheriting, and we are inheriting QIO device. And if we go to signals, we have a ready read signal. So this is what we're going to be using to get data as it comes out of our network manager object. We also need to handle the signal when the data is finished, and I think we have that in our QNetwork Access Manager class, and it is this signal here. And if you want, you can click on it. This signal is emitted when the reply has finished processing. So we have finished reading the data, and this is what we are going to do. Okay, so let's go back to our class and set up these connections. We set up the connections and use the slots we don't have defined yet. And you see we don't have QNetwork reply included. We can do that right here. So include QNetwork reply. And this should be happy now. And we need to put in these slots here. Okay, so let's go to the header and do that. We will put in a public section containing our slots, and we want to implement them and put the code in the CPP file. We can do that pretty quick by refactoring and adding definition in the CPP file. And I realize I am throwing a bunch of classes to you that you probably didn't even know about, for example, QByteArray here. But this is the point. You have to learn as you go, and that's the reason you have the documentation. You can really read the documentation and really put all these little pieces together. So let's go down and put the code in our slots. Again, data ready read is going to respond whenever we have a little piece of data to read, and we will read that piece of data into our buffer. So the buffer is going to be growing. Again, this may be the entire piece of data we want to read on top here, and we have our buffer object down here. And as the little pieces keep coming from the internet, we're going to be reading them and storing them in the buffer. So the buffer is going to be continuously growing. When the entire data set is read, or when we are finished reading, we are going to fall in this slot because of the connection we have here, and we will be able to read the entire thing we have in the buffer. Again, I really hope this makes sense. Okay, so whenever we have some data to read, we will read and put the data in the buffer, and this is how we do it. We call the append method, and we read everything we have from the reply object and put that into our buffer object here. Now, when we are finished reading, all the data should be stored in our buffer object, and what we are going to do is read the data and show that in a text edit that we will have on our user interface in a minute. Notice that to be able to print things in our buffer, we can use the QString constructor that takes a buffer object. And if you want to see this constructor, all you have to do is hit F1 while having this selected. So let's do that. We will open the documentation for QString. And if we look at the constructors that we have a constructor taking a byte array, and this is going to be building a string from this byte array here. So you should use the documentation again. Let's go to the UI form and put in a text edit component. Text edit, yes, it is a text edit. We can select and apply a vertical layout and resize this. Or even to resize this, you can use this little button here, which is going to adjust the size of this to make it as small as it can be, to not be too big. So we have this, and if we go back to our widget CPP file, we should get rid of this error here. And we are going to use the data we have in the buffer, construct a QString, and set that string to be the text shown in our text edit here. And everything we need is in place now. Again, take a moment to understand what is going on here. And because we are using signals and slots, one point I wanted to make here is that things are going to be happening asynchronously. So we are going to be sending the request using this statement here, but we're not going to be getting an answer immediately. An answer may even come 10 seconds or even 12 seconds later. And when the answer happens to come, the signal is going to be fired, and whichever slot is responsible for responding is going to respond down here. So things are not going to be happening synchronously, they are going to be happening asynchronously. There are ways you can do things synchronously, but I am not going to go down that path here. For now, we just want to build to see if we don't have any boo-boos in here. And hopefully we don't. Looks like we don't. The build is good. And now, fingers crossed, we are going to be running this application. And I don't know why we have this error here. So let's go back to the widget CPP file again. And hopefully the error is going to go away. That was Qt Creator having a hard time understanding what is going on. So what we want to do here is run the application, but notice that we are sending this request when we hit the constructor of QWidgets. So the moment the application runs, it will start sending this request, and if the data is available, we will read the data, and we will be getting HTML for the website that we want to get here. So fingers crossed. Make sure you open application output here to be able to see this. We can kill this and open application output here, and we are going to run. This is going to come up and it's going to send the request. You see that we are activating our data ready to read signal as we get data. And you see we have things we have read from the internet, from the GitHub website, if I remember correctly. Is that the thing we wanted to get? Yes, github.com. Okay, so how do we prove that we are really getting the source code for the home page for GitHub at this moment here? Well, if we open our thing and go all the way to the bottom, this is what I like to do. And look at what we have here. The last thing is body HTML. But if we go up, we're going to see this thing here. And the last things are going to be 11.060Z. So let's see if I open my browser in private mode, because if I go in normal mode, my browser is going to automatically log me in, and I may see things that are different from what I get from the Qt project that we are doing here. So I am going to visit github.com, or even better, we can copy that from our code here to make sure we don't have any typos or whatever, and we are going to go in our browser and put in this. And if we visit the site, it is going to open up. Okay, we have GitHub here, but what we want to do is look at the source code. So what we can do, the HTML that is generating this page here, we can right click in an empty slot and view page source here. This is what we are going to do. And this is the code we are getting. You see that we have these empty spaces on top, but if we go all the way to the bottom, we want to see the body HTML, and you see we have the same numbers here. So 0.11.060Z, that's what we have. If we go back in our application, we have the same thing here. So this should be proof that we are able to read the HTML for the GitHub website from our Qt application using the Qt Network Access Manager API. And again, I do recommend reading the documentation if you are interested in more about networking programming with Qt. For now, I am going to stop here in this video, and I will see you in the next one. In this lecture, we are going to build a JSON REST API client using the network programming features of the Qt framework. And we will do something like this. This is an application that is going to fetch posts from the internet. So you can think of these as a bunch of blog posts, for example. So we have the text here to say what this is, and we have a button we will click to initiate the request that is going to be sent to a given URL. And from that URL, we will get a reply, and that reply is going to be a JSON document. If you don't know what JSON is, you should check that out on the internet. And this is the URL we're going to be using here. And before we even do anything, let's go to the browser and show you what we get from this URL. Let's increase the size of this so that it is really visible here. So you see the endpoint here. And what we get is an array of JSON objects. And again, if you don't know what JSON is, I do recommend reading on that on the internet. So this is our array here. And what we want is to get the data and print these titles. And we're going to be putting them in a list widget, which is going to list all of these guys here. You can see it goes from 0 all the way to 99, if I remember correctly. Yes, it goes all the way to 99. We're going to be reading all these things and printing these titles from our Qt application. The application is strikingly similar to what we had in the last lecture. So it's going to have a bunch of objects. We have a network access manager object, we have a reply object, we have the buffer through which we're going to be reading the data. But we are going to be initiating the request when the user clicks on the button. So this is a major change here. You should be aware of this, but what we do is really the same. We have the endpoint. You see, it is the same thing we used in the browser. In a minute, we have our request. We're going to send it out and get a reply object. And we are going to connect a bunch of slots to the signals coming from the reply object. And we will get our data in our data read finished slot. So exactly the same thing we did in the last lecture, but the similarities end there. Once we get the data in our buffer, we will turn the data into a JSON document, and that's what we are doing here. And again, you can read on the QJSON document to see what it does and combine that with your knowledge of JSON data format. That's really what I recommend to understand what is going on here. What I am just showing you is how to use this to read data and be able to display this in a list widget like we are about to do here. So we know that we are going to get an array from that endpoint, and we are going to be interpreting the data we get as a JSON array. That's why down here we are turning our document into an array. So we have an array object. Once we have the array object in Qt, we will be able to loop through elements inside. And at each iteration, we will create a JSON object from the thing we have at a given iteration in our array here. We will turn this into a map because a map allows us to fetch things based on the IDs that we have in the array we get from the internet. Let's go back to the browser and really show you this. So using a Q-variant map, we will be able to read things based on the labels that we have here. For example, title, body, user ID, and ID here. We can use these identifiers, if I can call them like that, to read these guys from a map. And that's why we are using Q-variant map here, to be able to read things like we are doing here. And once we have the data, we will show that into a list widget. So we are going to add items here. We will show the iteration we are at, and we will just print the title, and we will be able to see these things in our Qt application here. So now that you know this, we're going to go to Qt Creator and play with us. Okay, here we are in a Qt Creator. Let's create our project here. So file, new project. We are going to give it a name. It's going to be named the JSON client, and we are going to hit next here. It's a CMake project. We want QWidget here, and it's going to be based on WinGW. You can use whatever kit you want, and we don't want Git, and let's finish here. This is going to give us the project. And remember, we need to make it network programming ready, and the way we do that, we steal things from the previous projects. And I think we can even copy this entire thing, find packages, and we're going to be replacing what we have in our new project here. So let's take this out and put in the new thing with the network module included. We can go and even grab the find or target link libraries thing and replace that, because this is going to be linking to the network module of Qt. So let's steal that and avoid some typos. I like to do this because I don't trust myself when it comes to typing long strings of text. And now we can rebuild. Let's close everything here, save all, and we are going to run CMake again. And it seems we have a problem. What problem do we have here? Oh, this is JSON. So this is a copy paste error. Sorry for that. I am going to change this. Okay, and rerun CMake. Let's save this and rerun CMake. And let's clean and rerun CMake and see if this works. So what is going on here? JSON client private bold. So let's see. Oh, we have a space that we need to put here, I think. And let's rerun CMake again. And now it should be happy, you see. Let's see if we can build, compile output. We can build. Sorry for these errors here, but now we are fine. So what we are going to do is go to the UI form and set up our user interface here pretty quick. We're going to need a label. Let's grab a label, and it is going to go on the left. We're going to need a button. We're going to put that to the right, and we need a list widget. So let's use that here. And we're going to call this post fetcher. And what this is going to be, let's make this a bit nice by applying a font here. So let's go and change the font, maybe make it a 30. Let's see what that looks like. 28, and post fetcher, that's too big. I think that's too big. So let's turn this to 26, maybe 24, apply. So I think this is going to do post fetcher. And let's name this button, and we're going to say fetch. And as we are going to name it fetch button. Okay, and we are going to apply a horizontal layout to these guys and apply a vertical layout to the entire thing. I think this is going to do. And we want it to respond when somebody clicks on the fetch button. So let's do that. Call to slot will respond when it's clicked. And our user interface should be ready. And another thing you can do here is to click on this button to give your thing the smallest size possible. Let's run. We can look at compile output here to see what is going on, but our thing is already done. And we are going to be showing the posts that we read in our list widget here. So let's do that. We are going to be stealing all of our networking code from the last lecture because we are exactly doing the same things. So let's do this. We are going to grab the components we have here and go to our header and include QNetwork Access Manager, QNetwork Access Manager, and we want to put these components in here. But we want to use an initializer list to initialize these guys here. So byte array, network reply, and network access manager here. So let's do that. We will go in our CPP file and let's make sure we remember the names. Net manager, we will start by net manager, and the way you use your initializer lists, you put them here. So let's do, we are going to say net manager, and it's going to be new Q network access manager and pass in the parent. The next thing is going to be the net reply. So let's do that. So net reply, and we will initialize this to null PTR because we will pass a value when we send the request, if you remember correctly. And we need to do our byte array. So let's do M data buffer. I think that's the name, and we need a comma in front here. So let's do that, and let's put another comma and say M data buffer. We don't need this comma here. Sorry for my mess. And this is going to be new Q byte array. Okay, so remember, we are setting this buffer on the heap and we are not giving it a parent, so we need to release the memory in the destructor. So we need to do delete M data buffer. We are going to be initializing the request in the slot here when the button is clicked. So let's put in the code to avoid some typing here. We will set up the URL, set up the request, and set the URL to the request. And we are going to use our manager to get the request here. And this is going to give us a network reply object we can use to manage things. And we will connect slots to signals from this reply object here, but we need to do a bunch of includes. So QNetwork reply, I think it's going to do the job. Let's do that and see what happens. QNetwork reply, we need to include that right here. QNetwork reply, QNetwork reply. And once we do that, this should be happy. It is. And we need to put in these slots that are going to respond here. So we are going to hop over in the header and put those in. We are going to put these together with our slot for the button, and we want to generate implementations for these. Let's do that. Right click and put implementation in the CPP file. Let's go to read finished, refactor, and it's not really doing what we want. Qt Creator sometimes is not very helpful. We can do this ourselves. Let's copy this and put this in the implementation file, and we're going to call that data read finished. Copy and paste here, and this is going to give us our slot. When the data is available, we are going to read it all, exactly what we did in the last lecture. And let's make sure this is going to be exactly as we named things. So net reply, we will read all the data. And when the reading is finished, we will read the data. So we do exactly what we did in the last lecture. So we check and see if we didn't have any error. If we have the error, we're going to fall in here and print that out. But when we don't have an error, we're going to read the data as a JSON document. And you see we need to include all these classes here. Let's include them one by one: JSON document, JSON array, and JSON object. Let's do that together. And QJSON object. And let's go down and see if Qt Creator is happy here. Looks like it is happy now. And this is exactly what we did in the slides. We are going to read the data from the buffer and use that to create a JSON document like we do here. Once we have the document, we will create an array because we know we are reading array data from the web server. And that's what we see here. This is a JSON array we are getting. And you can recognize this if you know a bit about JSON. Once we have the array, we're going to be looping through the array, reading every piece of data, turning that into an object. We will turn the object into a variant map. Again, maps allow us to read things in this format here by passing in the labels that we had in our JSON array. And we're going to be reading this title here and printing it out in our list widget. Now we can build and see if the application actually runs. Let's compile. Looks like the build is good. We can run. And we have our post fetcher here. So fingers crossed, we're going to resize it a little bit and hit the fetch button. And look at what we have here. We have every title that we had in that blog post, and this is really cool. I can't tell you how excited I was when I was able to do that. Let's look at the first thing, for example, or even to be a bit random, let's look at 57. Sed ab est est. That's what we have as a title. Sed ab est est. And if we go to 57, if I can find it. 57, where is it? It is right here, the ID, okay? And it is saying sed ab est est. So you see that we can really read this from our Qt application, and this is really cool. And it is what we set out to do in this lecture. In this chapter, we were exploring the facilities that the Qt framework offers to do network programming, and we saw that Qt has a bunch of classes you can use. For example, you can do TCP, UDP, DNS, SSL, and HTTP. And we had a chance to see an example of using Q Network Access Manager. Q Network Access Manager is a built-in class to allow you to do HTTP requests. And we saw that we could couple that with Q Network Reply to do a bunch of things. We saw that we could download an HTTP page using Q Network Access Manager, and we saw that we could even get some JSON data and manipulate it in our Qt applications using some JSON facilities we have built in the Qt framework. I hope you found this chapter interesting, and I will see you next time.